What is big data? Big data refers to large, complex, organized, and unstructured data collections that are generated and sent in real time from a variety of sources. The three V's of the big data are made up of these characteristics. Volume. The enormous amounts of data being stored are referred to as volume. Velocity. Velocity refers to how quickly data streams must be processed and analyzed. Variety. Data is acquired from a variety of sources and forms, including numbers, text, videos, photos, and audio. When big data and high performance analytics are combined, you can do business related tasks such as, in near real time, determining the root causes of failures, difficulties, and flaws. Anomalies are detected faster and more correctly than the naked eye. Improving patient outcomes by transforming medical picture data into insights as quickly as possible. So let's see, what are the big data use cases? One of them is product development. Big data is used by companies like Netflix and Procter and Gamble to predict client demand. They create predictive models for new products. Predictive maintenance. Organizations can perform maintenance more cost effectively and maximize components and equipment uptime by identifying these indicators of possible faults before they occur. Customer experience. To optimize the contact experience and maximize the value offered, big data allows you to collect data from social media, online visits, call records, and other sources. So now let's see how big data works. Big data provides new insights that lead to new business prospects and models. The three key steps that are required to get started are integrate. During the integration process, you must bring in the data, process it, and ensure that it is prepared and available in a way that your business analysts can use. Manage. Storage is required for big data. And the third one is analyze. When you analyze and act on your data, your big data investments pays dividends. So now let's see the salary and job prospects in big data. Big data engineers earn an average of 18.4 lakhs, mostly ranging from 10 lakhs to 33.6 lakhs. The average salary for a data engineer is $116,000 per year in the United States and $5,000 as cash bonus per year. Hello everyone and welcome to today's session on Big Data Hadoop course by Intellipaat. In today's fast-paced world, we hear a term big data. Nowadays, various companies collect data posted online. This unstructured data found on websites like Facebook, Instagram, email, etc. comprises big data. Big data demands a cost-effective, innovative solution to store and analyze this data. Hadoop is the answer to all big data requirements. Hadoop is an open source software project that offers a new way to store and process big data. To sustain in the cutthroat competition, Hadoop certifications helps you to sustain in the market. Big companies like TCS, Wipro, Cognizant and more are employing professionals who have earned certifications. Here's where Intellipaat comes in. Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council, IIT Guwahati. This course will help you to upskill and land your dream job. Now let's check the agenda for the session. So first we'll be talking about what is big data. After that we'll be covering importance of big data and then we'll be doing how Hadoop works. After that we'll be covering HDFS concepts and then what is Pig and what is Hive. Then we'll be covering Hive architecture and after that we'll be talking about Hadoop versus Spark. And at the last we'll be talking about Hadoop interview questions and answers which will help you to ace your interviews. So that's all with the agenda. Now let's start the session. But before we begin with the session, please subscribe to our channel and hit the bell icon for more updates from Intellipaat.
What is really big data means for us and what is Hadoop and relation between these two actually. So it's not something data is exists now. So it is there from beginning, almost 20-30 years onwards, the data is there. But all of a sudden, people and a lot of organizations started discussing, a lot of discussions are going on the big data. So what is the meaning of big data means for us? So before I take you in depth about the big data, first of all, you have to understand a little bit about the data. So what is data? So probably you can think on that. What is data all about? Data is nothing but collection of some information, right? Anything. If you're keeping some information together, then you can call that one as a data, right? Data or data set actually. So, when you are going to see the data, how you are going to see the data or data sets? Basically, from different data sources, you're going to see the data set. Just forget about the big data definition. So I'm just going through about the data set actually. So now data sets will be generated or data will be created out of the data sources basically. So you can just take the simple example, this Zoom. Zoom is one of the data source where we are seeing a lot of data will be generated behind the screens. So how we are discussing the audio, the video, the statistics, and the network, and who joined at what time, who left what time, all these things will be captured behind the screens actually. So that is all about the data set actually. Data sources are the one who is going to generate the data. Without data source, there is no data actually in this world. A very clear statement. Without data sources, there is no data. Everything, your cell phone is a data source, your personal computer is a data source, your YouTube is a data source, social data is a data source, right? Social networks, probably Facebook or Twitter or anything, right? And also a transport data, right? YouTube data, satellite data, right? And also stock exchange data. All these are going to be the data sources actually, right? So data sources are the one who is going to generate the data actually. So Ajay says, what is data set example, right? So for example, right? So you went to the market and to vegetable market or probably to grocery, and you got some items, right? And he's going to print a bill for you with a list of items and their amount, right? That is a data indirectly, right? So the data you are going to maintain in a simple, in a computer world, in terms of data set actually. If you are maintaining, earlier we used to maintain the data in the documents, nowadays we are maintaining the data using computers as a, in terms of data sets actually. Collection of some data, if you are maintaining in your computers, that is all about your data sets actually. Legacy systems, right? Or traditional techniques. So using these things, we can really maintain the data actually. So these notes will be shared as a class notes, friends. You don't have to write down, or you don't have to be busy taking the notes throughout our discussion. All you have to concentrate on my screen, because everything will be shared with you. Okay, whatever I am showing on my screen, except paints, where we are going to use here and there paints also, except that we are going to share everything with you actually. So now let's go ahead and see definitely legacy systems, right? So one of the widely used in terms of data, it's mainframes, .NET, right? Or Java, it's one of the widely used, RDB, MS DBs, right? Or any ETL tools, right? etc. So using this, you can maintain the data actually. So these are really well matured systems, friends, from beginning, and you don't have to worry about to maintain the data. But how far they can maintain the data? Maximum terabytes of data they can maintain, because when they designed the systems, they thought they are going to see maximum terabytes of data. That's how these tools were designed, and there is no question at all. When you are seeing the terabytes of data from your data sources, these systems are excellent systems actually. But now definitely you see, are you seeing only the maximum terabytes of data? No, we are going to see petabytes of data, which means 1024 terabytes equal to 1 petabytes, exabytes of data, zettabytes of data, yottabytes of data, etc. You started seeing this much of data from our data sources. But when you see this much of data from your data sources, but when you are trying to manage this much of data using these existing systems or traditional techniques, where they are not able to tolerate your data, then they can start calling the data set is a big data. So what is that? Big data, it is a data set only, right? But this data set we are not able to manage using the existing techniques actually, because it's a huge volume of data. It is beyond their storage capacity, beyond their processing capacity. So that is the reason they are not able to really tolerate the data actually. Clear? Big data, probably you might have thought you are going to learn as a language, as a technology, as something else, but you are not going to do anything with that. Simply big data is nothing but it's a data set only. It's a collection of some meaningful information, but using your existing systems, you are not able to really manage it actually. Clear? So that is all about the big data. When your existing systems are overloaded, simply you can call your data as a big data. That is as simple as that actually. So using your existing systems, we are not able to tolerate your data. Definitely we have to think the alternatives. We have to introduce the alternative for the big data actually. So now how we are going to do it? Let's go ahead and see one by one actually. So as you can understand here, right, there are many systems were born to handle your big data. So it's not a single a system or framework that was born to handle your big data. There were many systems were born in this market to really just address your big data related issues. So one of them is going to be the Hadoop, right? And also you see Spark, and also you can see HBase, MongoDB, right? etc. These are the frameworks which were born to really understand, to address your big data related issues actually. So what are the big data related issues? Basically storage one, big data issues. There are two issues basically, right? Storage related issue, processing related issue. So these are the two issues that you have to understand, that you have to address whatever you're going to introduce actually. So what is big data? I mean, what is Hadoop basically? Hadoop is only, it was born to address your big data related issues. Hadoop is going to address your storage related issues out of your big data. Hadoop is going to address the processing related issues out of your big data. Hadoop can manage both the things. So now let's go ahead and see how we are going to really, right, process, how we are going to store the data, how we are going to process the data using Hadoop. What is the specialty with the Hadoop than you're comparing your legacy systems actually, right? Before that, let me introduce about the big data definition from IBM side using 5Vs actually. So very, very important thing. I don't want to miss that one because most of the interviewer is going to ask those questions. So what is big data definition using 5Vs actually? Let me pull that documentation. So I'm going to share this one with you. So very simple, 5Vs means volume, velocity, variety, veracity, and value. That's how nicely they are calling as a 5Vs and 4Vs and 3Vs and all. So you don't have to worry. So all you have to understand about what is each V means, then how we are going to leverage this each V definition to define your big data. We are going to see one by one actually. So let's see. So what is volume of data? Volume of data is nothing but simply the amount of data that you add from your data source to warehouse actually. So if you take any example, right, you are going to add some amount of data actually. So you're going to add some amount of data, and you're going to see some amount of data, and you're going to see that will be retained somewhere else actually. You're going to, you see some amount of data from your data source, probably you can think of Amazon, and you are retaining somewhere else in the warehouse actually. So now you are trying to really just dump the data from here to here. So whatever the volume, whatever the amount it is, but you are going to retain the data. So let's understand volume means. So volume is nothing but velocity, right? I mean, volume is nothing but amount of data that you are adding from your data source to warehouse. From this data source into your warehouse. Warehouse is nothing but it's a place. It's a common place where you're going to retain the data, that is called warehouse actually. Amount of data that you are adding from your data source to warehouse is called nothing but volume, right? That is the volume definition. The amount of data that you added from your data source to warehouse. It can be anything in size. It can be bytes, it can be MBs, it can be GBs, it can be petabytes also. So that is called volume. Velocity is nothing but at what frequency you are trying to add the data from your data source to warehouse. So for example, you are seeing around 4 terabytes of data here. This 4 terabytes of data is being added at what frequency? How long your data source has taken to add this 4 terabytes of data? Is it taken a month, a week, and a year, in a month? So that's what your velocity means. At what frequency you're trying to add the data. It can be a day, it can be a month, it can be a year, it can be 10 years actually. So that is all about the frequency of adding your data actually. That is velocity. You know volume, you know velocity. The third thing is variety of data, right? So order does not matter, friends. All you have to understand each V means. So variety means, as the name says, variety, different forms of the data actually. So in this data world, right, if you take any data, that has to be categorized into one of these three ways: structured data, unstructured data, and semi-structured data. As the name says, structured, your data is being well organized in your data set. That's how we will be calling as a structured one. Unstructured, there is no structure at all, right? Your paint is unstructured data, your image is unstructured data, your audio file, video file, everything is unstructured. There is no structure, right? Binary format completely. Right, that is unstructured. We know very well about the structured and unstructured. So what about this semi-structured? So half of the data, as the name says semi, half of the data, your data has been just structured and rest of the data is not been structured actually. So you have to really process that unstructured data to make it as a structured one actually, right? To make it as a structured one. That is about the semi-structured actually. Your XMLs, JSONs, where we are going to use in our application. So where data exchange can be happen more frequently using your XMLs. And we are going to see more about the XMLs. You don't have to worry about that in our big data world, Hadoop world. So XML is all about the parent and child tags. We are going to see down the line how they are going to be working actually. Okay, that is all about the right structured, unstructured, and semi-structured. So we are going to see down the line how we are going to just leverage these definitions to define the big data. So we know structure, we know volume, we know velocity, we know variety. The next thing is veracity. So veracity is nothing but the accuracy of the data, right? So always there will be inconsistency, which means there is no accurate data you can see out of your whole data actually. If you collect, for example, right, 1 terabyte of data, 1 terabyte of data is not going to be the accurate data. You may see, right, some of the data is really, for example, if you're taking Amazon example only, or probably if you take any data, I mean, a exit polls are conducted in so and so city regarding the elections that has happened recently. So do you think all are going to be the accurate one? All the data that you see is the accurate one? No, some of them they just like that they submitted. Some of them they gave, they don't know anything what's going on. Some of them are not eligible, but they gave. But you see all data, but you have to separate it actually. That is called inconsistency. That is what accuracy of your data. Finding the accuracy is very, very important out of your data actually. So history says only the 70% of whole data will be accurate actually. That is called veracity means. The next thing is value, right? So earlier we used to define using these 4 V's: volume, velocity, variety, veracity. So the next thing came here before I define the value. For example, if you see high in volume of data, high in velocity, high in variety, high in veracity. If these 4 characteristics are qualifying, then simply you can call that one as a big data. High in velocity, high in variety, high in volume, high in veracity. If these 4 characteristics are qualifying, then simply we used to call that one as a big data. But do you think if you are seeing this one, but if there is no value out of your data, do you think that that is going to be any value for your company, right? It's as simple as that, right? For example, you are maintaining a IT infrastructure and you are retaining so and so data from long time, but you are not using the data at all. But because of that data, your system is training. Because of that one, your system is straining actually. So do you think that is a big data for you? No, because unnecessarily there is no value out of your data, but still you're retaining the data for no use actually. So there is a reason, if you are retaining the bulk data, definitely that should give some value should have some meaning out of that data to give some value towards your company actually. That is called value. Volume, velocity, variety, veracity, and value actually. That is all about the 5 V's. So very, very important thing. We took ample time to discuss on this one. So that's all about the big data definition using 5 V's actually. So what is Hadoop really and how the Hadoop is going to work? So we have to understand very clearly. So Hadoop is a framework basically, and it's open source one also, right? So framework is nothing but, so you as a developer, framework developer, you don't have to start your application from scratch actually. Hardly you have to develop only the 60 to 70%. Rest of the things will not be developed by the this thing actually. Hadoop is a framework. Also, it is a open source one. So open source is nothing but free to use actually. You don't have to pay any license cost actually for that actually. So that is an open source framework. Excellent. And it was born to address both big data issues, storage issue and processing issue actually. So now, what is the specialty with the Hadoop? Why your Hadoop is able to handle your big data in an effective way comparing with your legacy systems? So the one of the important thing that you have to understand here is, right, Hadoop was born with very rich features, friends. That is the reason Hadoop is able to really, right, address your big data related issues in an effective way actually. So Hadoop was born with the very rich features. One of them is going to the master slave architecture actually. Hadoop is going to follow the master slave architecture, which means Hadoop is going to work in a master slave architecture way. So which means master and slave. So indirectly, how the project manager and team member is going to work together within a team, the same way it's going to work. So this is the example always I give to all my participants, so that this example can be captured to understand most of the Hadoop concepts actually. So what is the project manager and team member? So very simple, very simple. Project manager is the one who is going to manage the team, right? Very clear. But why the team was born? What is the purpose of team? When you are working on your own, why you went with the team? Right? That's what you have to understand very clearly. We went with the team because you are not able to really complete the work. You are not able to really satisfy your client on time for their work. That is the reason we went with the team actually. When your client is able to complete your work with you alone, then you are good. But the moment your client wanted to work to be done more from your end, but when you are not enough able to complete that, then you are going to say that, boss, I cannot complete. For example, if your client has assigned the work to complete in a day, but you are going to say that I'm going to take 15 days of time, then definitely, right, no way you can see your client is going to wait till that point of time. So for that reason only, definitely you have to understand team came into the picture, where team is going to work for you completely, where team is going to help you really to complete your task on time actually. So where you're going to see parallel, right, distribution, right? The distribution of the work is being done using the team actually. So which means instead of you alone working on top of your work, you're going to have the multiple people to work for your common task actually. So what is happen? So instead of you alone working, you are having 5 physical guys, 10 physical guys you are going to have, and you're going to complete that work actually, right? You have to understand that way. So when you go alone, when you work alone, you're going to take more time. But when you just work that same work with the 10 guys, definitely you're going to complete the work on time. You're going to take very, very less time to complete the work actually. So now that's how the team came into the picture. That's how you are going to just complete the work on time actually. So he's the project manager, right? And is going to be the team member 1, team member 2, team member 3, something like that. You see, okay, that's how you are going to make sure these 10 team members are going to work for you to complete the work on time actually. Okay, So now let's see exactly, this is called master slave architecture. Master slave architecture is nothing but master is the one who is going to manage the team members actually. But one thing that you have to understand here, how the team members are going to be managed. Project manager is the one who is going to take care of the team members. All team members has to report back to the project manager. If one guy is not working, your project manager knows how to handle that one, and how the other team members are going to be working as a backups for the other team members. All these things in a team is going to work actually. The same way, Hadoop also is going to work for you actually. So here, each and every circle you have to understand is a computer. It's a machine actually. It's a node. It's a computer. All are going to represent the same thing. So what is happened here? Instead of you alone working or only single server, single computer, single node is going to work for you, you are going to have a multiple computers you kept together within the network, right? You pulled multiple computers to work within the network together towards the common task, right? So instead of you alone working, you pulled 10 computers, indirectly 11 computers you pulled here, right? Including your master, you pulled the 11 computers together within the network where they can work together, where they can talk each other. So that is called cluster actually. So team is equivalent to the cluster, master computer, and it's going to be the slave computers actually, slave machines, physical machines, friends. So how you are attending this meeting using your computer. So those kind of machines, you are given 11 machines to build this cluster actually. So we are going to see down the line how we are going to build this cluster very clearly. We are going to see it, but 11 machines you kept together within the network to just build the right a cluster actually. So how they are going to help you out to really, we are going to see very clearly in terms of storage, in terms of processing, how this Hadoop cluster is going to help you. We are going to see one by one. There is no limit to add the number of nodes to the cluster, number of machines to the cluster. If you want more storage capacity, simply go ahead and add. If you want more processing capacity, simply go ahead and add. So this is called horizontal scalability. You are scaling your system in a horizontal way, right? So that is one of the excellent feature out of the Hadoop. Hadoop is going to enable you to scale your system in a horizontal way. So for example, to really little bit elaborate that one, for example, you take the two organizations. One is Google, other one is for example, a small, probably your a banking sector. For example, if you are from India, let me give a simple example, any banking, ABC banking. So now you see your Google, whatever the infrastructure that is as, whatever the Google, you have the IT infrastructure, Google can manage, right? For example, forget about the Hadoop and all, existing infrastructure, whatever you have Google 15 years back, 20 years back, they can maintain, for example, 50 terabytes of data easily, right? Because the IT infrastructure that they have is really well matured one. They can maintain 50 terabytes of data in an easy way actually. But do you think the 50 terabytes of data can be managed easily by ABC organization from the banking sector? Because they did not think much about the data. They thought more about their business, not about the data. But Google has thought a lot of data is going to come because their business is that one. That's how they had the matured systems there. So that's how existing systems, whenever from the Google side, they see 50 terabytes of data is not a big data for them. But when you see the same 50 terabytes of data from ABC organization is going to be the lot of data actually. So your ABC organization can call that one as a big data, but your Google is not going to call that one as a big data actually. That is a difference when to call your data as a big data. Simply, whenever your existing systems are overloaded with the data that you see out of your organization, then you can simply call that data as a big data actually. So when extending horizontally, is it cost going to be increased as well? Yes. Instead of using one machine, you are as you are increasing horizontally, you're going to say 1, 2, 3, 4, something like that. You are increasing horizontally. Definitely, you're going to put a lot of efforts to buy these things actually, right? Definitely. Instead of buying one machine, if you're buying 10 machines, you have to spend 10 times actually. But you have to understand very clearly, Hadoop is going to claim that, right? They can use the commodity hardwares actually, cheap hardwares, general purpose hardwares actually. So when you go with the legacy side, for example, any MySQL server, right? So you cannot use the cheap hardwares there actually. General purpose hardware, whatever you use in your personal computer, these are the general purpose hardwares actually. So you cannot use them cheap hardwares there actually. You have to use the high reliable hardwares, right? When you go with the high reliable enterprise hardwares actually, you have to end up spending a lot of money to buy those enterprise hardwares actually. So cheap hardwares are the general purpose hardwares and you have to spend very less amount to buy them. So Hadoop is going to claim that, yes boss, you can use the cheap hardwares for me to build actually, because I have my own tolerate mechanisms. Best features is best tolerate mechanisms that where I can tolerate my data, where I can make sure my data is available more than one time. So that's how they came actually. Hadoop can use the commodity hardwares. One commodity, instead of buying one enterprise hardwares, you can buy 50, 60 commodity hardwares actually. There is a difference between the enterprise hardwares and commodity hardwares actually. So now how this is going to help you out to store your data. Let's go ahead and see one by one. So very simple. Hadoop is born to address your storage related issues and processing related issues. Let's go ahead and see how this is going to help you out. So very simple. So instead of one computer that you have, so right, in the legacy side, you have only one machine, right? You're going to maintain that complete thing using the single machine actually. And you're going to say standalone, individual machine. So now you see, for example, if you're having, right, 4 terabytes of data, you are going to see 4 terabytes of data will be managed by the single guy. So you are here, you are the client and you're trying to use your legacy system. Then you are going to see 4 terabytes of data will be managed by the single guy. No way you can share it, right? You're going to just manage using the single guy. And when it's come to processing side also, right, you're going to see 4 terabytes of data will be managed by this guy actually. 4 terabytes of data will be managed by your single guy. In terms of processing also, single guy has to process actually. That is where it's taking more time, right? That is what the main issue with the legacy side. So now how this 4 terabytes of data will be handled by your Hadoop? Let's see that. So you are going to send the request to the team and the team is going to, which means it's going to be notified for the project manager. So in the case, master computer is the one who is going to really notified, saying that yes, this is the work that I need to store. So now here in terms of storage, first initially we are going to see the storage, then after that I'm going to discuss about the processing side. So now you see 4 terabytes of data that we have. So for example, 4 terabytes of data that we have, I need to handle that one actually. So one thumb rule before that. So each and every machine hard drive, computer, you're going to have a hard drive. You know that your computer hard drive is how much, that much of data that you can store. So now I see 20 terabytes of data that you have, probably 32 terabytes of data that you have, 32 terabytes of data that we have each and every machine hard drive capacity. So 32 terabytes of hard drive is really huge actually. So to maintain the 4 terabytes of data, do you think 32 terabytes of data needed? So very simple. I can manage using this with the 4 terabytes of data I can manage, but that is the legacy way of managing your things actually. That is the legacy way of managing your these things. But how the Hadoop is going to do? So here one thumb rule that you can remember always, whenever you are going to store the data in the Hadoop cluster, Hadoop is going to divide the data into the chunks of data and distribute actually. He is not going to store your whole data together. Even though individual machine is enough capable to handle your whole data, your data will be divided and distributed actually. So what is the meaning of that actually? So now you see 4 terabytes of data. Let's say we divide into the 4 parts. For our easy understanding purpose, I just said 4 parts, but does not mean that it's going to be the 4 parts actually, right? We can go very in-depth discussion how the division is going to happen. We are going to see down the line. You don't have to worry about that. A simple, a layman way, right? You don't know anything about Hadoop. So you simply have to understand my 4 terabytes of data is divided into the 4 chunks and it started distributing this way.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Right, your master computer is the one who has distributed one chunk here, one chunk here, and one chunk probably here, and one more chunk somewhere else here, actually probably here. Let's just keep one more here, so that many rules, whatever you are going to assume, but you can break them actually. Right, friend, you can see very clearly here, instead of just going and depending on single guy, you are distributing your work to the multiple guys. You have divided your data into the 4 chunks and you distribute it into the multiple guys. So now you see one chunk here, one chunk here. You don't have to really distribute sequentially. If you are distributing 1, 2, 3, it does not mean that 4, 5 has to be used. That's the reason I broke that rule. I left the data slave node 3, right? Slave computer 3, I left it. And the next thing is, when you are accepting one chunk from one file, does not mean that another chunk cannot be accepted from that file actually. You can, as long as you are having the bandwidth, those many chunks also you can accept from your main thing actually. So that is how you can see very clearly how your data distribution has happened actually. Instead of storing using the single machine, we are going to have the multiple machines for you actually. That is all about the how the data division is happened and distributed. This concept only we'll be calling as a Hadoop distributed file system. So we can call them as a HDFS, Hadoop distributed file system, to address the storage by issue actually. So we are good with the storage things. And the next thing is processing. So now definitely the processing is nothing but you as a user, you are going to send the logic, and also you're going to send your file name. That's all. This is my file name and I need to process this one. So this is the logic and this is the file name. So you as a user, you know this division, where your divisions, where these chunks have been distributed, which chunk is going to be really maintained by what and everything. Are you going to see this one really? The answer is definitely no actually, right? So you as a user, you don't know anything. You don't have to know anything. All you have to understand, right, where what is my file name and what is the logic. So when I say logic, what you need to read out of that file, what you wanted to see out of your that file actually, that is all about the logic actually. So now that is how you send the master computer. Now master computer, so he is going to really check your chunks, whether it is accommodated by your slave 1, slave 2, slave 3, slave 4, something like that. So for example, if you take Yahoo, which is one of the biggest Hadoop cluster, right? 45,000 machines they added together. So do you think 45,000 machines that you have to scan to locate your data now? If that is the case, forget about the advantage that you see, but a lot of overload will happen actually. But how you're going to see that? So one thing that you have to understand very clearly, so you are going to see at the time of storage, your project manager is going to maintain a log, right? Your project manager is going to maintain a log saying that, yes, my work has been distributed into this many guys, and these many guys are doing this one. And if anyone is requesting the work status, I need to go ahead and check with these guys. That's how he's going to maintain the log, right? Definitely. The same thing in Hadoop also, your master computer is going to maintain a log. So we'll be calling that one as a metadata in our Hadoop terminology. That metadata is nothing but data about your data, information about your data. The real data is your your file that is being this guy, right? About this one, we are maintaining some information saying that my whole data has been divided into the 4 chunks. One chunk is there with the slave 1, other chunk is there with the slave 2, other chunk is there with the slave 4 and slave 5, 2 chunks. That's how that information will be maintained here actually. The information will be maintained here. So this guy, right, the same thing, the moment your master computer is receiving any request to process, he's going to scan that metadata and is going to simply send the logic wherever the data exists actually. So now, so here the request is being sent to this guy and this guy and this guy. That's all. So whichever the machines not involved, they don't have to work for this task actually. Whoever is involved to accommodate your data, they have to work on top of your these things actually. So now you see, so this is the data. Now you see slave computer 1, and this is the logic, and your master computer is going to assign the work to the slave to start working on top of this chunk alone. The same thing, this slave is going to work on top of this chunk alone. The same thing, this slave is going to work on top of this chunk and also this chunk actually. So that's how they start reporting the status back to the master computer actually. So now master computer is the one who is going to consolidate the results and is going to report the status back to the client actually. So what has done here, instead of just processing using the single guy, and as the data is being distributed the same way we started processing actually. So we are going to see really in depth the concepts how the processing is going to happen, but at a high level what has happened, where the data is being distributed, there only you started processing actually. So this concept only will be calling as a MapReduce. So MapReduce is a programming model, right? It's a technique using which you can address the processing related issues actually. Storage related issues will be addressed by your HDFS, and processing related issues will be addressed by your MapReduce actually. So now there are some ecosystems, right? These are core systems we can call core Hadoop core systems. If someone is asking what are the Hadoop core components means, these are core components. So you can get the ecosystems also, right? Ecosystems, but I'm going to define, we are going to learn Pig. Pig is nothing but it's a scripting language, and it's an alternative to MapReduce actually, right? So we are going to see how that is going to be useful and all. It's a Latin script so that we are going to use scripting language, and using that we are going to really just alternate it to the MapReduce, because MapReduce is a framework, right? It's a technique, right? It's a framework, it's a technique. So we have to use Java or Python to develop actually. So Java or Python or Perl or Ruby also we can use it to develop this. We have to use this case actually. But you have to understand very clearly. So MapReduce, right? It's a programming model using which you can process. But to develop that model, definitely you have to use Java or Java kind of programming language. So now definitely you're going to ask me, do I need to know Java or Python to develop the MapReduce? Yes, right? We have to know definitely a Java, core Java, definitely you have to understand. Otherwise, there is no way you can develop the MapReduce. So that is the reason they develop the Pig. So to avoid the writing your MapReduce using Java or Python, simply you write the Pig scripts using Latin scripts. Very, very simple to understand, simple to really learn also. So you can just alternate the MapReduce. You don't have to know single Java if you know a little bit Python actually. The same thing Hive. Hive is same as SQL. So the engineers who are from SQL background, Facebook thought like they should able to really come up and develop the Hive application, I mean Hadoop application. So that's how they develop the Hive framework. Hive is same as SQL. If you know the SQL, then you know most of the Hive concepts actually. So these queries again, they are going to just use to alternate your MapReduce actually. You don't have to worry. So you know Pig, you know Hive actually. We are going to see HBase also. HBase is nothing but NoSQL one. What I mean by NoSQL, not only SQL databases, there are different NoSQL databases are available. So using that, you can maintain. NoSQL specialty is nothing but you can maintain the billions of instructions in your table. So when it comes to big data world, using row oriented, right? Rows and columns, it is not easy to maintain that much of data. That is the reason, right? We go with the column oriented actually. NoSQL databases are the one of the column oriented database. We are going to see in depth about that, but you can maintain entire data using the single column. How and all we are going to discuss in depth in the HBase discussion. You don't have to worry about that. Okay. Then the next tool that we are going to discuss about the Scoop actually. So to import the data from RDB MS DBs to Hadoop world, we are going to use Scoop actually. SQL to Hadoop actually. Scoop is nothing but SQL to Hadoop. So really to import the data from RDBMS DBs to Hadoop, we are going to use Scoop actually. So Scoop, the same thing, Flume, right? Flume to import the streaming data from large log files into Hadoop side, we are going to use, right, Flume. So they both are data ingestion tools. To get the data from outside world into the Hadoop world, we are going to use these two things, Scoop and Flume. but they have their own different usage. We are going to really discuss down the line how we can use them in a different way. But a simple one-line statement, Scoop can use to get the data from our DBMS world, and Floop can be used to get the data from the streaming, definitely from large log files into the Hadoop actually. The last thing that we are going to discuss, Oozie. So Oozie is a scheduler actually. So to run your jobs in a particular pattern, right? If you take any organization, it's not something only one job that you're going to run. You have to run multiple jobs to really maintain your data actually. So for that, we use Oozie actually. Okay, so these are all about the ecosystems. We are going to discuss in depth about them as we proceed further. So now let's go ahead and discuss about the HDFS now. So HDFS, now we know very, very high level about the Hadoop cluster. It's a combination of multiple machines, and we are going to have master and slaves. Master is the one who is going to maintain the slaves, and slaves are the one who is going to report back to the master. We know very well. So this is going to be the master computer, and this is going to be the slave computer. Let me take this picture, just have in one more pen so that I can make use of that one for the, okay. So let's proceed further. So how we are going to make use of this. So this is what your master computer, master node, computer, both are same. Slave node, slave computer, both are same. Slave node, right? And also we can call this one as a worker node. And also we can call this one as a data node. All are going to represent the same thing. Slave node, worker node, data node, all are going to represent the same thing. The only slave node one, you can call them as a data node one or worker node one. Anything is fine. Okay. So now let's go ahead and see. So how this is going to be helpful. So one thing that you have to understand here, master is the one who is going to manage all these things. The same concept that we discussed here, but how we are going to manage the data. For example, you have a file, right? File name is called temp.txt file. So who is having, right? So and so size. So then how you are going to manage the data, we are going to discuss one by one. So this is the this is the temp.txt file. Then I wanted to store the data into the Hadoop cluster. So from here onwards, every topic is interlinked. So please try to concentrate on my screen 100%. If you're not able to follow any time, any screen, please do stop me. Okay, so now next thing, temp.txt is the file that I wanted to store the data into the Hadoop cluster. So now, like I said, the file has to be divided into the chunks actually. So now how that is going to be divided, who is going to decide that one? So all these things we have to discuss one by one. So now here, as we know, this division, right, in our Hadoop cluster, the division is going to happen at the file level, not at the cluster level, not at the directory level also. As you know, every directory is going to have a multiple files. If you take a Windows, as you use most of the time, you use in a Windows folder, you see the multiple files. Each file is going to just have in the directory. So, but the division is going to be at the file level, right? And this division, a user can decide how they wanted to divide the data actually. How they can decide and divide the data, they can decide here actually. But for example, user has not decided to divide the data into the chunks. Then there should be the default division also has to be there, right? Based on the Hadoop version, we can just go ahead and divide the data into the chunks of data. For example, you see temp.txt file, and don't worry about the chunk, but let's go ahead and see. I'm using the Hadoop 1 version. So there is 1 version and also there is 2 version also. And nowadays we are using 3 version also, but very rare, it's not matured. But 2 and 3, there is no difference. 2 and 3, very in-depth concept. There are differences, but you don't have to worry about that. So Hadoop 1 version, initial version. So what is the default division actually? So based on the size, right, we have to divide, right? So whether you go with your own division, whether you go with the Hadoop version, but you have to have a concept. You have to have a parameter to divide the data into the chunks of data. That parameter name only is called block size actually. So block size is nothing but the way you are going to divide your whole file into the chunks of file.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
So what is the block size here? So let me define the block size here. So default block sizes that we are going to see, but what is the block size means? Block size is a parameter. Block size, what is that block size? It is a parameter, it is a argument, or it is a just a simple value using which parameter, using which we are going to divide the whole file into chunks of file. So you can read. I'm requesting everyone to read this one so that you will understand what is the block size. So I know as we proceed further, it will confuse you, but you have to understand block size is a parameter using which we are going to divide, right? Block size is a parameter which is used to divide your file into the chunks of file actually. So this block size you as a user, you can define whether the based on the version you can go. A default block size is based on the version that you are going to have. For example, you decided to go based on the version, right? So when you say Hadoop version that you're using one, then all in every machine you're going to see only one. It's not something one in one machine, two in other machine. You're not going to mix it. So for example, you as a Hadoop user, you decided to go with the Hadoop one version. So what is the block size that you're going to see as a default way? It's going to be the 64 MB actually. 64 MB is the block size, default block size using which you are going to divide the data into the chunks of data. So 128 MB in two version actually. So what does this mean? This means your whole file has to be divided into 64 MB is the block size so that you start seeing the number of blocks, chunks, sizes, slices, pieces, and all that we used to call as a layman way, but now you have to understand that is a blocks actually. The whole file will be divided into the number of blocks, right? So temp.txt file is being divided into the block size actually. So now for example, so what is our really right file size? For example, temp.txt file is having 100 MB and the block size that I'm going to have is 64 MB because of the one version. So how many blocks? So two blocks, right? B1 64 MB and B2 36 MB, friends. So that's how the division is going to happen. So any questions? So the block size can be configurable. Going forward, when I say configurable, you can go all the way with the 1 MB minimum block size that you can go with 1 MB, which means you can go and configure your block size there 1 MB in one version and two version. Maximum block size can be anything. I should give as a star here, right? Block size can be anything, but one thing that you have to understand, so we should not go more than 256 MB as per our recommendations, because the more block size that you have, the more resources and availability that you are going to see actually. So that is the reason you have to understand very clearly block size maximum 256 MB that you have seen so far in my work experience actually. So minimum that you can have 1 MB, the maximum can be 256 MB. Indirectly you can take that one as a selection. 1 terabyte. Let's do how we are going to do 1 terabyte. If you are going to convert into the MBs, so you can do 1024 or 1000 also, does not matter. So this is what 1 GB, right? 1024 GB equal to 1 terabyte. Again, if you do multiply with 1024, it became what? MBs actually. So now it is 1024 into 1024 equal to 1 terabyte by 64 MB. Both are MBs, right? So if you do this guy, what is that answer? That is going to be your answer. So it's going to be the 16,000 something, right? 16,556 something. You see that correct answer. But 15,000 also it's fine. 16,384, right? I think that is the, so now file 1 70, right? Then both are MBs. I don't have to convert. There is no work for me, then 64. Then how many blocks ended up having? B1 64 MB and B2, the rest of the data we just track as a B2. What is that? 6 MB, right? Then file 2. So what is that? Your 10 MB. So by 64, there is no way you can divide, then you are going to track that one as a B1 actually. So now how many blocks you ended up having? First one is 2, second one is 1. So total 3 blocks actually. That is the answer actually. So this is the calculation. So one thing that we are clear now, how we can divide our file into the smaller files and track them in our HDFS file system. Very, very high level we are able to discuss. Let me take you a little bit in depth so that you will understand more on this one also. So now you see, right? So this is how your master computer and who is there for you to manage your data. So now, for example, temp.txt file. So now it has divided into the smaller files, which is block 1 and block 2, as 64 MB is the block size, B1 here and B2 here. Or for example, B2 somewhere here where you are having around, right, data node 1, data node 2, data node 3, data node 4, and data node 4000 or 5000, for example. Right, these many machines are there in your cluster. That's how the data distribution is happening, right? So one thing that you have to understand, right, these are master component, master node. So now you are the one who has stored the data, and that is how it's settled, which is good. So now, for example, another client, another user came into the picture and he wanted to read your temp.txt file. You send the request to the temp.txt file. Out of your temp.txt file, now you send the request. All you are going to say that, yes, I would like to locate the temp.txt file. So the request will go to the master node. Now master node is going to scan 1, 2, 3, 4, 5, something like that, 5000 files to locate your temp.txt file, which is just 100 MB of file. No way it's going to happen, because each one is, for example, 32 terabytes or 64 terabytes of data that you have, right? So then definitely what will happen? It is going to take a lot of time to scan just 100 MB of file. So forget about the advantage that you see, but a lot of disadvantage that you can expect out of this connection. So for that reason only, what your master computer is going to do, he's going to maintain the metadata here, friends. So metadata is nothing but, right, data about the data. So information about the data. That is the metadata definition in our layman language. So information is what? Simply some data that you are maintaining about your real data. The real data is temp.txt file. About that we are maintaining some information. So here our Hadoop is going to maintain some information about your each and every file. So that is called transaction log, you can call, or metadata, saying file name, file size, block size, right? Number of blocks, blocks location, right? And user group, and for example, date, and permissions, right? All these things that you can expect as a metadata is going to have. For example, our temp.txt file, let's see, the file name is temp.txt file, and file size having 100 MB, block size that we wanted to have is a 64 MB, number of blocks is 2, and blocks location B1 is there with the data node 1, and B2 is there with the data node 5000. Okay, and user, for example, XYZ, user belongs to super group, and date 08 something 24 or whatever it is, and permissions, read, write, blah blah blah, whatever it is, right? So this is how for every file these guys are going to maintain this information, and it's going to be the flat file, right? So your metadata will be managed by one of the master computer in terms of flat files actually, right? Binary format, nowhere you can read it, but it is in terms of binary format. Now you see this whole file has been tracked this way. Now you see, right? So this file is a flat file, binary format, nowhere you can read it. But the moment your master computer is going to receive any request, he has to scan this file. If there is any entry in this file for this file, then only it's going to say that the file exists. Otherwise, it's not going to It's going to say that file does not exist actually. So this is a temp.txt file. If it is exist, it's going to say yes, it is available. Otherwise, it's going to say that not available actually. So temp.txt file, and it is available, and it's going to check B1 is there is the data node 1 and B2 is the data node 5000. Simply is going to send the request to B1 and B5000. He does not have to scan the rest of the machines because they are not involved in accommodating this data actually. So that is all about the metadata. So you see, can you locate your file without metadata file? Right? Is it possible to locate your metadata file? I mean, without your metadata, is it possible to locate your actual data in the HDFS file system? The answer is yes. It is not possible. It is impossible. So that is the reason metadata is a hot kind of thing for your HDFS file system. If there is no metadata, no way you can locate it actually, right? So if you are missing the metadata, no way you can locate this guy actually. That is the reason we call this one as a counter piece of your HDFS file. It's a hot kind of thing. So if you are missing the metadata, nowhere you can recreate this one. You have to start from scratch. You cannot do the reverse engineering saying that data node 1 is having these many blocks from these many files, then I'm going to recreate this metadata. Nowhere you can create, because you don't have user information, you don't have permission information, you don't have date, you don't have groups information. All these things you cannot rebuild again from the existing file system. You have to retain the metadata as much as a backup, as much as you can actually. So that is the reason metadata is going to play very important role actually. So who is going to maintain the metadata? One of the master computer. Yes, if the master computer is going down, that is what Veera's question. What will happen? Your complete cluster will become the inaccessible actually. So is a Lehman way we are calling as a master. I'm going to introduce the real names for that now. A high level, you're just calling as a master nodes, but at a low level, we are going to see. So who is managing the metadata? One of the master computer. That master computer name, let me introduce. That is called NameNode. NameNode is a master node. We'll be having the multiple master nodes in the Hadoop cluster, right? NameNode is a master node. ABC is a master node. XYZ is a master node. We are going to introduce one by one as we proceed further. Okay. So NameNode, I just introduced the one master node, the first master node, that is a NameNode actually. So you have to understand NameNode is a master node who is going to really take care of your Hadoop metadata, Hadoop cluster metadata. As of now, it's going to have the multiple responsibilities. One of the first responsibility I'm introducing, the NameNode actually. Metadata. So NameNode is the one who is managing the metadata. NameNode is the one who is managing the all external clients in terms of writing the data into the Hadoop cluster, in terms of reading the data out of your Hadoop cluster. Again, I'm repeating, in terms of whenever you're writing the data into the Hadoop cluster, whenever you're reading the data out of your Hadoop cluster, you are going to see, right? NameNode is the point of contact. The metadata also will be managed by the NameNode actually. And also whenever you are assigned the work to the data nodes, you are going to send the work. The NameNode is the one who is going to send the work to the data nodes in terms of data storage. So I just introduced one master computer, that is a NameNode actually. Okay, let's proceed further. So these are the data nodes or worker nodes. You can call them with any name that you wish. So this is going to be the name node. Let's start with our real names, name node actually. So now name node is the one who is managing the metadata. You know what is metadata, and he is the one who is going to manage the worker nodes, data nodes, right? Worker node, data node, slave nodes, all are going to represent the same thing, friend. Okay, so whatever number of machines. So now temp.txt file that you just sent to store the data, and block size that you wanted to have is 64 MB. Then you ended up having two blocks, B1 here and B2 is somewhere else. So now, as we can see, every participant is expecting. Yes, if you are just missing the metadata, then you have to start from scratch. For example, it's been 2 years you started, or it's you're interacting with your Hadoop cluster, and you missed your metadata file. So you are going to start from again scratch, right? For example, 1.5 years back you started, And from 1.5 year onwards, whatever the activities that you're done, you have to redo again. So is it going to be acceptable? Definitely no.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Right? So you cannot redo the same thing again. It's really not easy actually. Okay. So now let's see. We have to have a backup for this one. Is there any way to recover the metadata file? Excellent. Right? Definitely everyone is expecting metadata backup actually. But next, before we proceed further, you have to understand, right? So anytime in this cluster setup, right? Anytime if someone is sending any request, that request is being sent to the name node. Name node should be always active. At the same time, you should listen that request actually. The same thing, you're sending the request to the data node, right? Data node also should be always active and should be responsive back to the name node. So for example, though you're in online, if you're not responding me back, what is the purpose of staying in online? No, actually. So that is the reason always every machine has to have a listener kind of thing to take care of their responsibilities actually. If you remember, if you know a little bit about the daemons concept. So what is daemon here? Any language. For example, if you know a little bit Unix, you know the daemon. If you know a little bit MySQL, you know the daemon. If you know a little bit about server side, you know the daemon. Daemon is nothing but it is a process, right? It's a process or program that will be running always in the background actually. So that is all about the daemon. Daemon is the process or is a program that will be always running in the background actually. So now here, if you go with the MySQL side, MySQL D is the daemon that has to be always running in the background in order to just to take care of your MySQL responsibility. The moment you are not running that, your MySQL is not going to be the accepting any request from the outside clients actually. The same thing here, each and every machine has to be responsible to take care of these actions actually. For that reason only, we go ahead and just make sure some of the daemons we are going to run in our Hadoop cluster. Hadoop daemons. So total we have 5 Hadoop daemons that we have actually. So let's go ahead and name it one by one actually. So NameNode is a daemon, right? I'm going to run one listener, right? Always in this machine, that script, that service, a program, a script, a service, right? We are going to run in this machine that is called NameNode actually. So now first daemon I introduced, NameNode daemon. So now here also, right? In every machine, we need to run one daemon to take care of the data node activities. So that is called data node daemon actually. In every machine, it's not something one data node is going to, one service is going to take care of all machines. If you're having 50,000 data nodes, means 50,000 data node daemons you are going to see. Each one is going to run one. In every machine, you're going to run one data node daemon, and that is going to take care of that data node work in terms of storage, in terms of reading the data out of your Hadoop cluster, in terms of writing the data to the Hadoop cluster actually, right? That is name node and data node. Name node is going to take care of your all responsibility what we discussed, and data node is going to take care of that one. And again, at the same time, you see those responsibilities actually. Clear? Name node, data node. So what else? So now you see, as we are expecting the backup for your metadata, we are going to have one more master computer to take care of the metadata backup. So that is only the purpose, friends. Please try to understand the purpose of this computer. Then after that, I'm going to introduce the name, because name also is going to confuse you, right? Because they gave very bad name, the worst name than your blocks is they gave this name. So it may confuse you. So I don't want to confuse you. That is the reason I am requesting you to understand this mission purpose. Then only I can introduce the name. So now you see, every 1 hour, what this machine is going to do is going to copy the metadata from this machine into this guy. Every 1 hour, you are copying your metadata every 1 hour from this mission to this mission, and this can be configurable. You can go with less time, you can go with more time. So for example, this mission is gone, right? You are not able to recover your hard drive also out of this mission. Then I can only just locate this mission to recover this metadata, friends. That's all. The moment your name node is going down, I'm not going to bypass this request to this mission actually. I'm not going to take care of my data nodes using this machine. It is not going to do this one for you. What is the one time of 1 hour, which means after every 1 hour from now, after next 1 hour, you're going to take one more file backup from this machine into this machine. Actually, this is one more master computer. We are just backing up that one into the other machine. This is one computer. This is one computer. That computer name only, right? Secondary name node actually. So this is secondary name node, which is just taking care of your metadata backup. So we are going to run one more daemon that is called secondary name node. Right. So far we have seen name node, secondary name node, data. Three daemons that we have seen. So two master computers, name node and secondary name node, two master computers that we introduced. Okay. So now, so far we are discussing about the storage. Name node, data node, secondary name node, all are just handling your storage. How about the processing side? So when I say processing, right, your data has been settled. Now one client came and you wanted to locate your data. Probably he came up with the MapReduce and you wanted to process against that. So now MapReduce request will be taken, it will not be taken care by the name node actually. So MapReduce request has to be taken care by the one more master computer. That guy name is called job tracker. So in Hadoop one version we'll be calling as a job tracker. They are the one who is going to take care of your all MapReduce jobs. And in 2 we are going to have the resource manager actually. Okay, so we are going to see what is the resource manager in Hadoop 2 version. So job tracker and resource manager. So job tracker in one version, and that has been replaced with the resource manager. What does that mean and all we are going to see. Yarn architecture actually. So definitely I'm going to take you there actually. You don't have to worry. In depth I'm going to take you there actually. Right. So we are going to run job tracker. Right. So job tracker is the one who is going to take care of all your jobs. So now the request is been sent to the job tracker, and job tracker has received the logic and is going to receive the file name. That's all. Temp.txt file is the file name and this is the logic. That's all. So job tracker has any information about your blocks of your file. So this file name is temp.txt file. Then that's all. Where the blocks exist, where they are available, all these things, who knows that? He has any intelligence to locate the data? He has any capable to locate your data? No, exactly. He does not have that information. So who has that information? Who knows your block report? Who has enough capable to handle your block report? Metadata. But who is maintaining the metadata? Exactly, name node. Then simply I need to request the name node. Definitely, but I need to know this is the my file name, but I would like to know what is the block report. So now name job tracker is the one who is going to send the request to the name node. Name node is the one who is going to scan the metadata, right? Who is going to scan the metadata and is going to check how many blocks are there and where they exist, and they are going to simply report back to the job tracker saying that yes, temp.txt file has been divided into the two blocks, and it is there. Block 1 is there, the data node 1, and block 2 is there with the data node 3. So now that's all. Job tracker is the one who is going to be start interacting with the respective nodes where the data exists actually. Okay. So now job tracker is at the cluster level, friends. All is managing the jobs. He cannot go all the way with the data node level and cannot just really do anything actually. So he's going to just have one more housekeeping the here. That guy name is called task tracker actually. So task tracker is the one who has to take care of these things actually. So job tracker is this guy. Task tracker is the one who is going to take care of the job tracker works. So indirectly, job tracker is the one who is going to assign the work to the task tracker, saying that yes, this is the logic, and you have a B1 from the temp.txt file with you. You go ahead and start processing this guy. Now task tracker is the one who is going to start the process against this block 1 with this logic. Then from here onward, it is going to report the status back to the job tracker. The same thing here it has happened, right? So from here onwards, he's going to send the status back to here. So job tracker is the one who is going to track the complete status, and is going to take the help from again one of the task tracker to consolidate your results. We are going to see in depth about the job tracker at the time of MapReduce discussion. But end of the day, job tracker is the one who is going to consolidate the end results and is going to report back to the client actually. So that's how, right? Task tracker also is being introduced actually. So what is that? Task tracker in one version, right? That is being replaced by the node manager in Hadoop 2 version. So we are going to discuss more about this job tracker and task tracker, or resource manager and node manager in our coming discussion actually. So any question? These are the 5 daemons that we are going to run in our Hadoop cluster. So let me take the questions one by one. So all you have to understand, this each and every box is an individual computer. A typical Hadoop cluster is going to have it this way. These are all individual machines, individual computers. It's not something you're going to merge together as a single machine actually. Right? So Arti says, where is the job tracker is running? In the other machine, other computer. NameNode is one computer, secondary NameNode is one computer, job tracker is one computer actually. Right? What is the task tracker? Task tracker is at the data node level to take care of the all tasks actually. Right? Data node is the daemon that is going to take care of all in terms of storage, in terms of reading and writing the data. Task tracker is the one who is going to take care of the all the jobs in terms of writing the data, in terms of reading the data out of your Hadoop cluster action. Okay, so now you see dead node 5 and also this one, and this is how your data will be sent, temp.txt file, and so you see B1 is here and B2 is somewhere else here, right friend? So now please concentrate on my screen. So now this is how your data has been settled. So now these machines are the commodity hardwares, right friend? Cheap hardwares, general purpose hardwares. They may go down any given period of time. So definitely you have to have a backup for this guy actually. So now the moment they are going down, then you are not going to realize to have the backup friend. There's no way you can just do that one, right? Definitely you have to have a backup before, right? Even though it is going down now, should have a backup. So for that one, what a Hadoop cluster is going to do, for example, your data node 1 went down, so your B1 is not available, then only B2 is available. That does not mean that only one block is not available. What is there, friend? I will go ahead and process B2 to see my output. No way you can see that one. Definitely 100% the data recovery has to happen before you start processing your data actually. Without, right, no way you can really process the data out of your 1 terabyte of file. Also, if one file is missing, one block is missing out of your 16,384 blocks, one block is missing, nowhere you can process that file actually. It's going to say that block is missing, right? Somehow the data recovery has to happen. So now you see dead node 1 went down, now B2 is only available, then you have to recover now to process your temp.txt file. If that is the case, definitely you see a lot of really disadvantage here actually. So for that reason only, what my Hadoop is going to say, at the time of copying the file, I can maintain the multiple copies actually. So B1, B1, B1. So 3 copies by default I am going to maintain, B2, B2 and B2. So now for example, I'm going to distribute this one into the randomly based on the bandwidth that is available. So B1 was here and one more B1 was here and one more B1 was somewhere else here actually. So now B2 is here and B2 is somewhere else here actually. So now you are not maintaining exactly data node replicas, but the copies that you are maintaining for your data. Indirectly, one file, block 1 is indirectly one file, and you are maintaining that in the 3 places actually. So this is called a replication factor actually. The default replication factor in 1 version and 2 version and 3 version, everywhere it's 3. Default RF is 3. The minimum, again, this can be configurable at the file level, not at the cluster level, not at the direct level. It's at this purely at file level. How we had the blocks at the file level, the same thing, the replication also can have the block level, file level. The minimum replication factor that you can have is 1, and the maximum replication factor that you can have is anything. So when I say here anything, really anything, right? Really anything that you want, you can have. The more replication factor, the more data availability here actually. So now let's see. So you see here at the time of copying your data, you maintain 3 copies. So now indirectly, instead of maintaining 100 MB, you are maintaining 300 MB of data in your Hadoop cluster. Hey Shiva, you are already having the lot of data. On top of that, you are having 3 times of data. Yes, of course I can do that one. How many machines that you want, I can horizontally add to my cluster, right? Commodity hardware, cheap hardware. There is no need to worry about the storage. All I need to just take care of my data with the very limited amount. So now you see B1 and B1 right here. So one B1 is not available, right? This complete information will be maintained in the metadata front. It's not something only one copy will be maintained and the rest of the copies will not be maintained in the metadata. No. So everything will be maintained in the metadata. Other thing that you have to understand, there is no priority that I'm assigning, right? First one is B1, first priority. Then second one is B2, second priority. Third, data node 4 is having third priority. There is no such concept actually. All are having the equal priority. So for example, the moment your name node is receiving the request to locate your temp.txt file, it has to locate only one copy, right? Not 3 copies, only one copy. So now B1, it was not available in the, it was available in the data node 1, but it is not available now. Then no way you can locate out of data node 1. Then what else we have? Data node 2 and data node 4. So data node 2 and data node 4 B1 is available. Then out of these two machines, which one is having the more bandwidth? That machine that you have to locate. For example, dead node 4 is having more bandwidth. When I say bandwidth, I'm going to really discuss more about the bandwidth actually, right? So how the bandwidth distribution is going to happen now, right? How we are going to locate that one, we are going to see down the line. So you see dead node 4, I'm going to really locate B1 because dead node 4 is having more bandwidth. When I say more bandwidth, we are going to discuss down the line. What do you mean by bandwidth and all? That is purely based on the RAM and hard drive. So that is each machine bandwidth is going to come out of that one only, right? So now out of B2, now B2 you see dead node 2, dead node 3, dead node 4 also. So now out of these 3 things, I'm not going to prioritize anything. I'm going to see the equal priority out of these 3 copies. Which one is having the more bandwidth that will be picked? For example, dead node 3 is having the more bandwidth. So now dead node 3 is going to be picked for the B2. So B1 from dead node 4, B2 from dead node 3 actually. So that is how the replication factor is going to help you out. So replication factor, it's a fault tolerance mechanism using which you increase your data availability in the Hadoop cluster. Instead of just depending on a single copy, you made sure 3 copies are available for you so that you can just maintain the data, right? Or you can process your data without waiting to recover your data from there actually. At what time the data replication happen? When the writing the data or after some time? At the time of writing the data. When you are writing the data into the Hadoop cluster based on the replication factor, your data will be replicated. So then the second thing is how your right data node is going to, how your name node is going to know that your data node 1 went down, right? You have to have that mechanism also. How your name node is going to know your data node went down, right? So that is also you should understand. Each and every data node is going to send the signal pulse back to the name node saying that I am alive. So that will be calling as a pulse, heartbeat, or signal. Every data node has to send the signal back to the name node saying that yes, I am alive. So that is going to be the every 3 seconds. So this can be configurable by default 3 seconds. Every data node is going to report back to the indirectly ping back to the name node saying that I am alive. For example, let's see the first data node 1 case actually. So name node did not receive any signal from the data node 1 first attempt. Then it's going to see the second attempt. Then it's going to see the third attempt. Then you see, yes, your data node 1 went down. Your name node did not receive even after third attempt. Then is going to, your name node is going to confirm saying that data node 1 is dead guy. So he's no more active in the networks. No way I can assign any work to this guy actually, right? Going forward, I cannot assign any work to this guy to accommodate my data. At the same time, I should start recovering the data that was there in the data node 1. You are not going to report the data node 1 to recover the data. Your data is what data is available in the data node 1, you know already. Who? You as a name node, you know that one. With the help of metadata, you know that. So now your data node 1 is not going to just accommodate only B1 and is just waiting ideally, right? So for example, this is having 16 terabytes of hard drive means 16 terabytes of blocks you are going to accommodate, right? 16 terabytes of files you are going to accommodate. So thousands of files has to be, thousands of blocks has to be recovered immediately because your data node 1 is not responsive actually. So I'm just giving the example for the B1 from the temp.txt file. The same thing has to be followed for the other files, right? Now you see B1 is available here. So now you see B1 temp.txt file is available in the data node 2 and also data node 4. Your name node knows that one because this metadata is available in this guy. So now B1 has to be recovered either from the data node 2 or data node 4. So at this point of time also, name node is going to check who is having the more bandwidth actually, right? Who is having the more bandwidth, that guy will be picked actually. So in this case, our data node, right? For example, data node 4 is having more bandwidth. Now is going to assign the work to the data node 4 saying that, yes, data node 4, I see block 1 from the temp.txt file. You have to just copy that one into the data node 5. So now B1 from the data node 4, now you are going to copy to the data node 5 as a B1. So now data node 4 has copied the B1 into the data node 5 and you recover the data immediately. You see after 9 seconds, automatically he is able to heal himself actually. You don't have to manually do this process. Automatically this will be taken care by the Hadoop cluster actually. So this is one of the excellent fault tolerance mechanism that we have in our Hadoop cluster. So every name node, data node, how you are sending the heartbeat back to the name node, how your name node is managing the metadata at the cluster level, your data nodes also is going to maintain the metadata at the data node level. So this is called data node metadata. You know the data node metadata is nothing but only the data node metadata, which means what files from what blocks are there from what files, how they are doing, right? Whether the data is real data was there when it's got copied, the same data is there, or it is corrupted. All these things will be available in this metadata. This metadata will be just shared back to the name node actually. So along with your heartbeat, your data node metadata also will be shared back to the name node. So we'll call that one as a block report, BR. Every data node is going to share the metadata from the data node to the name node in terms of block report along with the heartbeat actually. Based on this one only, your main name node metadata will be shuffled accordingly, because earlier data node 1 was having one of the copy from your temp.txt file. Now is it available? It is available with the data node 5. So the moment your data node 5 is sending the block report back to the name node saying that yes, temp.txt file one of the copy is available with him, then your name node has to has to update the metadata to the current one, so that in future request, if someone is locating the temp.txt file, you should be able to give the correct exact location of your blocks actually. So that is called all about the block report. With the block report, you are able to make sure your name node metadata is shuffled up to date actually. Everything is clear. Now your data has been settled. You are maintaining the 3 copies. So now your admin came into the picture and he has looked into this one and there was a network issue and he has fixed, right? He is ready to rock and roll, which means he is ready to take care of your work. There was a network issue and is fixed. So when you say fixed, he is not going to recover the data that was there here. Temp.txt file B1 2000 from your log file, 25,000 from your so and so file. There is no way you can see, you can recover that blocks actually. Simply he is going to really format this file data node, right? He's going to delete the complete data that was there here and is going to act as a fresh machine and is going to accept the new work from the name node. He's not going to even restore the status back here actually. If that is the case, you are going to see a lot of work only for this game. Your data is been recovered and recovered, that's all. So why you have to go again and recover this data, right? Why you have to retain your old status of your B1? Your data has been recovered, that is done, right? So that is all about the how, if one of the machine whichever went down, how you are going to get it back, how you are recovery is going to happen. I hope you are clear. Even for a tricky question, you should be in a position to answer, right friends? So let's proceed further. So these are called, right, multi-node cluster, right? Multiple machines. It is ideal in the production environment. For example, your production is having 20,000 machines. So do you think I need to maintain the 20,000 nodes in my development environment also? Do you think I need to maintain the 20,000 machines in my test environment also? Right? Really not possible. Nowhere you can maintain these many machines in the every environment. So that is the reason you can really develop with any number of machines, and you can deploy that code to any number of machines, and you can run that application with any number of machines. So that is the reason multi-node cluster is ideal only for the production, but in the development environment we are going to use single node cluster, right? Single node cluster is nothing but your all daemons you are going to run in a single machine actually. So name node, secondary name node, data node, job tracker, task tracker, all these daemons you are going to run in a single machine. But what is the purpose of this one? Are you going to get any performance here? The answer is no, you don't get the performance. But what you get the concept wise how it is working, you are going to get, but the performance wise you have to get out of the multi-node cluster actually. So multi-node cluster only can give the performance, but the single node cluster is going to just give you the for the development purpose, that's all. So that is all about the multi-node cluster.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
What you have to do in Oracle VM VirtualBox is click onto the Oracle VM VirtualBox. This is the main link. Okay, and here are the sublinks for different operating systems. I have also given this particular link as well, so look into that. So based on the operating system that you are using, okay, based on the operating systems that you are using, try to click on to any one of those links and a file will get downloaded in your system. Okay, let's say I'm using a Windows operating system. I'll click on to this and there will be a file that will be downloaded. Okay, so after downloading VirtualBox, you just have to double click on that so that to install that particular application. Okay, a double click on that particular application and it will ask you for certain yes or no. So you have to click on next, next, next and continue. Okay, can we use to Hadoop VM setup for Linux? So as far as the downloads with the respect to the VirtualBox, just click on next, next and continue. Do not try to change any of the default settings. Okay, let there be all the default settings as it is. There is no requirement for you to change the default settings. Just click on next, next, next and continue. Okay, and so after installing VirtualBox, please make sure that you have installed it properly. How to check is just go to your search window and just type in Oracle VM VirtualBox. Okay, just by typing initial words, you should be able to see an application that is present in your system. You should see that. Can you see this? This is my downloaded file. This particular is the file. What file? This file. Okay, after we have downloaded successfully, the file should be looking like something like this. Okay, before, okay, if your VirtualBox is not installed, this will be of an unsupported format. So as I have already installed VirtualBox in my system, this will show you some of a supported format. And how can you check whether this is of a supported format? Just double click on it. It will redirect your page to the VirtualBox directly. Okay, it will redirect to that particular application, which is nothing but your Oracle VM VirtualBox. Okay, now you can see the specifications. So basic requirement is, as let's say, as if you have a 8 GB RAM, so we are specifying 4 GB of RAM to my virtual machine. And you also can change also, when you check onto this, you can change the RAM size also, but preferably because you have to have a decent amount of RAM allocated to your virtual machine, we keep all the settings as default. Okay, so let's say if you have a 16 GB, no worries, 4 GB is totally fine for the virtual machine. Just click on to import. As you click onto that, it will require a total of 10 minutes for you to completely import all the things that your downloaded file has. Okay, so as I have already started this will not be showing to you. This is a different virtual, this is the virtual machine which I have already. Okay, when you are starting for the first time, this also will not be there. Okay, I will cancel this because I already have imported everything in this particular thing. Okay, so after importing, after a time span of nearly 7 to 8 minutes, the entire downloaded file will be imported as Ubuntu. Let's start the virtual machine. We have already imported the virtual machine. Let's start just by clicking to start. Please notice that as this is a local on-premise virtual machine, it will take some of the time. Okay, because it has to start a new virtual machine inside your local machine. You have to have some patience before it gets initiated. Start this, you will get this particular window. Okay, it is asking for a validation whether you are for Hadoop. So you have to always select on Hadoop. This is where all your Hadoop frameworks have been installed. Just click on enter. You should be initiating your Ubuntu virtual machine. Yes, finally we have got into our virtual machine. So this is the entire installation process. We also had a file with respect to the commands as well. These are my command files. When you open this, you will see many different commands. Okay, why exactly these are commands? What are these different commands? You will have a basic idea on top of that itself. So start dfs.sh is used to start the Hadoop cluster. So start -yarn is used to start yarn services. So, and also JPS command is used to check the status of all the Hadoop services that is currently being running in the system. Okay, and also there is something with respect to the NameNode from web browser, how you can access the NameNode resource manager, all these things. I will show you how exactly you have to do. And also there is something called as different framework that are available, and according to each command, let's say if you want to start a Hive shell, these are nothing but the basic and the most used commands that is very much important for you to use them in the future, in the upcoming course. So many commands are there. What I ask you is, whenever you are running all the commands, please make sure that you are familiar with the commands usage. Okay, whenever you are executing this particular command, you should know that actual use case of this, which is nothing but to start the Hadoop cluster. Whenever you're using start yarn, you should know that it is starting the yarn service. Similar to that, this again, we are using this pig command to get into the pig shell. Yeah, hive command to get into the hive shell, spark command to get into spark shell. Okay, so now if you ask me where exactly do we execute these commands, let me show you that. So there is a terminal in the virtual machine. Okay, just click on to that. You should be able to access a terminal. So this is your terminal. So where exactly you have to run all the commands? You have to run all the commands in the terminal itself. Let's say your first command is nothing but to start the Hadoop cluster. Get into the terminal, just type in start-dfs.sh, which is the command to start the Hadoop cluster. Click on enter. It will start all the requirement that is necessity with respect to the command. So it will start your name node, data node, secondary name node. Till when you have to wait to get the complete process done is until you get back the same terminal, which is the Hadoop at Intellipaat-Hadoop. Please do not try to execute any other command. It is starting secondary name node as well. Yeah, so not yet we have got that. So we have to wait until it gets back to Hadoop at Intellipaat-Hadoop. So as you can see that we have got back the same Hadoop at Intellipaat-Hadoop. Let's run a few more commands. Let's use this particular command. Let me show that. Start-yarn.sh.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
This is for Mac users, OS Exhaust for Mac users. So yes, we are running the other command, which is start-yarn.sh. Let's that get completed. Okay, and also there is a command called as JPS that will tell me what are the different services that are currently running in my Hadoop environment. So you can see that data node, name node, node manager, resource manager, secondary name node. All these are the services that are currently being running in my system. And also with respect in that command file, there is also something with respect to to access name node from your browser. How is this possible? Is you have to copy this URL, okay, which is nothing but localhost:8088. Okay, this is your URL. So what you have to do is go to the browser that is present in your system, which is nothing but which is nothing but Firefox. Okay, when you click onto that Firefox, it will automatically create a browser it will open up a terminal, which is nothing but a tab with respect to the Windows operating system. In that particular tab, just type in the URL, which is nothing but localhost:8080. What is this 8080? These are specific port number to that particular manager. So here it is talking about the yarn resource manager. So 8080 slash, just type in to that. You should be able to access the name node. Okay, localhost. Okay, let's access the 7870, which is nothing but my name node. So can you see this? We were able to access the name node with the help of a GUI as well, which is like the graphical user interface for the different nodes that we are using. Yeah. Similar to this, there are multiple other ports also, which is 8080 for resource manager, 9864 for default port. Yeah, for the data node. And also to stop the cluster, we also have a command to stop the cluster, which is stop-dfs.sh. Okay, let me also show you some of the frameworks. Okay, let's say if you want to get into a Hive shell, okay, for all the other shells, you can directly get into the Spark shell. Let's say for an example, this is just to show you how exactly to execute different commands to get into some shells. Okay, not to worry if you have no idea with respect to what exactly a Spark shell is, what exactly is a Hive shell. Yeah, so let's say to get into the Spark shell, so the command is spark-shell. Just click on enter. You should be able to access Spark. Okay, it will take you to a different environment, which is nothing but your Spark shell. So we have to wait until it gets completely executed. Yeah, so finally Spark session available as Spark, and now you should be able to access Spark shell. Yeah, can you see this? We were able to get into the Spark shell. So this is the Spark shell, and whatever the commands with respect to Spark or Scala, you will be executing it over here. Yeah, so what if I say to get back to my system portal, which is my terminal portal? So the command to get back to your system portal is Control-C. Okay, so that you will get back to the same port. And yeah, similar to this, let me show you also, there is something called as Hive. Okay, to access Hive shell, first you have to run this particular Hive service metastore. Okay, this is to start your Hive metastore. With the help of accessing this only, you will be able to access Hive. Okay, so let me show you that. So let me clear all this. So first you have to get into Hive service metastore. With the help of this command, you will activate your metastore. Is this the command? Hive service metastore. Yes, this is the command. Okay, this is the command through which you will be able to activate your service metastore. Okay, now see, this will not get this will never get back to the same terminal, which is Hadoop at Intellipaat, showing that yes, the Hive store is activated. So what you have to do is create a new terminal. This is only for Hive. Okay, for all the other things, there is no requirement for you to use two terminals, not at all required. Just for this Hive, in one tab you enable your metastore, and in another tab just click as Hive. That will nothing but get me into the Hive shell. So as I click into Hive, as I get into Hive, you should be able to see my Hive shell. See, yes, we were able to access Hive with the help of Hive command itself. Okay, for that, the only prerequisite is to keep your metastore always active. Do not terminate this particular session and create another one. Just create another terminal and use Hive there.
What is Pig, and is it something similar to Hive? I have heard a lot about Pig, so where it is used, where it is not used. The first thing I'm going to tell about Pig is that, so this might be a little bit confusing, but still, Pig and Hive were invented almost at the same time to solve the same problem, meaning both these tools were invented almost at the same time, and both these tools allow you to solve the same problem. Well, almost the same problem, I can say. In most of the cases where you can use Pig, Hive can also be used. There are some situations where you cannot, but mostly. So you may be asking, then why did you just invent one tool? Why did you invent two tools? If Pig and Hive are almost the same, then why do you have two tools? See, the answer is very simple. Remember the use case of Hive? So Facebook was dealing with massive amount of structured data, and they were running most of their queries and all on Oracle with hand-coded Python, and that was the stage set for the invention of Hive, right? So Facebook had to move to Hadoop, and they had to query the data, and they didn't know what to do. So they practically invented something called Hive. At the same time, Yahoo was facing the same problem, but in a different way. So you see, Yahoo is the company who practically kind of invented Hadoop. They did not invent Hadoop. They basically acquired the Nuts project, actually, but the first stable release of Hadoop actually spun out of Yahoo, right? So when Yahoo had Hadoop, okay, the same problem was there. All right, I want to work with the data in Hadoop, but the only way is MapReduce. That means I have to force my employees to learn Java, then write MapReduce code. What should I do? But Yahoo thought it in a different way, actually. What Yahoo thought was, right, all right, let's create a scripting tool. Let's create a scripting tool which is very easy to learn, so that people will just install it, write their script, and just run it. And the scripting tool is going to convert the script into a series of MapReduce programs, and that is your Apache Pig. So even though Yahoo invented it, later they contributed that to Apache, and it became a top level project. And you will be surprised to know that somewhere around 2013 and 2014, I think around 70% to 80% of ad hoc jobs in the world of Hadoop were achieved only using Pig. Pig is so popular, actually, one of the most popular tool. Well, not very recently, after the invention of Spark, in fact, Pig's popularity is not as we see today, but yes, still Pig is one of the best choice for all the programmers and analyst folks, right? So what exactly is Pig? We will see. So to give you the backdrop, this was invented by Yahoo at the same time when Hive was invented by Facebook. The only problem, these two companies did not talk to each other, right? So they didn't know that they were trying to solve the same problem, and ended up inventing two tools. What is Pig? So it's basically a scripting language used for exploring large data sets. Now it is a new language, which means you will get some time to use to it. So the learning curve of Pig is higher than that of Hive. To put it in another way, if somebody has to learn Hive, it will be much easier since Hive follows SQL and most of us know SQL. You can just get a Hive CLI and start exploring right away. But when you start with Pig, Pig has its own language called Pig Latin. So Pig's language is called Pig Latin, and Pig Latin is a new language. So the syntax, how you use it, all are new. So you'll take some time to get familiar with Pig, but that's all fine. I'm gonna help you to figure out how to learn Pig and how to work with that. That's not a big deal actually. So components of Pig. So actually Pig comes as a package in which you have something called a Pig engine, which runs on top of your Hadoop and converts your code into MapReduce. The language is actually called a Pig Latin. Pig Latin is your language which you're supposed to learn. Now, what are the advantages of Pig? It removes the need of users to tune Hadoop, in the sense like if you're writing a custom MapReduce program, then you might have to fine tune the program, but Pig by default optimizes your code. You can turn on and off the optimization, but by default code optimization is turned on by Pig. So that means Pig will create the best optimized MapReduce code for you, and it insulates the users from Hadoop interface, so you don't have to practically learn MapReduce or Hadoop or anything. So if you're supposed to write some 200 lines of Java code, you can write the same thing in 10 lines of Pig Latin. And the same way, if you try to develop a Java-based MapReduce code in 4 hours, the same can be done in 15 minutes approximately in Pig Latin. So it opens the system to non-Java programmers. Now this we have practically seen. So whenever we are writing a Pig code, it's quite how do I say, fast and easy to work with. Now it's a common way for every scripting language, right? So whether you are into Python or say Ruby or to shell scripting, all scripting languages gives you a couple of more advantages. All scripting languages are short and sweet. They have a lot of built-in functions to use. For example, if you look at Python, n number of packages and functions are available, right? Python codes can be very, very small. It's a scripting language, right? So the same way, Pig also acts like a scripting language. But it's not like your SQL, okay? So SQL is more or less like a query. So there, maybe if I want to pull the certain results from a table, I can write a single complex query and run it and get the result. But here, you might have to write it as a script to interact with Pig. So the next is Pig Latin data flow language. So it actually allows you, regular data types. So you can use long, float, char array, int, etc. So that is all possible. Pig also supports complex data types, which I will come in a moment. It is extensible and supports user-defined functions. So that means if you want to add some functionality to Pig, what you can do is that you can write it in something like Java, right, and call it inside Pig. So that is called user-defined function. I will show you an example of UDF or user-defined function. So you can write your own functions in your language, say Java, and package it as a jar file and register that with Pig so that Pig can use that UDF actually. Pig doesn't need metadata. It can work without metadata, without type declarations or anything. But if you provide Pig with metadata, it will work the same way. But Hive is not like that. If I'm working with Hive, my metastore service must be running. I cannot say that, okay, create a table, now don't use any metadata. It doesn't work that way. Either I have to use my own metadata service or something like H catalog, but metadata is required. For Pig, you don't have to use metadata, but it can use when it is available. It can even share the metadata with other tools like Hive through H catalog. It operates on files in HDFS, we know that. Provides common operations like join, group, filter, sort. So Pig has a lot of built-in functions. So provides common operators like join, group, filter, sort. So the power of Pig actually comes from these built-in operators. That means whenever you want to perform any operation, so you want to do a join operation, you can call the join operator and it will do the join operation for you, right? So this is actually from where the power of Pig comes into help us, right? What are the usage scenarios? So one thing might be web log processing. I will show you a Pig program which actually takes a web log and process it. Now, Pig is very good at string operations as well as regex, your regular expressions. So this can be extremely helpful in situations like web logs. So imagine you have a web server running and it produces a lot of log files. Now the log files will be kind of unstructured. It doesn't follow a particular pattern as such. You can call it semi-structured, but I would like to put it like unstructured data. And if you want to extract something, you can use Pig. So Pig is very good at trim, substring operations, regular expressions, etc., etc. Data processing for web search platforms, ad hoc queries across large data sets. Even Hive can be used for ad hoc queries across large data set. Rapid prototyping of algorithms for processing large data sets. So who all uses Pig? Yahoo, one of the heaviest users of Hadoop, runs 40% of its jobs in Pig. Twitter is also another well-known user of Pig. So Pig is kind of like one of the most widely used ecosystem tool that is available to us. Pig versus Hive. Where Pig and Hive looks exactly the same, right? Then why do you need, or is there a difference actually between them? Yes, there are differences, right? So if I just have to relate this, the major difference might be starting with this, okay? This is so maybe the first point is that Pig is just a client-side application. So there is no Pig server or something, right? So that means, so Hive can have an optional thrift server, and we have seen a Hive server 1, Hive server 2, etc., and where you will be using what, right? But when you look at Pig, Pig is just a client-side application. So there is no Pig server or something. And why is that so? Because Pig is not a data warehouse, and Hive is a data warehouse where you need to create connections for accessing and storing data. Well, Pig doesn't have to have. And one more thing here is there is no JDBC ODBC connectivity, and here it supports connectivity. So that means either using the Beeline client or from your regular SQL clients, you can always connect to a Hive table. Right, so Hive actually supports JDBC drivers, right? So you can directly connect to Hive and do whatever you want to do. But since Pig doesn't work on tables and doesn't work on storage, there is no JDBC ODBC connectivity. So if Pig has to get some data, the data should be in Hadoop, in a folder or somewhere, and it reads the data, transforms the data, and stores it back into Hadoop. That is what it does. There is no table or something inside Pig, right? And Pig is actually used by developers mostly, and here it is used by analyst folks mostly, right? So I mean, it's up to you, but again, mostly Pig is by developers and Hive used by analysts. And here schema is not mandatory. And here schema is mandatory. You need a schema, right? When you create a Hive table, you need to have some sort of a schema at least, right? And also Pig doesn't have a web server. Here you can have an optional web server, a web interface for your Hive. That is possible. So I think these are the obvious differences actually There can be much more, but some of the points that you need to consider, right? Where does actually Pig fit in the scenario, right? So let's say you have a Hadoop cluster. I have a MySQL database maybe, and I have a web server here, and I might have an app server here. So what I can do is that maybe I'm collecting data. So maybe I can bring in Scoop here, which can bring my data from MySQL into a Hadoop, right? And from web server, maybe I will pull the log files using Flume or something. So I'm getting all the logs from here. And here also I'm pulling some logs. So you see, I'm trying to collect multiple types of data, mostly structured and semi-structured. I dump all this data in a folder. Okay, so this is my folder in Hadoop. So what am I doing? I'm collecting data from my RDBMS systems, from my web server logs, maybe from my data warehouses, from multiple places. And then I dump them in a folder in Hadoop. Okay, so now the data is there. Now you may ask me, can I send this data to Hive? Yes, you can, but usually what we do is that once it is in this folder, I will run Pig, which will read the data from here and transform the data and send it back to Hadoop. So maybe, here is my data, right? And this transformed data will be accessed by Hive for reporting purpose. So Pig is actually used as a data factory operator or something which can clean your data. So what happens when you get raw data from the web server logs or from your databases? You may want to clean the data. So the ETL guys can correlate this very well more than that, right? You may have unwanted, information, unwanted marks and traces and cookie related information, robot scrolling information, etc. A lot in the data. So in that case, I may not be in a position to dump this data into Hive, because Hive is my final destination where everything gets stored and my reporting tools can directly connect to Hive table. So what I do, I use Pig for transforming my data, cleaning my data. And once Pig cleans the data, I give the structure to the data, and then that data can be stored in a Hive table. So you see, Pig is not storing anything. It is reading the data, transforming it the data, and storing it back to Hadoop. Another example is this sensor data, weather data. So if you're collecting data from this weather sensors like temperature, etc., I will again show you an example. What happens is that the weather data usually comes in a very specific string format, which is very difficult to decode. So when I have my whole weather data in a folder, Pig can easily get the data, use some string operations to get whatever information you are interested, and then that structured data is stored in another folder so that your Hive can access. So Pig is used as your cleaning operator or data factory operator to give structure to your data and so that it can be stored in Hive. This is the original concept. Now these days, whatever Pig can do, most of the things Hive can also do. Hive can also work as an ETL tool sometimes, but yeah, so Pig can be considered as a typical ETL on top of your Hadoop. Where Pig and Hive fit in the system, right? Where not to use Pig? Well, Pig is not really good at pure unstructured data. For example, you have audio, video, images, etc. In such cases, Pig might not be the right fit. It may not be able to process. So Pig is the best fit use case in terms of structured and semi-structured data. And the next point I wanted to discuss, how come you have a weird name, Pig, for this tool? The guys in Apache are really funny, I believe. I mean, there is something called the philosophy of Pig. If you want, you can read it. The Apache Pig philosophy, wherein Apache explains how they gave the name Pig to this tool. So what Apache says is that, first of all, the animal pig can eat anything. Same way, your Apache Pig can also eat any type of data, mostly structured, semi-structured, and some sort of unstructured. So that means pig will not say no. Anything you give, it will eat, just like the animal. The second point is that the animal pig is easily domesticated, meaning I can have my pig in the house, pig in my farm. So pig is a creature which can fit into any place. Same way, this Apache pig is also a tool which can very well work with different platforms.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
And Apache also says pigs will fly. So in the sense, like, you can write scripts on the fly. So that is the pig philosophy. So this is Apache pig's philosophy. See, pig eat anything, right? Pig lives anywhere. Pigs are domestic animals and pigs fly. So check out the pig's philosophy and understands why it is called as pig. A pig actually supports something called complex data types. So it supports your regular data types, and it also supports a complex data type. So what do you mean by complex data type? There are three of them. One is called a tuple. Tuple is very common even outside the world of pig. Tuple is an ordered set of fields. Think about tuple like a row from a table, and tuples are usually represented like this. For example, 19,2, this is a tuple. Then there is something called bag. A bag is a collection of tuples. Well, the definition is not so correct actually, because a bag can contain tuples. A bag can also contain other bags actually. So bag is an unordered collection. So a bag is a complex data type which can contain tuple, or it can even contain other bags. Map is a key value pair. How to start working with pig? So first things first, you have to understand the data that I'm working on. Otherwise, there is no point, right? So first thing you have to understand is the data. Now it is very common in any big data scenarios. You have to understand your data, then only you can start working with the data. So let me show you the data that I'll be working on. So now we have the data to work with. So there are two set of files. Okay, this is called New York Stock Exchange daily data. This has certain columns. For example, the first column is the exchange name, which is New York Stock Exchange. The second column is called a symbol or ticker. This is the stock name that we are monitoring. Then we have the date. So this is the date column. Then you have opening value, closing value, high, low, total trade volume, and another value, right? So basically this is stock data. So every stock will have opening value, closing value, high, low, total volume sold, etc. And this is a real good piece of data set. It's a public data set because you can do a lot of operations on this data. So this is one data set. The second data set is this. It is a similar data set but with only 4 columns. So this has first the exchange name, NYSE, second the symbol or ticker, third the date, and the last column is dividend. So there are 4 columns. So these are the 2 data sets we will be using initially to understand pig. Now if I go to my desktop, both these data sets are available in my desktop. You can see here NYSE daily and NYSE dividends. So both the data sets are available on my desktop. The first thing you need to understand about pig is that pig can run in 2 modes. One, local mode. 2, MapReduce mode. In this mode, pig will read the data from local file system, transform it, and store it back to local file system. Okay. In this mode, Pig will read the data from HDFS file system, transform it, and then what? Store it back to HDFS file system. So, which means you can run Pig in two modes. There is local mode and MapReduce mode. Local mode means if you start Pig in the local mode, it's going to start it and it will take data from your Linux machine. Basically, it will expect the data from your Linux machine. It will read the data from your Linux machine, right? And it will do whatever transformation you ask it to do and so store it back onto Linux machine, meaning it will not touch Hadoop in the local mode. In the MapReduce mode, the same concept, but it reads the data from HDFS, that is Hadoop, transforms it, stores it back into Hadoop. So MapReduce mode is something we use in production. Local mode is for testing. For example, if you want to create a Pig script and see how it works, what you can do, you can run Pig in the local mode on your laptop. It'll read data from your laptop's hard disk, transform it, store it back on the hard disk. So you'll just experience how Pig works using the local mode, right? You can also do this in the MapReduce mode. So the first thing I'm going to show you is local mode. That means how Pig can read and transform the data and store it in the local file system, right? So in order to start Pig in the local mode, all you need to do is just type pig-x local. Yeah, in local mode, it has nothing to do with Hadoop. And local mode we just use for testing, right? So now I have started the local mode of Pig. How do I know? I see this prompt called grunt. So grunt is the Pig prompt actually, meaning this is the prompt of Pig, right? So here I can type my first Pig command. So this is how a Pig line will look like to you. A line of code, a line of Pig script will look like this to you. So what did I write? First of all, you can see that I have written something called dividends. And there is an equal to symbol, this symbol. So whenever you see this symbol, it means it is a relation. Pig works on something called relation. How do you identify a relation? When you see this equal to symbol, that's a relation. So here I am declaring a relation. I'm saying dividends equals load, this is the file, as exchange symbol date dividend. Now this dividends can be anything. Okay, I just called it as dividends. Okay, you can give any name to that. For example, I can say Raghu equals this. Works. So here what you give doesn't really matter. I mean, it should be something which you remember. By the way, it is not a variable. Pig doesn't have a concept of variable. This is called a relation, not a variable. So now we say Raghu equals load this file. So does that mean there is some data which is getting loaded? No. Load is an operator in Pig, or a function you can call it. What load actually does is that it will create a pointer to the file. Meaning, now I am saying that whenever I call Raghu, Raghu means this file. And this file has 4 columns. I'm naming the columns exchange, symbol, date, and dividend. And you see, I'm not giving any schema, meaning the data type. All I'm telling Pig is that Pig, if I call Raghu, give me this file. And I have 4 columns in the file. These are the headers for 4 columns. That's all I'm doing. Now there are multiple ways to write a relation actually, but remember this, you have to start with a relation to work with Pig. So first step in every Pig script is actually loading the data or pointing to the data, because without the data, how do you work? How do you work without the data? Not possible, right? So now I have created a relation called Raghu, which points to this data, right? And you could have also noticed that when I created the relation, nothing happened. I said Raghu equals to load this. Well, that's fine, right? But did something happen? No, nothing happened, because we call Pig as the lazy operator. Pig, just like the animal pig, is very lazy, right? So to give you an example, let's say you're sitting at home, you with your wife, okay? But imagine you are sitting at home with your wife or with your girlfriend, right? Now your wife comes to you and say that, tomorrow evening, today evening, you have to go out and get something. And she creates a list of things that you have to do. For example, you have to go to the supermarket and buy something. And you have to go to the telephone exchange and pay the bill, maybe. You have to go to the milkman and get the milk. But will you be doing that now? No. Because you are just creating a list of things that you're supposed to do. You are just sitting at your home and your wife says you have to do something.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Right? So what do? You create a list of things you have to do, right? You will say, okay, milkman, go and get 2 liters of milk. After that, what? Supermarket, go and get groceries. After that, what? Telephone exchange, go and get this. X, you create a list of things you to do. But when it is time to do, when it is time to actually go, what you do? You just go out and execute them one by one. That is exactly how Pig will work. So here I'm saying Raghu equals load this data, and I hit enter and nothing happened. Why nothing happened? Because this is like I'm creating a list of to do things. I'm telling Pig that, hey Pig, this is the data called Raghu. So Pig is going to ask me, so what? So what? If this is the data, what should I do? I'm not going to do anything, right? So just for the sake of argument, we'll keep it as dividends. Okay, so you can change it like this. So see, the declarations are completely dynamic, right? So I changed from Raghu to dividend. So now this will be reading it as dividends. So first I declare my relation. Now I don't want you to pay attention to the syntax, but I tell a Pig, Pig, group dividends by symbol. So dividends is my previous relation. I want to group that by symbol column and store it in another relation called grouped. So now what happened? There is a second statement which correlates with the first statement. And still is Pig doing anything? No, it is not doing anything. It is very lazy. It sits idle. Okay. Then I say for each group, that is a previous relation, generate the group number, calculate the average of dividend, store it in a relation called AVG. So I have typed 3 commands here. These are the 3. Or in Pig's terms, 3 relations. And nothing has happened. Why nothing has happened? Each line is red. And Pig will look at it and see whether it has to do something. Yes, it has to do something, but are you asking for the output? No, unless you ask for the output, Pig will not do anything. Pig will sit lazy. So in the first line, I will say, okay, load the data. Second line, I will say, okay, group it by the symbol column. In the third line, I will say, calculate the average of every dividend. Fine. But finally, what should I see? I should see the average, like a print statement in Java, right? So finally you say system.out.println. That is where you see the output, right? So I have not done a print statement for Pig. How do I do a print statement for Pig? I will say dump avg. So dump is a keyword in Pig, which basically says execute this relation. Dump means you're asking Pig to do it or print it or show me the output. Now when you say dump avg, it's going to read this line. It says avg is collected to grouped. So it'll go to this grouped. This is related to dividends. So it'll go to dividends. So it starts executing line by line and show you the result. If I hit enter, a MapReduce job will be fired. Pig executes it line by line and will show me the average. And you do have the average here. All the entire stock average is written. This is how Pig works. I mean, I don't want you to understand the syntax right now, but just the feel of Pig actually. You first create a relation called dividends. Then on that relation you do grouping. On the grouping you calculate average. Then you will say dump average. This is one way of doing that, right? So, but there is a problem with this. The problem is that you're typing the commands line by line. You're typing the commands line by line. And the last line says dump avg. Dump is a keyword which we use to show the result on the screen. And avg is your previous relation, right? So if you don't want to do this, you can just quit from here. You can write it as a script. So what I can do, I can create a new file. I will call this file as testing.pig. So what is the name of the file? Testing.pig. So this is how you create a Pig script. You can give it any name, .pig. And inside this file, I can just write my commands. So let me just copy paste them. So I just created a file called testing.pig. And if I open the file, it has the same 4 statements we had, but written like this, right? Now what I can do, I can say pig-x local. This means I'm running Pig in the local mode, meaning the file will be read from my desktop. My desktop already has the file. And then run the script called testing.pig. If I hit enter, it should execute that. Same thing. And you get your prompt back, right? So either you can work interactively with Pig by launching the shell where you have to type in line by line the commands, or if you are an expert, if you're very good at Pig, you just put all the commands that has to run in a .pig file and run it. Both ways it is fine, right? So what did we learn? We learned that Pig can work in the local mode, right? That means it is reading the data from your local machine and storing it also. Now another thing, if I open this thing, so one problem with this script is that the script will read the data, find the average and show me the result, but it is not storing the result anywhere. If you want to store the result, instead of dump, you can say store average into, then you give a folder name, say April 8. So what am I saying? I'm saying execute the 3 lines and then store avg into a folder called April 8. Now if I run the script, If I run the script, it should run the same way, but should store the result in a folder on my machine. Done, right? So now if I do an ls, there is a new directory called April 8. And if I go to April 8, there is a file called part R. If I open the part R file, here is the result. So either you can ask Pig to show the result on the screen, or you can ask Pig to save the result in a file. Both ways it will work. April 8 will be the folder name it will be creating. Inside the folder, the part R file will be there. Look at here. See, I'm inside the April 8 folder, right? There is also the MapReduce mode of Pig, right? So in MapReduce mode of Pig, what Pig will do, it will read the data from HDFS, do the transformation, store the data back. In order to demonstrate that, I will use the same example, but my data will be in Hadoop. So let me show you that the same data is available in Hadoop first. So this is my Hadoop, right, Hue, and you see this NYSE daily and NYSE dividends are already available in Hadoop, right? So all I need to do, if I want to run Pig in the MapReduce mode, just type Pig and hit enter. Remember previously you used to type pig-x local. Now you have to say just Pig, and you see the same grunt prompt. But there will be a difference. For example, the same command I can say, I will write it again. I have to say load /user /cloudera / so I have to give the Hadoop path here. I have to give the Hadoop path here, right? Now if I want to store, I can say store dividend into, I can say /user /cloudera / a folder name April 8. So this will start the MapReduce job. It's going to store the file into Hadoop to a folder. So you can see that it is creating the jar file and running the MapReduce job, etc., etc. So the MapReduce launcher is done here. You can see it is 0% complete. So it's a proper MapReduce job because you are running in the MapReduce mode. Done. So you see the result, right? And if you go to my Hue, if I go to my Hue, just go back to the same directory again. It should have created a folder called April 8. Here is April 8, and here is the result file. So my point is that running Pig, the commands and all are same in local mode and MapReduce mode, right? If you want to run Pig, it's same, right, in local mode or MapReduce mode, right? Only difference is that, you know, in local mode, you have to give the input path from your Linux and output path in Linux. In MapReduce mode, give the input path in Hadoop, output path in Hadoop. That is the only difference, right? So now we can look at the schema. Look at what I'm doing. If you carefully observe, you will understand what is happening. So first, let me start Pig in the interactive mode, the local mode. I'm going to start Pig in the local mode. That means I have the file in my desktop. I want to read it and do something, right? So I started in the local mode, and what I'm going to do is two things. So first thing is this. I'm going to say dividends equals load the data as exchange char array, symbol char array, date char array, dividend float. So this is explicit data type declaration. Meaning, this is usually how you work with Pig, because you will have the data and you will know the columns and you will know what data type you want. So what you do is that you will tell Pig, hey Pig, load this data called NYSE dividends, which has 4 columns, and these are the data types of all 4 columns. If you do this, Pig will stick with whatever data type you have provided, just like any other programming language. So here I'm saying that these are the data types I want. And how do you know the data type of a relation? You say describe dividends. So when you say describe dividends, it will say that dividends has 4 columns and these are the columns. Now let me do now dividends. Describe here. What I did, I loaded the data saying explicit data type. I said these are the columns, these are the data types. Then I said describe dividends, which will show me the data type for dividends, and it says these are the data types that we have. Then I said dividends equals load NYSE underscore dividends. Let me just, or you can say daily. Okay, so let's take another example. Or you can say this, and you can say describe daily. So I'm just saying that load the file. I'm not giving any schema. So then if I say a describe, what it is going to tell me? So Pig will say schema for daily unknown, because you are not mentioning any schema, right? So now the question is, if I'm just loading the file like this without describing the schema, can I perform some operation on the file? Yes, you can do that. That is the real advantage of Pig. And I think no other tools have this advantage. Very less tools have this advantage. I'm going to show you that. So now what I did, I just loaded the file called New York Stock Exchange Daily. It has like 8 columns. I did not even give the column names or data types or anything. And then I just said describe daily, and Pig tells me that schema is unknown. But you can transform the data. So I loaded the data, and then I'm saying for each daily. So what is daily? Daily is this data, right? Generate $7 by 1000. So $7 is 8th column. So we represent column with numbers, $0, $1, $2. So I am asking Pig to divide every number in the 8th column by 1000. Again, I am asking Pig to multiply every element in the 4th column by 100.0. Then I am asking Pig to extract the first character from the first column. I am also asking Pig to subtract the 7th and 4th column elements in every row. Now leave the syntax. So it is using an operator called for each generate. But basically what I'm asking Pig is that, hey Pig, look at this thing called daily, right? And it has 8 columns. You have not given any column name, that's fine. But it has 8 columns, right? So obviously when you load the data, if the data is tab separated, Pig can read. So Pig expects the data which is tab separated. So every column should be separated by tab. If your data is not tab separated, you can give an argument like comma or whatever you have. But by default, my data is tab separated. So when I say load NYSE daily, Pig will automatically identify every column. It's going to name every column like $0, $1, $2, $3. Then I'm saying for $7 by 1000, that means I want every element in the 8th column to be divided by 1000. Every element in the 4th column to be multiplied by 100.0. And substring operation means from $0, that is the first column, I want a substring 0 to 1, first character. And I also want for every row subtract $6 minus $3. That means 7th column minus 4th column. Now what I am trying to tell you is that you are asking Pig to divide every element in the 8th column by 1000. So when you ask somebody to divide something by 1000, that means that number should be an integer. So Pig will automatically cast it as integer, the 7th column. Again, for the 4th column, you are asking it to multiply by 100.0. So when you say 100.0, multiply something by 100.0, Pig will assume and cast the column as double, data type double. And when you say substring, it will automatically understand that you want to extract characters. So it's going to understand that this is char array, right? But when you say minus $6 minus $3, there can be a confusion because you are asking Pig to do a subtract operation. Now, the subtract operation can be between integers, can be double, can be floating point, right? So for precision, Pig will assume both are floating point and will do the subtraction. Now, if I do a dump of this calcs, you can see it will show the result. See, even without giving any schema, it is able to understand your schema. So the first column is integer because you're asking to divide by 1000. The second column is casted as double. The third is char array. The fourth is again a floating point, right? So I will show you this calc relation once more. Now look at the result, you will understand. So this is what will happen if you do not mention the schema. Ideally, you should mention the schema. So that is another thing. Ideally, for Pig to work on, you should mention the schema. I mean, that is what we do. But in some cases where you don't have the schema as well, you can quickly load the data and transform. For example, imagine you're getting a text file with some 10 columns. All are whole numbers, integer. You can just load it and do all the operations. You don't have to declare any data type. Because, you know, when you say, okay, divide by 1000, it'll understand it is integer by looking at by what number you are dividing and cast it as integer. Let us look at the operators or the syntax in writing. Operators in detail. Right? Now, what is the load operator? The load operator will, like I said, create a relation which will point to your data. So if you look at my data that I was using, it is this NYSE underscore dividends or NYSE. So if I open this data, you see this data is tab separated. The separator is tab. And by default, Pig will understand your data if you're using the tab separator. But what if your data is not having the tab separator? What if your data has comma, right? So what you can do is, if you look at this data, this is the Olympic data set, and this is comma separated data. This is the comma separated data. Now, what can I do with this data if I want to load it? Very simple. All you need to do is, in Pig, you say A equals load, say Olympic using Pig storage. Now I'm saying load Olympic, this is my file, using Pig storage, comma. So you have to say this Pig storage if you're having another type of data. Now I can simply, so this is the load operator. So if I say load Olympic only, it will expect the data to have tab separated values. If I say load Olympic using Pig storage, comma, that means it expects the data with comma. So this is very good if you have CSV files or comma separated values, etc. This is how you can load the data. And just to see whether the data is loaded, do we have a schema? No, there is no schema because we have not mentioned. You can say what? Dump A. It should dump the data and you can see the data. So you see the data is perfectly loaded. So you have to see this using when you're using the load operator. And we also know this store operator, right? If you want to store the result, so this is the load data, then I can say store A into Hadoop folder name, whatever. So you have to create a folder here and it will store. Dump will show you the result on the screen and store will store the data in a folder. So either you can use the load store operator or the dump operator. Dump operator will show on the screen, which is not so good. If you're having like 1 million lines, it's going to throw all the 1 million line on your screen. Rather you say store, it's going to store someplace. In Hadoop, you can give any folder name which you have access to. Relational operators. Okay, we have something called relational operators, right? So now let me show you a couple of examples for this. So I'm going to load another one. I'm going to create a relation here. I'm going to say load NYSE daily as, I'm just giving the column names here. Exchange, symbol, date, open, high, low, close, volume, ADJ, close, right? So I'm going to load that. Now, the first operator you have to be familiar in Pig is the for each operator. So how your for each operator works is that it is going to take every row and apply an operation you are mentioning. So here I'm saying close minus open. So there is a column called close, another column called open, right? So it's kind of like a SQL loop, right? So it's going to apply something like a SQL loop. It's going to go iterate through every record and subtract. What if I want to see whether this is working? What should I do? So I have to dump the operator called gain. So I will say relation called dump gain. And that's it. I can also do much more things. Okay. So now what I did this, right? I can also say C equals prices. I can say for each prices generate $0, $1. And now let me do a dump of C. Did you see what I did just now? I said for each prices generate $0, $1. Right? That means you are just extracting 2 columns. And when I did a dump, what did I get? Exactly 2 columns. So how easy it is to filter, right? I just want 2 columns or 3 columns, You don't have to even cast it. You don't have to say the data type. You just say load for each. That's it. You get. And store it as a separate file. That's it. So this is data transformation. So that is what I'm saying. It is very easy to transform your data. Is this relations case sensitive? That means, okay, A equals load is not same as A equals load. Here I'm saying A equals load abc.txt. And I'm also saying capital A equal load. So small a and capital A are different. So relation names are case sensitive. But I can say either this or this. So the operators like load or for each, either you can use small letters or capital letters, but the relation names are very specific. Now you can also do this. For each operator can be used for mentioning a range. So again, I'm loading the same data, prices, right? And I can do these things. You can say for each prices generate dot open. That means it produces exchange symbol date open, all the columns till open. Or you can say open dot close. That will be open, high, low, close. Or you can say volume dot. That means volume and adj underscore close. So you can mention a range of columns like this. So I say I created a relation called divs. Okay, and I'm loading the same one. And I can say, okay, so here I'm creating a relation, right? And how many columns we have in this relation? Well, it's not called columns in what you say Pig. It's called a record. Sorry, it's called a field actually, not a record. How many fields we have in the divs relation? 4. Exchange, symbol, date, and dividends. So we have 4 fields, right? And look at what I'm doing. I'm saying here.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
A new relation in underscore sense. For each divs, generate dividends into 100 as dividend, comma, dividends into 100.0. So this is a bit confusing the way I write it, right? So I'm saying for each divs, that is my previous relation, generate, I want to multiply this field called dividends into 100 as dividend. So what do you mean by here as dividend? I have written dividends into 100.0 as dividend, again dividends into 100.0. It is the field name. See, what I'm telling to Pig is, multiply every element in dividends column or dividends, what you say, field, right? And store it as something called dividend. So I'm creating a new column or a new field called dividend. But on the second relation, what I'm doing, I'm saying multiply every element in dividends, but I'm not asking to store it as a new column. So what will automatically happen? A dollar will be created. So if I do describe, see, it has a column called dividend, which is double. The second column is just double. There is no column name, and you will be able to access it by $1. Did you understand that? That means whenever you're performing any operation, you have to say as some column name, right? Otherwise, it will create a column with a dollar notation. Okay, let's go to filter. So in filter operator, I will just load the data first. So it says load dividends as exchange carry, symbol carry, date carry, and dividends float. Okay, and I can say filter divs by dividends greater than, I don't know what's the data we have. See, what did I do? First I loaded the data. So data is loaded like this. NYST dividends as exchange, symbol, date, and dividend. Then I can say filter divs. Divs is my previous relation by dividends column greater than 0.14. I want all the rows where, so you can say some column greater than some value, less than some value, equal to some value. And then I did a dump of D. It will dump D and show me all the records where this column is greater than 0.14. So filter operator will take a condition. Filter will say that filter the relation where the column value can be greater than, less than, something, something. Now that will work for integer, floating number, etc. If you are having characters, for example, in this example, first two columns are characters, right? Third is date, leave it. But first two are strings, right? So what I can also do is that I can say what? Filter divs by symbol, which is my column name, matches cm dot star. So that is like matching with an expression. So I want all the records where in the symbol column it starts with cm. If I do a dump, see, all CMO, CMA, CMS, CMI, CMK. All you need to do is that filter a column, either a regular expression or you can say greater than, less than something. That is the filter operator, right? So that's the filter operator. Now you also have a very important operator called grouping operator. Okay, so this grouping operator is very, very, very important in case of Pig. Just see, there are so many operators actually. Let's look at grouping first. Anyway, so first let me load the data. Now you can also load the data like this. Look at here. I'm saying, load NYSE daily as exchange and stock, meaning I'm just using only two columns. I'm just using only two columns. So it will load only two columns, right? I will say group daily by stock. So grouping is a very common operation. We see grouping in SQL, grouping in many places, but grouping works in a very different way in your Pig. So all I'm seeing here is that I want to group the previous relation, which is my data actually, by stock name. So you will expect all the stock names will come together. Yes, it will come together, but in a very specific format. If I do a dump of grpd, okay, so this is the grouping result. Or let me see whether I can get any other data set. So I can say A equals load Olympic, okay, using Pig storage, comma. This is the Olympic data set. And since I did not mention any schema, it's going to load with default schema. Okay. Now I want to access, let's say 0, 1, 2. So I can say B equals group A by 2. So what I'm saying, group A by $2. So what is $2? $2 is the country. I want to group the data based on country. When I say dump B, this is what you will be getting, and this is probably what I want to show you as well. Yeah, so look at this. You have the country name. So let's see a country where there are very less athletes actually. So it's easy for us to identify, right? Look at here. This is one record of grouping operation. This is one record. So here it will have two parts. One is the grouping key, which is the country. So I'm looking at the country called Dominican Republic. Second part is all the records which belong to Dominican Republic. Look at here. So there is one guy who is in Dominican Republic, and there is another guy, there is another guy, there is another guy. So this is how the grouping result will happen. So my point is, when you do grouping operation, the result is like a key value pair. The key will be your grouping key, in this case the country, in my record Dominican Republic. The value will be a bag which contains all the records matching with Dominican Republic. Same way you have Trinidad and Tobago. If you look at here, another country, right? And these are all the values of Trinidad and Tobago. So look at the first element, Trinidad and Tobago. That is the grouping key. Then in a bag, you have all the athletes who are in Trinidad and Tobago. So this is one record, one athlete here, right, from Trinidad, then another athlete here, etc., etc. So what I can then do is, for each B, generate group. I can say something like this, and count, let's say A equals load Olympics. Then I said where is B? B equals to group this. Then I can say C equals for each B, generate group, comma. Then here we are basically what we are doing is actually counting the data. Count. Then I can say dump C. So this statement means we are just loading the data. Fine. Then what did we did? I said group A, which is my original data, by $2. $2 is what? My country column. Then in C, for each B, generate the group name. So I want the country name and count A. So what will be A? A will be my original data, right? A is where I'm loading every record. So it's going to count. So basically, this is going to give me a count of every country. See, New Zealand, there are 51 records. North Korea, there are 21 people. So grouping is very useful in doing things like this. Grouping is very useful in, and for NYSE, you can do the same thing. You can say load NYSE daily as exchange and stock. That means I'm loading exchange and stock. Group the relation called daily by stock. Then I can say for each group, generate, so previous relation group, and then count the daily. So it will count how many are there. So this is how we do the grouping operator. You can also say order by. I say daily equals to load this, right? And I can say order daily by date. So what this will do, it will look at the date column and order that. By default, it will be in the ascending order. You can say descending as well, right? So, so by default, it will be in the ascending order. Okay. You can also do multi-column ordering. I can say order daily by date, comma, symbol. If you want, you can do that also. Okay. And you can say order daily by close descending, comma, open. So this close field will be descending, other will be ascending. Yeah, so here is join operator. So if you want to do join, you can simply load the data and you say divs load as exchange. You can say join daily by simple date, divs by simple date. You can do single column join or multi-column join. Let me just show you this. So I will load the data called daily first, and then I will load the data called divs, and then I can do a join. So this will be normal join, right? You can also do left outer, right outer, full outer, whatever type of join you want. So here I'm saying join daily by symbol comma date, divs by symbol comma date. If I dump J and D, it should have the multi-column join result. See? So this is the join operator. You can also say limits. Okay, so I can say load the data. So here I'm saying load the data. I'm not giving any schema. I can say limit. I can say limit divs 10. Okay, now if I dump first 10, what's going to happen? It's going to show me only 10. So what did I do? Limit divs 10. So the limit operator will limit how many records will be shown. How do I say? A random selection. You cannot say which to limit. So the limit operator actually limits your data, right? What a word count program. Now the first thing I'm going to do is that I'm going to run the word count program, right? And just ensure that it can actually do the word count. We will look at the script later. First, we will run the script and see whether we are getting the result. So I have the script. This is the script actually, which will do the word count for us. And I will explain the script later. As of now, we just have to run the word count program and see what is going to happen. This is the script which has this word count.pig, and all I need to give is the file name, and the file which will be analyzed is this file. This is the file which will be analyzed. Mary had a little lamb, its fleece was white as the snow, and everywhere that Mary went, lamb was sure to go. This is a nursery rhyme, right? So we will do the word count on Mary had a little lamb. So this is the sample data that I have for analysis. So in my script, I have to give this data. So what I'm going to do, I'm going to open my script and I'm going to say that this is what I want to load. And then I'm going to run this first. I'm going to say pig-x local word count.pig. So this is how you run the script. So I'm just going to say that, hey, pig, run this for me, word count.pig, and just show me what it is there, right? I'm just going to hit enter and see whether we are getting the expected result. And we are able to do the word count very well with the script. So it is just a 4-line script that we have, and it actually does the word count. Now compare this with your Java program, the MapReduce program, which was doing word count. It was very complicated to write, right? So this is quite easy to do it. So now, all right. So now let's see what is going to happen. I'm going to just explain the script. Rather than explaining the script, what I will do is that I will run it line by line. If I just run the script, you will not understand anything. So what I'm going to do, I'm going to run it line by line. So to do that, I'm just going to start. Let's analyze the script. This is the first line in my script, and I don't think it needs any explanation. All I'm doing is that I'm loading the data as a single column, a single field. So I'm calling this entire 4 lines of data as a single column or a single field. The name of my column is line. The name of my column is line. Now I'm not mentioning any data type or anything, because since it is a word count, I really don't know what will be the data that I'm getting in. I don't know. So I'll just say that load this data as line. So line is my column name. What is line here? It's a column name, basically, right? Then what I do is I do this. So I will create another relation called words. For each A, that means for every line in my data, generate tokenize the line. So what is line here? Line is the column. So line means, the column which represents your data. Tokenize is a function or an operator in Pig which will extract every word. So basically what tokenize will do, it will pick every word. Flatten means it will create a row for every word. So basically, when you say for each A generate flatten tokenized line, what it is going to do is that it's going to read every line, extract every word, and for every word it's going to form a row. So basically it will arrange all the individual words in a single column. As word means that will be my column header. So think about them like column header. Here line is your column header for your original data, and this is the column header for the transformed data. Now if I do a dump of words, so I'm dumping this relation, okay? So if I'm dumping this, this is what you get. So what that tokenized flatten will do, it's gonna pick every word and arrange them in a column like this. So now I have all the words that I want to count, but I know that Mary is repeating here. So here is Mary in the first row, and again Mary is here. So Mary is repeating 2 times. So if I want to count Mary, I should group them. So the next step will be grouping my data. So I will say that GRPD group words by word. Words is my relation, word is the column name. Okay. Now don't get confused. Words is my relation, word is the column name or column header. So I'm saying that group the relation called words by the column word. Now the column word has all the data. What data? This data. So this is the column which contain word actually. So remember the grouping operator in Pig. So I know that this is my data, I mean the previous relation, and I know that I'm doing grouping. I know that I'm doing grouping, but being a Pig developer, what you should know is how the output of grouping will look like. So to do that, I will do a dump of this relation called GRPD. I'll take a dump of this, and this is how it looks like. Look at an element called Mary. Now this element or this record called Mary has 2 columns. First column is the grouping key, which is Mary. Second column is a bag which contains a tuple, I mean not a tuple, the repetitions of Mary, right? So first is the grouping key, second is the actual number of repetitions of Mary. Same with lamp and snow, sure, they just repeat only once, right? But this is what you need to understand. Now what I need to do is I have to say for each GRPD. So GRPD is my previous relation. For each GRPD, generate group. Generate group. So what is group here? Group will be this first column. And count words. What is words? Words will be this column. So if I apply this, what is going to happen is that it will generate group called Mary and then count 1, 2. 2 times Mary is repeating. Now remember that words is your original relation, right? So this is words, the column called words, remember, so that is where the column which contains all this, data, right? And I grouped it. Then I'm saying that count these words. So basically these words, this Mary is actually part of words, right? So I just want to count this 1, 2, right? And this is group. So if you look at here, see, group words by word, right? For each, generate group. So generate group means it will generate the grouping key and count it. Right now, if you do a dump of CNTD, you have the final result. Right? So always remember the result of a grouping operation has two parts. One part is the grouping key. The second part is the elements that are repeating. So in this case, Mary will become the grouping key and Mary, Mary will be the result. So all you need to do is that, for each generate the group and then count that relation. So it will count how many times it is happened. So this is how you write a word count program in Pig, weather data analysis using Pig. So basically this is string operations actually what we are going to do. Now let me first show you the data, then I'm going to explain what we'll be doing. So this is the data which we are going to analyze. And it doesn't look nice. The data doesn't look nice. Why it doesn't look nice is because it is the weather data. So what do you mean by weather data? So these are the type of data that we get from sensors and all. So this data basically has temperature readings and lot more than that, but we are actually interested in temperature readings, right? Now, if you look at the data, you may think it doesn't have a structure, but it does have a structure, right? But you cannot really put it into a column format and all as of now because the way it is given is kind of like very funny, right? So what we are going to do from this data is this is kind of like unstructured data, semi to unstructured data. We are going to use Pig to extract the information that we want. So I just started Pig in the local mode. And if I look at the commands that I'm doing, okay, so first thing that I'm doing is that, so what's the file name that we have? Let me just check. It is weatherpig.txt. So first thing I'm going to do is that I'm going to load the data. I'm going to say A equals load this data using text loader as data and char array. So basically I'm going to declare this as char array because I want to perform the substring operation. I want to perform the substring operation. So I'm going to declare this as char array for the time being. All right. So then what I'm going to do, I'm going to say for each A generate trim. So trim is an operator which you can use in Pig basically to trim, and then you can say substring from this column called data 6 to 14, 38 to 45, 46 to 53. So what does this mean? So basically I want to extract character position 6 to 14. So where is that? 6 to 14. 0, 1, 2, 3, 4, 5, 6. 6 to 14 will be this data. So since I'm loading it as char array, you know what it will do is that it's gonna get this, right? And this is going to be the date column. So this is the date actually. You can see it is 2013 January 1. Same way I'm gonna extract from 38 to 45, which is minimum temperature, 46 to 53, which is maximum temperature. Now you might naturally ask me, how do you know that this is the data? You have to ask the guy who is giving you the data to understand the data structure, right? So, you know, once I extract that, basically, you know, I can actually dump off this and see how it looked like. Dump AF, and this is how my data looks like now. So now the data is extracted into the date. So date is there, comma, minimum temperature, comma, maximum temperature. So I have this format now for my data, but this is not I want to do. So my use case is different. So what I'm going to do now, I'm going to store this data. So I will say store the data into a folder, right? So how do I know whether a folder is created? So if I do an ls, there is a new folder called data9, right? If I go to this folder called data9, do an ls, there is a part m file. If I cat into this part m file, I have the data. So basically I stored the data in a folder. Okay, so once your data is stored in a folder, what you can do is you can give structure to your data. I can say that possibly this will be data 9.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
I can say load this data which we just extracted using Pig storage comma, because the data is comma separated, as date, minimum, maximum. Now you are creating schema for this data and loading it into the relation called S. So now this relation called S will have 3 columns which you have extracted from the raw data, and these 3 columns are even having specific data types like char array, double, right? So now I have the date, the maximum temperature, and the minimum temperature. And what I can do, very simple. If I want to find the hot days, what I can do, I can say x equals filter s by max greater than 25. So I'm saying that filter the previous relation, okay, by the column called max greater than 25. So I'm assuming that any day which is having a temperature of more than 25 is a hot day. So now if I dump x, I will get all my hot days. So look at this. On the last column, all are more than 25, the max temperature. You can also say min less than 0. You can find the cold days actually. So I can say x equals filter s. S is my previous relation by min column less than 0. Now if I do a dump of x, I should be able to see. So you see the second column in this result, right? All are less than 0. right? So basically that is the condition I have given, right? You can also do a lot of other things. Now these are more towards the statistic stuff, right? This is more towards the statistic stuff. So basically, if you want to find out the hottest day, what you do is that you do a group S all. So I will say, so normally you say group S by the date column, by the minimum column, by the maximum column. But here I'm saying group S all. This is a very special grouping I'm doing. See here. So this is what I want to show you. I'm saying group S all. So normally you say group by. So now if I take a dump of H1, the result will be very interesting. So this is the result. See, group S by all actually means it will create only one result. The key here will be all. Can you see this? The key is going to be all. The values are the entire data that you have. So when you say group S all, so you are asking to group by everything, which is kind of like impossible. So what Pig will do, it will create a key value combination in which the grouping key will be all. All means everything. And the value part will be every element in your relation. See, so this is what happens. And then what I'm doing, I'm saying, for each H1, so that is my previous relation. For each H1, generate max S dot max as maximum. So I'm declaring a new column here. So that is why I'm saying as maximum. I'm using the max function. Okay, S dot max. That means in this, I'm going to find the maximum. So then if I do a dump of this relation, I should see the max value. So that is 34.1. This is the max value that I'm getting. Now, so I'm finding the hottest day. So then all I need to do is that I have to say filter S. S is my original relation by max, that is a column, equals I dot maximum. So I dot maximum will be this. So basically finding the maximum and filtering the data. I want the record where this 34.1 occurs. So that is basically if I do. So if I do a dump of X, this will show me the hottest day. This is the hottest day. 2013, 12th June, maybe. It's a bit complicated to understand, but I guess you got the grip of it. So first I will group S by everything. Then I'll say for each H1 generate maximum, S dot max as maximum. So this will give me the max value. Then I will say filter the S by max equals I dot maximum. So it will show me only that. Same way you can find the coldest day as well. So same way you can find the coldest day as well. Okay, you can just say max of the column and then do the filtering also. Here I wanted to show you this group as all, so that is why I used it this way. Okay, so you can also say that instead of doing this, you can say for each S, generate max of the max column and filter that by I dot maximum. That will also work. S dot max actually means S dot max means in the relation S, the max column. In the relation S, the max column. So what the only thing here we are doing is group S all. This will create a result wherein the grouping key will be all and the values will be everything in your S. So S is your basic data, right? And then I'm saying for each H1 generate the max. Max is my operator. S dot max. S dot max is my column as maximum, right? Then I'm saying that filter S by max equals I dot maximum, right? So this is the way I have written. I suggest you to try a little bit different also and see how it gives you the result. What is the requirement of Hive? You have this guy called RDBMS, right? So let's say you are using MySQL and you are also using, let's say, MS SQL, that is Microsoft SQL, right? And you are also having Oracle. So your organization, let's say, uses 3 databases, right? Now, why are you using 3 of them? I don't know. Maybe you're using Oracle for transactional data, payment, etc., etc. Maybe you're using MySQL to store product catalogs, etc. Maybe you're using Microsoft SQL for some other purpose. So, but just assume that you are having 3 databases, right? Real-time databases. Now, these guys are called RDBMS or database, right? And we also call them a name called OLTP. They are online transaction processing systems. Now, I know that this is too basic, but I'm just trying to give you an idea. So every organization has multiple OLTP systems, maybe single OLTP systems deployed across the world. Now, your manager comes to you and says that, hey, so let's say I'm the employee, so my name is Raghu. Hey, Raghu, we want to do something. You know what? We want to just collect the data from all these databases, and I want to create a nice report and show to my CEO so that I can get a free holiday. So I can impress my CEO with my nice report and all, so I can get a free holiday. Maybe you get a salary hike also. So why don't we pull all the data from these systems and put it into a place and practically create a report out of it? Now, you have guys known as business intelligence guys, BI. So business intelligence is a part wherein you get data and you make sense out of the data. Given any type of data, you can create nice charts, pie diagrams and reports, etc. using business intelligence. There are a lot of BI tools available in the market. For example, we have Pentaho BI, many tools are available, right? So I thought like, all right, so let me do one thing. Let me take a business intelligence tool which can create nice reports and all, and let me install it on my Oracle. Let me also install the tool on Microsoft SQL and MySQL, all 3 databases. But this doesn't make any sense. Why it doesn't make any sense is because you see all these databases are real-time databases. That is why we call them as OLTP. And they are serving your customers in real time. I don't want any unnecessary load on these databases, right? So if I install a reporting tool on top of it and start digging the data, it may impact the performance of these databases. So I don't want to do that, right? So what I do is I bring in the elephant in the room, and that is, my friends, your data warehouse. We call it as DW. You can also call it as OLAP, Online Analytical Processing System. So using ETL, you bring data from your RDBMS systems into your data warehouse. So technically what is happening is that using ETL tools, ETL is extract, transform, load, right? You can take data from your RDBMS systems and dump it into a place called a data warehouse. Now, data warehouse is a fancy term actually. It's not a fancy term, it's a technical term. What is a data warehouse is nothing. Data warehouse is a place where you store, first of all, massive amount of data. Point number 1. Point number 2, this data is ready to be accessed, ready to be reporting. So if I have a BI tool, my BI tool can be directly installed on my data warehouse and it can produce nice reports, etc., etc. And a data warehouse is internal to your company. You don't have public access, because this is your private storage. I'm collecting all the data and dumping into this guy so that this guy holds the whole data, and now I can do whatever I want with my data. Very simple. Organizations were doing this for quite some time. If you go to any enterprise organization, what they do is that they will have multiple OLTP systems. They keep on collecting the data, nightly cron jobs or whatever you want, and then dump it into a data warehouse, right? Now the data warehouse will hold historical data. So this guy has historical data, meaning it will have this year data, last year data, last to last year data, a lot of data, right? And on this data, you can do whatever analysis you want. Very simple. So data warehouse is a place where you store massive amount of data ready for analysis, and you do not typically have public access to this thing, right? And that is. Now, if you look at the players in data warehouse, you have many companies who are doing this. There is somebody called Teradata, which is a major player actually. You also have Oracle Exadata. These are all data warehousing companies, okay? You have SAP HANA. you have Netiza, Greenplum, etc., etc. These are all data warehousing companies. So in your organization, if you want to implement a data warehouse, what you do is that you go to, let's say, Teradata and say that, hey, Teradata, you know what? I want to implement a data warehouse in my company. So Teradata says, all righty, take this and go. So they will give you practically an appliance, like a box, which you install in your company, and then you can load it with data. It stores, you analyze the data. So the question is, why am I talking about this? What is the big deal about this? See, there is no big deal about this, but so far, whatever I was discussing is how the world was working. Now, everything seems nice here. Okay, nice. We have OLTP systems. We take ETL. We dump the data to data warehouse. We produce reports. Nice and happy. But only one major problem. And the problem is this. Dollar, dollar, dollar. Money, money. Okay. The problem is cost aspect. Data warehousing is a costly affair, to be honest with you. Right? For example, if you want to implement a Teradata solution, it will cost you millions of dollars, practically speaking. It is not so easy. Also, it is not so cheap. People who are working in the data warehousing background will be able to comment on this, but data warehousing is a costly affair, right? So that is the backdrop. That is the history that we are talking about. Now enters Hadoop. So here is your Hadoop cluster. So what is this? Your organization has a Hadoop cluster. Now imagine your organization already has a Hadoop cluster. Fine. What is the problem? In a Hadoop cluster, obviously you can store big data. Right. But what happened was that somewhere in 2006, the company called Facebook got interested in Hadoop. So Facebook was dealing with this big data problem. So basically, Facebook was in the growing stage in 2005, 2006, etc. And Facebook was getting a lot of users at that point in time. And Facebook was thinking that, you know what, everything is working fine, but we really don't have a solution for storing big data and analyzing big data. And Facebook was running completely on Oracle. Oracle was their prime backend actually, and Python. Python plus Oracle, that was Facebook's initial architecture, right? Now, somewhere in 2006, somebody told Facebook that, hey, you know what? Why are you so worried about storage of data? There is something new in the market called Hadoop, and if you implement a Hadoop cluster, you can store unlimited data practically, because Hadoop is naturally the solution for big data, right? So Facebook got interested in this idea and they immediately implemented a Hadoop cluster. So practically speaking, the entire data that Facebook was storing and analyzing, they moved into Hadoop. But what was the problem? Back in 2006, we were at Hadoop version 1, or the old Hadoop, or the original Hadoop. And you know what? The original Hadoop had only MapReduce. That means if you want to interact with the data in a Hadoop cluster, the only way was that you must write a MapReduce program. Right? You have to write a MapReduce program. This became a problem for Facebook because every day Facebook needed to fire 70,000 queries, SQL queries. The requirement of Facebook was that every day they had to fire 70,000 SQL queries on their data. And this was working when they were having Oracle. Even though it was slow, they were able to somehow manage, because Oracle is a typical RDBMS. You can easily write 70,000 queries. Now what happened? All of a sudden, the whole data is moved into Hadoop. No more Oracle. So the developers at Facebook faced a serious problem. The problem was that now the entire data is in Hadoop. And Hadoop doesn't understand SQL. Hadoop never understands SQL. What Hadoop understands MapReduce. And if you want to write a MapReduce program, you have to learn Java, you have to write your program, you have to compile it, create a jar file, deploy it. It's not easy. If you're a SQL developer, trust me, learning Java is not going to be so fun for you, right? Because SQL developers, we tend to be, more towards the SQL side of the spectrum. We don't really are not programmers, right? So all of a sudden, all the employees in Facebook started complaining. They said that till yesterday, our SQL queries were working on the data. Today, when I write a SQL query, I'm not able to run the query. What happened? So Facebook said, guys, we just moved everything into Hadoop. Well, that's not justice. That's not just, right? So in Hadoop, you cannot run SQL queries, or you were not able to run SQL queries. Then what was the alternative? The alternative was to write a MapReduce program for a SQL query. And that's practically madness, because for a simple select count star query, you have to write 100 lines of code in Java and compile it.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
And imagine 70,000 queries. So what Facebook did is that they thought, all right, we need a solution for this. We have a lot of structured data in Hadoop, but unfortunately, our developers are not able to access the data. So what we can do? And thus, Hive was born. Hive was created by Facebook. Later, they donated Hive to Apache as a top-level project, but the first Hive version rolled out from Facebook. So the next big question, what exactly is Hive? Imagine you are storing some data in Hadoop, storing structured data. Let's say you're storing a data called sales.txt, a text file called sales.txt. Imagine. And imagine this text file has a structure like, comma separated values, imagine, so they are having order number, product ID, blah, blah, blah. It's a very big file actually. You store it in Hadoop. Now, if you want to analyze this file, you can write a MapReduce program. Or what you can do, you install Hive, right? Now, Hive will give you a shell or a command line. You write SQL on the Hive's command line, right? You say select count star from this table. You write a SQL on Hive's command line, hit return, meaning run the query. What Hive will do, it will convert your query into a MapReduce program, run it in the cluster, and show you the result. That is Hive. Hive is a SQL interface on Hadoop, and it is the default data warehousing framework on top of Apache Hadoop. So what is a data warehouse? A data warehouse is nothing, a huge storage with a SQL interface. Data warehouse is huge storage with SQL interface. Now you already have Hadoop, which is huge storage. You install Hive, you get a SQL interface. You practically create a data warehouse with zero investment. That is the advantage of Hive. Hive is free. You just install it. You can start writing SQL and you can access structured data using SQL. You can do all your regular operations, creation of tables, left outer join, right outer join, group by queries, blah, blah, blah. That is Hive. Now, what is the difference between Hive and HBase? Now, Hive is what we are seeing right now. HBase is your default NoSQL database on top of Hadoop. But remember, HBase is the default Apache NoSQL database on top of Hadoop, right? The real question is that why somebody should use Hive? You should use Hive. Say, for example, I don't want to learn Java. I don't want to learn MapReduce. I'm not a programmer. I know SQL. Then Hive is your choice because it just understands SQL and it will automatically convert that into MapReduce so that you don't have to sit and learn Java and MapReduce. You write your logic in SQL and it works. Imagine you have an Android mobile phone, right? Now what happens is that in the Android mobile phone, when you're buying a mobile phone, obviously, right, you get a default calling option, messaging option, etc. You can call people, you can text people, you can do a lot of things with an Android mobile phone. But you can also download apps. For example, if I want to catch a taxi, I will download and install Uber. If I want to check WhatsApp, I will download and install WhatsApp. Similarly, Hive is a tool which you have to install on top of Hadoop. So that is why it is called as an ecosystem tool. Ecosystem tool means tools which can be installed on top of Hadoop. Think about Hadoop like your Android operating system and Hive like Uber app you are installing on top of that, right? So Hive can talk to Hadoop. It gets installed on top of Hadoop. Point number one, right? Now, another point, where is Hive, right? So the first question is, where is Hive getting installed? Is it inside the cluster? Is it outside the cluster? Is it on top of my head? I don't know, right? Where are you installing Hive? So I have a Hadoop cluster, right? Now the point you have to understand is that Hive doesn't have any storage. Hive doesn't have any storage. For example, let's say you're copying a data. So I'm copying a data called, let's say, transaction.xls. It's a spreadsheet. I'm copying a file called transaction.xls. Now what happens in my Hadoop, this gets divided into blocks in data nodes. We are all familiar with this, right? When you copy the data, what happens? The data gets divided into blocks on my Hadoop, right? So in Hive, when you say create a table and load the data, Hive will refer to this data which is lying as blocks on your data nodes. It doesn't have its own storage. Very important point. So Hive is just giving you a projection of your data. Your original data is lying as blocks in data nodes. And when in Hive you say create a table, you're just giving a structure to the data so that you can see the data in the form of a table. Clear? So Hive doesn't use any storage, right? The second point you need to understand is that if I am sitting here, okay, and I have a laptop or a desktop, Hive is a client-side application. For the time being, I will explain more about this, meaning Hive gets installed on your laptop, not in the Hadoop cluster. Now there is a slight variation to this, but for the time being, let's assume like this. That means, and your laptop is obviously connected to the cluster. You will have Hadoop client libraries, so your laptop can access the Hadoop cluster. So Hive is a client-side application. That means you install Hive on your laptop, open the Hive shell, you will say create table, and you will give some schema, whatever schema you want. Okay, then you will say insert the data into the table. Now what is this data you are inserting? This data is these blocks, that's what I'm saying. You are not inserting anything. When you say insert the data, Hive will just refer to these blocks in your Hadoop. And then you say do a group by query or some SQL query. What Hive will do, it will generate the jar file, right, and send it to the Hadoop cluster. So for Hadoop, there is nothing called Hive. For Hadoop, it is just a MapReduce program. Let's understand that Hive is a client-side application. That means you install Hive on your laptop. And why are you installing Hive on your laptop? Because you don't know MapReduce. And you are a SQL developer. And you know that there is structured data in Hadoop. You want to create a table out of the data and do the queries. So you install Hive on your laptop, say create a table, load the data, write your query, hit enter. Hive will automatically write the equivalent MapReduce program, create a jar file, send it to the cluster. So from the point of view of the Hadoop cluster, it is a regular MapReduce program. It's not Hive. Hadoop doesn't understand Hive. Hadoop understands MapReduce. So either you can write MapReduce, create a jar, say run. Or you write in Hive, Hive is also going to create a jar and say run, same thing. That means Hive doesn't have its own storage or anything. It is just accessing the data in Hadoop and giving a projection so that it is easy for you to work with. Now, you cannot work on blocks or data nodes and all. If you can see your whole data in a table, it's easy for you to write queries, right? And that is Hive giving you. It is giving you a projection of structured data stored in Hadoop. That's it. So Hive understands your SQL, even though Hive's language is called Hive Query Language, or we call it as HQL. It is pretty much similar to SQL. So that means if you're a SQL developer, you know SQL queries, you can easily start working on Hive. Introduction of Hive. Hive is a data warehouse infrastructure that is built on top of Hadoop. Hive provides a mechanism to project structure on the data using SQL-like language called HiveQL. Hive uses MapReduce and HDFS for processing and storage retrieval of data. Now that we understand, the data is in HDFS, processing is done by MapReduce. Now there is a small point here. It's not exactly MapReduce, right? But for the time being, let's keep it as MapReduce. The advantages of using Hive, it can be used as an ETL tool in the sense you can bring data to a Hive table, modify the data, store it as permanently. It provides capability of querying and analysis. So Hive is actually used by the analyst community who is very good at SQL, can handle large data sets, and you can do filters, join, group by, all these SQL queries on top of map and reduce. Now, if you ask me, can I see the MapReduce code created by Hive? No, you cannot see. So the MapReduce code created by Hive is not visible. You will just get a jar file. You won't even see the jar file. You will see the jar file running, right? Now, the most important point you have to remember is that Hive is expected to be slow. It is slow because ultimately it is MapReduce. It's not like your Oracle or MySQL or something, because in any RDBMS systems, typically when you write a query, you will expect the results within microsecond. In Hive, when you write a query, sometimes I have seen queries taking 4 hours, 5 hours. Why? Because, you know, it's just an illusion. Where not to use Hive. So this is very important point. Where you should not be using Hive. Hive should not be used if the data does not cross gigabytes. That means if you are not having big data.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Hadoop Hive data analysis. The data set is going to be a Facebook data set. All right, so let us begin now. So we're going to get to the hands-on section where we are actually going to use Hive to analyze some Facebook data. But before that, for the people who are not from a big data background or a data analytics background, just to give you guys a little bit of background information of the technology that we're going to be using today. So let's begin with that. So in the agenda, firstly, we're going to understand what data warehousing is, because Hive is a data warehousing technology. We're going to understand what Hive is and how does Hive work in the context of big data and Hadoop as the environment for Hive. And finally, the environment that I am going to be using for this particular tutorial, we're going to discuss that as well, what specifications I am using. And then eventually the hands-on tutorial, which is the Facebook data analysis. So what is data warehousing, right? So it is basically the process of building and utilizing a data warehouse to derive insights from data, right? So a data warehouse is essentially built when data is collected from multiple sources. So data is not only coming from one source, it's coming from multiple sources. To explain that in more depth, imagine that you have an e-commerce business, right? You're running an e-commerce business. So a lot of users come in and log into your website, create their accounts on your website. So they're generating customer data. So that is in a database. The table is called customer maybe. That is the table in their database, right? And then there is the sales data for the inside employees, the sales team and the higher management. They have access to the sales data. So whatever transactions the customers are making, they're also generating sales data from that, and that is also a separate database. So what a data warehouse will do for you, the data warehouse will become the de facto aggregation of all of this data. So you don't need to separately access the customer data and separately access the sales data. Imagine you're from a non-technical background, or you're in higher management, and you want the combination of all of the data together. You don't want to get into accessing the customer data separately or the sales data separately. So you'll run this data through an ETL tool. An ETL tool is a abbreviation for extract, transform, and load, which basically means that you're preparing the data, you're cleaning the data, you're transforming the data in a manner that is understandable by people, right? So once the data has been extracted, transformed, and loaded into your data warehouse, you can now access it, right? So that is what a data warehouse is. And then the further teams like the business analytics team can take that data from the data warehouse and generate their reports, annual sales reports, or predictive analytics, or just analytics in general, anything that you would like, just the insights and reports from that. So that is the advantage of data warehousing. You don't need to access all of these data sets separately. So what is Hive? Now that we know what a data warehousing is, what we definitely need tools for that, right? There will be a lot of data warehousing tools. So one of them is Hive. But with Hive, your the use case is big data, basically. So Apache Hive is a data warehousing tool built on top of Apache Hadoop, basically. So Hive was built by Facebook, just to give you a little bit of trivia. So they needed a solution for their big data problem because Facebook has a lot of users. So on top of Apache Hadoop, which is an open source technology, they built Apache Hive so that they can basically warehouse all of the data together and perform their analytics and business insights and whatnot. So yeah, Hive is built on top of Apache Hadoop, and it's a data warehousing solution for big data. So how does Hive work? So Hive provides an SQL-like interface, which is an abstracted query language, which we call HiveQL. So HiveQL is basically SQL, but it's just working in the data warehousing tool, which we call Hive. So you can basically write SQL-like statements, and it would run as such to query the data stored in databases and file systems that are integrated with Hadoop, right? So that is the original definition of Hive. And Hive supports the analysis of large data sets stored in the HDFS. So HDFS is the Hadoop distributed file system. So Hadoop runs the file system on its own, where it stores all of the data. So the big data is stored in HDFS, right? So Hive supports the analysis of this data. So you can take all of this data, like you can take the customer data and sales data from the HDFS, combine it together, and create a data warehouse from it using Hive. But nowadays, Hive also supports other file systems like Amazon S3 and Alexio, and a few more as well. Because as times evolve, you need to evolve your compatibility as well. Because there are a lot of distributed file systems as well, which have come up ever since Hadoop came out with the original HDFS. So Hive needs to be updated accordingly. So in my case, what we are going to be doing, we are going to have the HDFS, which is the Hadoop distributed file system, and we can have any sort of data set within that that distributed file system. It could be JSON, CSV, TXT, for that matter, and it's within this file system, right? We're going to put it through Hive, and then Hive runs on top of Hadoop. So Hive also takes advantage of Hadoop's processing tool, which is Hadoop MapReduce. So Hive takes advantage of that to calculate its queries, and then we finally get our results or insights or reports. So yeah, let us continue now. So the environment that I am going to be using is going to consist of VMware. So I'm going to be using a virtual machine, and I'm going to be running CentOS on top of that virtual machine. CentOS, for those of you who don't know, is a Linux operating system, and we're going to be using that. And on top of CentOS, we already have Hadoop and Hive installed. So we're going to be using all of these 4 tools for our little analysis that we're going to be doing today. So let's now move on to the hands-on section, right? So let us look at the data set first that we have. So this is the Facebook dataset that I downloaded from Kaggle basically, right? So let us see what data it contains. So we can see that there's a user ID, which is the primary key. So this is the primary key for our data, right? This is unique and not a relevant column at all for our analysis because we wouldn't be needing this. We have age, so this is the age of the user who has created their account on Facebook. This is their date of birth, the year and month. This is their gender, and this is how long they've been on Facebook. So I think this is in the not entirely sure what unit of time this is, but this is the length of how long they've been on Facebook. So I'm assuming this can be days because it cannot be 266 months. It has to be days. And the friends count. So how many friends they have. So right now you can see 0, but as we move down, there are a lot of friends as well on their accounts. And how many friend requests have they sent to other accounts, friendships initiated, how many likes they've made. So in their time operating Facebook, how many posts and statuses and how many basically things they've liked on Facebook and how many likes they have received. And to further subdivide that, we also have how many likes they've received through mobile phones, how many likes they've received through web browser as well, which is the www_like. So basically a standard data set, a user data set that Facebook can make public or has made public. So we'll be solving some industry level question sets that would come out of this data set that your employer may ask of you if you're dealing with Hive or big data in general, right? So let us just open up our virtual machine, expand this and log into my account. So I already have Hadoop and Hive installed on top of this CentOS machine. So yeah, all right. So first thing that we would do is actually look at the data set. So here we have our data set. Where is it? Yeah, so here's our data set, which is our sudo_facebook.csv. So if I open that up, you can see that it's in the form of comma separated values. So comma is the delimiter between all of these values. And you might be noticing that I've removed the topmost row, which would have contained all the column names. So the reason I've done that because Hive is kind of buggy with headers, right? So even if you set the header to off, it still takes the headers for some reason. So it kind of messes up with the final result, although not by much, but it does mess it up. So that is why I've removed the top row entirely for that reason. And we have the data from below of that. So we can see right from here we have our data, right? The 266 over here, and we have it over here as well. So 266. Yeah. So this is the data that we have. So let's now begin. All right. First thing that I would do is actually transfer this data set that I have, which is the sudo facebook.csv, into my HDFS, which is my Hadoop distributed file system. So it's the same thing. Even if I were dealing with with a huge big data cluster, I would be doing the same thing. So I'll open up the terminal and I'll just expand so that you guys can see the text. Yeah. So the first thing that I would do is type in Hadoop FS. The moment I type Hadoop FS, what we're doing is now we're dealing with the Hadoop file system, not with the local file system that this Linux virtual machine has. And firstly, I'm going to create a folder. And within this folder, I'm going to add this data set. So mkdir, the make directory. And in the present working directory, I'll create a folder. I'll call this folder Facebook data. So let us call this folder Facebook data. When I press enter, the folder has now been created. So now what I want to do, I'll simply, when I minimize this, I'll simply remember this name, which is sudo_facebook.csv, and I'll put it into that folder, right? So if I type in Hadoop fs put, so the first parameter for this would be the file on the local file system. So on the Linux, it's in the present working directory. It's sudo, what was it? I forgot. Sudo_Facebook. sudo underscore Facebook dot CSV. This is the file, and I want to put it in Facebook data. So this is the folder that we just created within our HDFS, and I press enter, and then it gets uploaded onto that folder. So verify that, type in Hadoop FS, and just like you type in Linux, type in ls and type in the folder name, which is Facebook data. Press enter. And we can see that we have our sudo Facebook CSV within our Facebook data folder. So we've successfully uploaded it into our distributed file system. And now Hive can access it. Now it's within the HDFS. Now we can data warehouse it. There are some questions about how to do it in Windows. So Windows is not the suitable operating system to run Hadoop. Although if you just simply do a Google search, you will be able to see where I think we have that video on our YouTube channel as well. So be sure to check that out. We have that video, how to install Hadoop on Windows. So be sure to check that out to get your doubts resolved in that regard. Yeah, and type in Intellipaat in the search to access that. But it's not recommended. It will generally the practice is doing it on cloud or doing it on a Linux server. So when you're working for an organization, the organization would be following either of two things, right? The first thing that the organization may be following is actually renting a server and manually installing Hadoop on top of it and having a team dedicated to maintaining the Hadoop infrastructure. The second is using cloud services like Google Cloud, AWS, or Microsoft Azure. All right, so enough questions. Let us just get to the second phase, which is minimizing this and opening up another terminal, expanding this. You can do that. So these are all the data warehouses that have been created earlier for various other purposes. So let us create a new database, right? So or just use something like the default. I'll use the default one at least. Use trial. Let us use the trial database. Right? And once we do that, we would be within the trial database, just like in SQL, right? And now whatever we do, whatever tables we create, whatever data warehousing we do, and put the values into the tables, we would be doing within the trial database, right? So let's now look at the data set actually, and just write our commands accordingly. So we'll have to look at the column. So I'll just simply put it on the side and put it like this. Yeah. So I think the best way to go about it is actually first, just a moment, writing the entire table creation statement down into a document, because when the line changes within the terminal, within the Hive is kind of buggy with that. Whenever you change the line in the terminal, it sort of writes the text in a weird fashion. So that is why I want to write the entire command within a document first before I actually execute it on Hive. So let's call this Hive command. Open this up and let's write our table creation statement. So create table like in SQL. And we will have to call the table something. So let us call the table FB, right, for Facebook. Open it up. So the user ID, let us look at the user ID. It is an integer value. It's not a big int. It's the number of digits is almost consistent, not a big int. And the user ID would be integer in that case. So we simply type in ID, which would be the name of the column, and int, which would be the data type of this particular column. Right. So the first column is done. Let us look at the second column, age. Int, no issues with that. Age is integer. Then we have date of birth, day. So let's call this day, and the obviously the value would be integer because it's 1 to 31. And we have a date of birth year, so that is integer as well. So year, int, right? Date of birth, month, so that is integer as well. So let's call this month and call it int. So now we're on to gender. So gender is not an integer. So we'll simply type in gender. And that would be a string. So gender would be a string, male, female, that would come under string. Tenure, tenure can come into integer. So let us type in tenure, type in int. Friend count, definitely integer. Let's call this friends. Let's call it that. We don't have to be since we are not actually matching any headers right now. These column names are irrelevant. We can name the columns whatever we want on our end, right? So that is another advantage of data warehousing. You're not limited by what the database is, right? You can simply manipulate it according to your needs and create new columns as well. So friends would be integer and friend count. Okay, friend count has been done. Friendships initiated. So friend spelling error. Yeah. Okay, friend underscore init, and that would be integer as well. So let's go furthermore. So what do we have after friends initiated? We have likes. So likes, simply just a moment. Likes would be integer as well. Likes underscore received. Let's call it likes underscore RECD. That would be integer as well. So we're now in the second line. So this is where if we were doing it in the terminal, we would have faced an issue. So that is int, likes received is int. Then we have mobile likes. So let's call this m likes, and that would be int as well. And then we have mobile likes received, which is m likes RECD int. Then we have website likes. So website like, and that is int. Well, website likes underscore received, that is integer as well. And any more data? Okay, that would be it. So we close the bracket off because this would be the template for our table creation. Now what? Now we have to specify that these values are actually separated by commas. You are currently seeing the data in an Excel sheet. So this is actually a CSV data format, but the Excel automatically creates the tables and everything, creates the columns and everything. So you're not actually seeing it in that fashion, but it's actually comma separated. If you opened it up with a text file, you will see that it's comma separated. So firstly, we have to specify that the row format is delimited, right? Which means that the row is delimited by a particular character, and fields are fields terminated by. So now you have to specify the delimiter. What is delimiting these particular data points? So in our case, it's comma. So comma is the one, since it's a comma separated file, comma is the thing that is separating all of these data points, right? So this is there. So now we have to reference to our source of data. So the source of data is in the HDFS, right? So we have to type in stored as text file, because our data is stored as a text file over there. Location. Now we have to put in the location that we have, right? So location would be the absolute path to our Facebook data, right? So in my HDFS, it's user training. If I go back just a moment, yeah, user training, and within that, if I simply open up my other terminal again, just a moment, yeah, this one. So I can see the folder name is called Facebook data, and yeah, we only need to refer to that to get our data. So we get back there, yeah. So Facebook data, and put in a slash over there just to specify that all of the data that is within this particular directory will be picked up. So Doesn't matter even if there were multiple files, right, within the Facebook data folder, they would have been picked up as well. So right now we only have one file though. So we copy this, Control+C, and we go back to our Hive terminal. We expand this and we paste it over here, right? If I simply scroll to the side and put in a semicolon over here and press enter, then if I scroll back, I can see that the query is okay and the time taken is 0.756 seconds. Now we have warehoused the data from here. We had our HDFS server and we created a folder within that HDFS server, and we had our CSV file within this. We uploaded it, right? This is our big data. This could be gigabytes to terabytes to petabytes of data within this Facebook data folder. Does not matter. We would do the exact same thing for that as well. But except Hive is very well suited to deal with large amounts of data, depending on the server, depending on the big data cluster that you have. Okay. So let us now type in select asterisk from FB and limit the number of values to 2 so that we don't entirely flood the entire terminal with data, because there were a lot of data points. And press semicolon, we do that, we get our first 2 rows of data. So these are the questions that we're going to be solving today. Are you guys able to see? We have headers in our create command, but Hive is not showing. Basically what happens is in Hive, you have to basically set that parameter to show the headers, right? So with this particular version of Hive, it's kind of buggy because it works sometimes, it does not work other times, right? So that is why I removed the headers from my data set in the first place. And for that reason also, you go into the particular options that Hive has, you set a particular value to true, and then the headers display. But for our use case, we wouldn't be needing that. So I'm not doing it right now. Although it's kind of buggy, so I'm not entirely sure it would happen at all in the first place. But in Spark, all of these problems do not exist. In Hive, they somewhat exist because Hive is an older technology in comparison with the newer ones, where these problems do not exist. Find out the total number of users in this data set. So for those of you who are from an SQL background, this is a pretty easy question. This is one of the most basic questions that are ever asked, and the answer to that is quite simple. So what would be the total number of users, right? So you simply have to run a count on the number of rows in the data set. Simply you have to do that because each row corresponds to one user, and if you count the total number of rows, you will get the total number of users. So quite simple, quite straightforward. So let me do that. So the way you would do that is select, and like SQL, you would type in count, and within count, you'll give in the asterisk so that you count everything that is there. So asterisk is indicative of everything. And then you give in the table name from FB, right? So that is the table name. Put in a semicolon, press enter. Now the fun part begins. We can see that it's not actually doing it normally. It's running a MapReduce job, right? So right now you might be thinking this is kind of futile for a 5 megabyte data set, but that's where you're wrong. The thing is, when you're dealing with terabytes of data set, it would take the exact same time, right? So you might not be quite impressed with how much time it took to analyze this 5 megabytes of data, but even if we are dealing with terabytes of data, it would take the exact amount of time and give us the results, right? Like 15 seconds in this case. So that is quite a good speed for when you're analyzing big data. All right, so let us look at the other questions, which is find out the number of Facebook users above the age of 25. So again, your employer can ask you, depending on whether the business analysts in your organization are doing a market study. So you're working as a data analyst, a big data analyst in their department under them. So what they'll ask of you is, please find this out for me. Please find out the number of Facebook users who are above the age of 25. We're doing a survey. We're doing a statistical analysis of our market base. So you need to find that out, and much more complex queries as well in that regard. So let me just do that as well. So we just simply have to look at the column, which is this age column, right? And we simply have to find out all of the count, which is above the age of 25, right? Quite straightforward. I think some people are also able to answer it. Yeah. So Nitin is able to answer it. He's also taken up our course as well in big data. So let us just do that. Select. So how do we do? How do we go about it? We go about it like count. We calculate the count over here from FP as well as our table name. But here we're not simply doing that. We're also adding a clause. So that's a where clause, and where age, which is an integer value, is greater. So is that greater? Above the age of 25. Yes, it's not. It's greater. It's not greater than equal to. And then we press a semicolon. A MapReduce job will start. And once the MapReduce job has finished executing, we'll get our result as well. So by the way, we didn't discuss the result of the previous question. We had about 99,003 records, which were those were the number of users that were available in our data set. So that was 99,003. So that was the result over there. We didn't actually discuss that. And right now we can see that the number of users who are above the age of 25 are 56,676, quite straightforward, right? All right. Let me look at some questions. How do we download the data from Facebook? I simply Googled Facebook dataset on Kaggle, and the first result that came up was of Kaggle. So it was a 5 megabyte dataset, so I downloaded it from there. You can do the same as well. Datasets are quite abundant. Obviously, you cannot get the deeper insights data of Facebook. All of the organizations keep it secret. You can only have access to the datasets that they've actually made public. So in the case of Facebook, you have this. In the case of Amazon, you have their product reviews dataset that they make public, but they do not make any other dataset public. So you have all of those things. The total number of users are distinct. Yes, they are distinct. So the reason I know they are distinct is because each row has a unique user ID. So this is the primary key, right? Essentially, and the primary key ensures that all of the rows are distinct because all of these rows are corresponding to new users on Facebook. I mean, it's basically corresponding to unique users on Facebook, not new users on Facebook, unique users on Facebook. Okay, when we did the first query, we did not run the MapReduce process. No, we actually did. What was the first query that we did? Yeah, so select does not require MapReduce, right? We don't require MapReduce for select because we've already warehoused the data. It's basically showing what we have. Whenever we are calculating anything, right? For in this case, this is a calculation. This is a function. Count is a function that is present in HiveQL, right? So that is a function. And whenever there is a calculation involved, Hive knows that it has to perform MapReduce to actually perform that calculation in a much faster amount of time, in a parallel amount of time, so that it can run that query across all of the data nodes that are there. So yeah, so say the file sudo Facebook CSV was divided into 3 parts and put on 3 systems, right? And all of those 3 systems are connected together. So what would happen is on one system, 1/3 of this particular MapReduce job will run on the other system, 1/3, and on the other system 1/3 as well. So that way we are reducing the time in which the entire operation would have been executed on one system. So essentially by the third of the time, we are basically taking third of the time. All right, so let us look at the next question, which is do male Facebook users tend to have more friends or female users? So these are also some questions that your employers can ask of you. So basic questions. As you can see here, the employer is not exactly telling you what to do. So he's just basically asking you a question. You have the data set and you need to think about what you have to do over here. So this is where your analytical brain comes in. So basically what will happen is my approach to this is my approach. You can take another approach to this depending on the data that you have. My approach to this would be, I would calculate the average. I would calculate the average friends that a male Facebook user has, and then I would calculate the average friends that a female user has, right? We can do it in one step, but I'll do it in 2 steps just to show you guys. Yeah, so let us do that first. Select, and let's look at the table names that we have. So select, what would we be doing here? We would be dealing with gender. firstly. So let's deal with gender first, and then we would be dealing with what would be dealing with more friends. So we would be dealing with the number of friends. So gender and friends are two column names that we are dealing with right now. So select how would we go about it? Average. So average is a function in SQL. You can also use group by in it. I'll be using it in another question that would be following this. Firstly, I'll show you without using group by. So what I would be doing here is calculating the average of friends. So I would type in friends.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
From FP. So that would be the entirety of it, but I need to add a clause over here. So firstly, I want to calculate the male. So where gender. So we are adding a where clause where gender equals to. Now we cannot simply type in male. That is something you not do. You have to type in equals to, and you have to put in a single quote or a double quote. It's a string value, and you have to type in male. When you do that, and you press semicolon and you press enter, that will start a MapReduce job, and it will only calculate the average of the friends where the gender is male, basically. So at an average, we get about 165 for male, right? So let us do that for female. Bring the previous statement up and change this over to female, right? And press enter. So let us see which particular gender has more friends on an average. I'm betting on female. So yeah, we can see that there is a quite a difference. We can see that in the male it's about 165, and in the female it's about 241. So even if you're doing as a businessman, right? You imagine you own Facebook, right? So you're calculating as to which target audience is more marketable, right? You want to market your product towards females more because they tend to be more active on social media according to statistics. It's just basic mathematics, right? So this is how business analysts basically get their insights, and then they forward their insights to the marketing team, and then the marketing team does what they have to do. So that is how these businesses are so successful, like these Amazon and Google and Microsoft and whatnot, basically. Yeah. So yeah, a lot of banter going on in the questions as well. Yeah. So let us focus on the next question. So firstly, I'll just do the group by ones to just show you guys how to do it all together. So we do the average of friends, and we also take another column, say gender, right? So in order to group by, you need to select gender as well in the column in the selection bar. Otherwise, it wouldn't actually register in the group by, right? So you do that, and then you type in at the end instead of where, you type in group by gender. Right? You do that, and I think that should work. And press enter. So that would start another MapReduce job, but we will get both of these results together. So Facebook has three options actually. So we have male, we have female, and there's the one option that is basically not disclosing, right? So we can see that male has 165 as we discussed before, female has 245, and the not disclosed would be 184, right? So this is basically we have this in order of group by. So that is how you use group by and get all of the results at one, and that's at once, and that is how you'll basically do it, right? So let's look at how many likes do young people receive on Facebook opposed to older members on Facebook. So naturally, I think you have some idea of this answer. So this analysis is basically about, are younger people on Facebook receiving more likes than older people on Facebook, right? So I think they do. So let us just verify that for once. So here also we'll do average. At least that is my approach. You can use other approaches as well. Whatever your approach would be, you can also use sum, but that would not give you the exact mean of the data. It will just give you the total of that. So one person could be an outlier. So it's not exactly a good parameter to base your entire decision on. because one person could have a lot of what would you say, likes, and that would just skew the entire data set altogether. One person could be a celebrity for that matter. So that is why it is better to do it at an average. So let's do that. Select, and then we have to find out the let's use the age bracket of above 13. Above 13 to 25, that would be our younger demographic, right? So let us use the above 13 to 25 for our young demographic, because 13 is the Facebook age limit, age limitation, and you have to basically be above 13 to be able to create an account on Facebook. So select, what were we doing? Likes underscore received, and we put it into an average. So we are calculating the average likes received from FP, and where age is greater than equal to 13 and age is smaller than equals to 25. So that is, I think, appropriate for a young demographic, and we press enter. So let us finish with the MapReduce job and get the result for that. Yeah, so we get about 200 likes, right? So this is the average of young people. Let us look at the average of old people. So let us take the age demographic of 35 to 35 and above, basically. So not exactly old people, basically people who are at the more adult side of Facebook, basically. So let us just find that out. Select, what would it be? Just simply bring that up again. Why am I typing it again? Yeah. So I'll remove this, and the age would be greater than 35. Put that in, semicolon that up, and press enter. So we'll wait for the results. Let me look at the questions. So for those of you who for those of you who are from an SQL background, right, from a database management background, they will absolutely have a blast doing this, because it's the easiest thing. Even Spark for that matter, PySpark for that matter, Hive for that matter, you'll have an absolute blast doing it, because you only need to understand the architecture really well. And after you understood the architecture, after you understood HDFS and other distributed file systems, if you want to move on to cloud, depending on whatever your interests are, you can basically use your SQL knowledge to a really great extent in this particular domain, because it's entirely that when using Hive, or majority of that when using Spark. So as we can see, there's a clear-cut difference. In the younger audiences, in the younger Facebook users, we had an average of about 200 likes, right, on their account received. And on an average for adult Facebook audiences above the age of 35, we have about 103, right? So there's a clear difference. We had a doubt. We thought that this would be the case, but we wanted to verify it. We cannot just go out on a limb and say that, yeah, that is the case, because old people are less active, so they will have lesser likes. But we need a proof for that. Now we have proof for that. So that is how you will go about it. So let me look at some other questions. Find out the count of Facebook users for each birthday month. So this is quite straightforward. We'll use the group by, and we'll use the month in this case. So let's find out which month has the people with in their date of birth, according to month, which month has the higher number of Facebook users. So select month. So month is something that we have to select, because we're going to grouping it by average, not average. What we're doing? We're doing count, and then we're doing from FB group by month. Put in a semicolon, press enter, and that would give you a list of 1 to 12 months, and correspondingly it will give you the number of accounts that exist for those months. So we can see January has the highest number of Facebook users. We have March 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So corresponding to December, we have 7,894, right? So we can see that for some reason, right, January has more Facebook users. So one could say, imagine that people basically start their New Year's with creating a Facebook account. Somebody thought that I will not create a Facebook account until the new year begins. So a lot of things can be speculated. That is why it gets interesting, right? Why does the January month have that skew? Why does it have more Facebook users when at an average it's about 7,500 from February to December? Why does January have that boost? So a lot of things intrigue you. Basically, Facebook can target January as a fruitful month. It can run a aggressive marketing campaign in January because it sees that users tend to create more accounts during January. So you get the idea. Let us look at do young members use mobile phones or computers for Facebook browsing? And do adult members use mobile phones or computers for Facebook browsing? So we want to find out in this day and age where a computer is not required to browse Facebook. You can use your smartphone for that. You can use other devices for that. You can use your TV for that. You can use your PlayStation for that. You can use a lot of devices. Every device has a web browser these days. Every device is smart. You can log into Facebook from that. So our database, particularly, not database, data set particularly, has two other columns as well, which is the mobile likes received and the website likes received, right? So this divides the likes received into two subcategories. So Facebook is also monitoring whether you're actually receiving those particular likes, actually making those particular likes from a mobile device or a web browser. So I'm not actually discussing the likes received column, we're discussing the mobile likes and the www_likes column. This is the number of likes that you have made using those devices. So let us look at the stats. So my assumption would be that young members are young members use mobile phones more, while older members use computers more. Although I can be wrong. Let us just check that. Select. When we go to check that, how do we go about it? We go about it in a way. Average or count. We go about it with an average. So let us look at that. Average M likes, right? And what we could do over here from FP, where let's use the initial age bracket, which was age greater than equals to 13 and age less than equals to 25, put in a semicolon, press, I think that would be it, press enter. So yeah, for those of you who are between the ages of 25 to 35, I'm not discounting you entirely. I'm just showing you an example. Please do not be offended. Yeah, so we get our result, which is 123. So that is the average. So this is the average number of likes of young users using mobile phones. Let us look at how much phones they use. I'll just look at both of those things at once, right? So average M likes and average website likes. So let us look at those two side by side. We can see that there's a difference. So on a mobile phone, young people tend to like more and they tend to use computer devices less, right? So that basically gives us that result. So what if we turn the tables and put it for the adult audiences? Let's look at that, age greater than 35. I think that would be it, and press enter. Let's see that. So we can definitely see that I was wrong. So what happens is basically even older people are using mobile phones more. Nobody is using computers. So that was a wrong assessment. So that would not be what I would base my business model on. We can see that there's a difference between the number of likes that they're making in general. The older people are making less likes, while the younger people are making more likes. So that was something that we proved earlier on as well. But yeah, the older people are using phones as well. So it's essentially the same difference in a way. So they tend to use computer devices less.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Why are you using Hive, right? You can stick with your traditional tools. If we don't find schema or bringing in schema is difficult or not possible. Now, the point is that when you access Hive, you have to create a table. Hive works on the concept of databases and tables, right? And whenever you're defining a table, the table should have a schema. Now, if your data cannot fit into the table, there is no point in loading the data. Let's say you're getting some type of data. Let's say you're getting text data, raw text data, right? Now, in that data, you're not able to find a structure to the data. Imagine, and I'm just saying you imagine. Imagine you're getting raw data, plain free-form text, right? So in free-form text data, how do you find a structure? You cannot find a structure. That means you cannot use Hive on top of that data. So you have to use Hive where you can find some structure to the data. Maybe you have comma separated values, space separated values, column separated values, something, or JSON files, XML files, even semi-structured data. They can all fit into Hive. Now the next case is if we need response in seconds and low latency applications. I told you Hive is expected to be slow. And if you are looking for a faster solution, don't use Hive. If RDBMS can solve, don't invest time in Hive. Very important point. Hive is not a replacement for RDBMS or something. Okay, because RDBMS systems are real-time systems and Hive is not something which can replace them. If your RDBMS can solve most of your problems, then don't use Hive. Hive is specifically for huge amount of structured data. Say you want to create a table, size of the table is 3 terabytes. Very good, do it in Hive, query the table. Your SQL will be very easy, even though it takes some time, you will get the result. That is where your Hive's use case will come. So think about Hive like a translator. It's a translator. You write SQL, it speaks MapReduce to Hadoop, right? And Hadoop gives the result, it shows as a table to you. So for you, the developer, everything is SQL and table. For Hadoop, everything is MapReduce. And Hive stands in the middle. Now, what is the similarity with SQL and difference from SQL? Hive is very similar to SQL-like queries. It is based on actually SQL 92 framework. And it is safe to say that its functions are mostly same. What is the difference from SQL? The major difference is that Hive query executes on Hadoop rather than traditional database. That means you cannot install Hive outside Hadoop. It works only on HDFS. This allows Hive to scale to handle huge data sets, which cannot be done by RDBMS. The internal execution of a Hive query is via a series of automatically generated MapReduce jobs. Right? So the next question naturally you will have is that, oh, I understand Hive, but can I fine-tune Hive? What about performance? Can I improve the performance? Can I do something with Hive? Yes, you can do. Now all Hive queries will be converted to MapReduce job. So why can't we write MapReduce ourselves? So this is one question people ask. See, Hive is converting everything into MapReduce. So why don't you just write MapReduce for God's sake? Right? Why are you using Hive? Understanding the internals of Hadoop framework is must to write MapReduce. SQL engineers can quickly write Hive scripts. Now, if you want to write MapReduce, right, you have to learn Java or Python or Ruby or C#, right? Then you have to implement your logic or using MapReduce framework. You have to write your custom mapper, custom reducer, package it as a jar file, resolve all the complexities, errors. Now here, you don't have to do any debugging, anything. Create a table, write your query, and it just works. That is how it works. So the next point is that now talking about the real world. Okay, so let's suppose you learn Hive in our Intellipaat course and you master Hive. And what did I teach you? I taught you that Hive is a SQL interface to Hadoop. Fine, you understand that, right? And then you go to a real world project, okay? And then you go to the project and say that, you know what, I'm an expert in Hive. An expert in Hive. I know Hive really well. You want to say to your project. And these guys are going to tell you that, you know what, you can use Hive or you can use Hive plus this. You can use Impala. You can use Spark SQL. You can use Phoenix. What did I just do? I just blew your mind out of proportion. So when you go to a real project, in a real world project, and you ask them, okay, I have data on Hadoop, give me a SQL tool, they will either give you Hive or give you Hive plus this, or give you Impala, or give you Spark SQL, or give you Phoenix. And you are like, oh my God, there is only Hive that is a SQL interface. Now I am in a dilemma because these guys are talking about this, Impala, Spark SQL, Phoenix. And trust me, if you write a SQL query, it will be executed the same way in all these platforms. You write a group by query, Hive will execute it, Hive plus this will execute it, Impala will execute it, Spark SQL will execute it, Phoenix will also execute it. So the real question is, what are these different tools? Right? So this is some real world info to you guys, right? See, Hive is the original tool. This came first, right? So Hive is the first Avenger. So this is the first Avenger. So this is the first guy who came into the world, right? So when Hive came, everybody was happy. So people said, all right, fantastic. Now I got SQL interface. I can write a query and you know what? The query executes nice. But over a period of time, people didn't really like Hive. People said like, all right, Hive is great. But the problem is that the queries are damn slow. You know, the other day I wrote a query, it took a day to give me the result. I don't really like Hive. We need something else. That is when the company called Hortonworks started proposing Hive and Thais. Now what happens here is that if you access a Hortonworks Hadoop cluster and you write a Hive query, say execute, the Hive query will be converted into Thais, not MapReduce. So original Hive is Hive plus MapReduce. Hortonworks Hive is Hive plus Thais. So what is Thais? Thais is a framework, Apache framework. Probably if you're interested, you dig deeper. Well, Thais is created to make MapReduce faster. So I don't want to get into details of Thais. I'm just giving you some extra information. For the time being, understand that Thais is a framework which is built to overcome the problems in MapReduce. MapReduce is ideally slow. MapReduce is normally slow, right? So some guys built something called Thais, and Thais also uses mappers and reducers and all, but Thais is much faster than your MapReduce, right? So Thais is a Hindi word. It stands for speed, and it is created by Indians. It is the next level of MapReduce, you can say. So what Hortonworks did, they said, see, what Hortonworks did, they said, why don't we club Hive and Thais so that queries are faster? Are you getting the point? So if you are on a Hortonworks cluster, you write a Hive query, say execute, you will see a Thais job firing. You will never see a MapReduce job firing because Hortonworks promotes Thais. Even though Thais is Apache open source, Hortonworks says they promote Thais and they say that's their queries are faster. So your first Avenger, original Hive, is damn slow. Now Hive plus Thais, this guy is interactive. Interactive query means it is faster, but not real time. So if you are writing a Hive query on a Hortonworks cluster, it uses Thais as an execution engine, and it is faster, but it's not real time or something. It's kind of like faster. So when Hortonworks started this, even before that, there is another company called Cloudera. There is a company called Cloudera. Cloudera, what they did, they invented something called Impala. Impala is again built on top of Hive. Impala is a SQL interface, but what happens if you write a SQL query on top of Impala, it will run it using a daemon called Impala D. It doesn't use MapReduce, it doesn't use Thais, it uses a proprietary Impala D to run. So this is promoted by Cloudera, and this is also interactive. Now Hortonworks will say that Hive plus Thais is faster. Cloudera will say Impala is faster. That is a war going on for like past 4 years. Nobody knows. Both are same. But whether it is Hive plus Thais or Impala, it's again a SQL interface for you. Only difference, if you're on a Hortonworks cluster, the execution is done by Thais. If you're on a Cloudera cluster, execution is done by a daemon called Impala. And there is somebody called Spark. Spark has a SQL interface that's called Spark SQL. If you write a query on Spark SQL, again same SQL, this will be converted into Spark, and this is almost real time. So this is faster. Look at this, look at this. Hive Thais, Hive Thais, SQL, Hive, Thais. But in Hortonworks, you can also say that I don't want Thais, I want MapReduce. They can switch the engine. So these are all additional information, extra information, but good to know things, right? So Phoenix is SQL interface on top of NoSQL. That means HBase is your NoSQL database, right? And HBase doesn't understand SQL. So if you do not know the language of HBase, you install Phoenix, you write your SQL query, it's going to convert in the language of HBase, show you the result. Original Hive plus MapReduce is batch processing, very, very slow. Thais and Impala are similar, interactive, but Thais is Hortonworks, Impala is Cloudera. That means you will never see Thais on Cloudera and Impala on Hortonworks. Spark SQL is again on Spark framework. Phoenix is on HBase. Difference between different Hive. For example, you have something called Hive. Then you have something called Hive Server 1. Then you have something called Hive Server 2 plus Beeline. So what are these terms? What is pure Hive? What do you mean by Hive Server 1? What do you mean by Hive Server 2 plus Beeline? See, so this is something which you have to understand from the technical point of view. Originally, only Hive was there. And this is just a client-side application with an interactive shell, meaning the original Hive, what you call the pure Hive, is just a client-side application. That means if you are a developer, you take your laptop, install Hive, you get a command line. In the command line, you say create a table, drop a table, do the query, blah, blah, blah. It just works. There is no server, only client. And that is what I was explaining in my picture also, right? I drew a picture where I was telling you that, Hive is just a client-side application. So when Hive was invented, people were really happy. They said, oh my God, that's really great. So we can get a shell and we can write commands and we can work with Hive. That is nice. But later, people started thinking, so how do you connect your database? Can you tell me? You have an Oracle database. The Oracle database is sitting in some place. How do you connect it with the Oracle database or Microsoft SQL database? What do you use to connect? You need a client-side tool, something like MySQL Workbench or something, right? You need a client-side tool to connect using JDBC or ODBC, right? JDBC, ODBC connections can be made, but for that, yeah, you will have a server where Oracle is running. You need an Oracle client, some SQL client, right? So what people thought is like, okay, everything is nice about Hive, but I cannot connect to Hive from my SQL clients. Why? Because Hive was just a command line. Look at here. That is when Hive Server 1 came. This guy will allow JDBC or ODBC connections from your regular SQL clients. That means Hive Server 1 means there will be a server running in a Hadoop cluster. Clear? Hive Server 1 is a server which is running in the Hadoop cluster. You in your laptop, if you install Hive, you can open the command prompt and type queries, or you can use your regular SQL client tools to connect to the Hive server and perform all the activities, right? So Hive Server 1, the option is that you can create JDBC connections from your SQL client directly to Hive. So you can insert into a table, you can do whatever queries you want, you can directly run in your client. Very easy. You don't have to use a command prompt. You can use a command prompt also. So people were really happy. Hey, great, we have Hive server, we can connect, we can run queries, blah, blah, blah. But this lacked concurrency, meaning there was no concurrency or consistency in Hive Server 1. That means if multiple users create sessions to Hive, it was impossible to handle the sessions. Data persistence, data concurrency issues were there. That is where Hive Server 2 came. Hive Server 2, first of all, it also allows your JDBC, ODBC connections. It provides concurrency, and it has a new client-side command line tool called Beeline. That is Hive Server 2. So Hive Server 2 is kind of like an upgrade to Hive Server 1. The basic difference is that it also allows JDBC, ODBC, but it provides concurrency. That means multiple JDBC, ODBC connections are possible. You can work with Hive, but they have redesigned the CLI of Hive, and the new CLI is called Beeline. Still, it supports the old CLI, and the new CLI is called Beeline. Beeline is actually a client which you can install, like SQL client. So I can go to a computer, install Beeline client. From there, I can make a connection request to the Hive Server 2 and start working in the Hive. So the Hive server will be installed inside your cluster. The architecture of Hive. Now you can see a person, okay, and he is using the Hive query language. Now you can, if you are a person, either you can interact with Hive through CLI. That is what I'm saying. CLI means it can be the Beeline client or regular command line, Hive shell. I will show you the Hive shell. It's an interactive shell. Or JDBC, ODBC. That means you are having a SQL client. From there you can connect. Or a web UI. Hive also provides a web UI. And whatever ways, look at the arrow. If you are using the CLI, directly you will be hitting Hive. That means hitting Hive in the sense, if you're using the CLI, you will be directly creating tables, etc., etc. But if you are using the JDBC, ODBC, these sessions are handled by Hive Server 2. So we are having Hive Server 2. So the main purpose of Hive Server 2 is to handle this multiple sessions that are created by users through JDBC, ODBC. That is why there is a difference in the arrow. CLI means you are directly invoking Hive. JDBC, ODBC means you're connecting through the Hive server. So either you use CLI or you use JDBC, ODBC. Now, where will I install Hive Server 2? It is not necessary that you have to install it inside a Hadoop cluster, right? It can be outside the Hadoop cluster also. See this picture. Your Hive server 2 is outside the Hadoop cluster in this picture. Now, so like I explained, you sit, if you use CLI, directly it is Hive. If you use JDBC, ODBC, it goes through Hive server. But again, the sessions are handled by Hive server, but it is ultimately Hive, right? Now, in the picture, it is very clearly shown that the Hadoop cluster is separate. That means Hive server need not be installed inside a Hadoop cluster. It can be outside. In most of the cases, it is installed outside as well, right? Now, inside the Hive architecture, you can see compiler, optimizer, executor. But how does Hive know where is the data? Or in other words, what about metadata? See, for any database or data warehouse or any system, you need to store metadata. What about the metadata? So in Hive, what happens? There is something called metastore service. What is metastore service? It is a service running to handle metadata. What is metadata? The definition of your table, the definition of your database, the schema of your table, all this is metadata. So you need to store the metadata somewhere, right? So that is what is handled by this metastore service. By default, Hive uses something called embedded metastore. This means it stores the metadata in built-in Derby database. So what happens is that by default, if you are downloading and installing Hive, it comes with a database called Derby, Apache Derby. Apache Derby is a database, and it will use this Derby database to store the metadata. Clear? So that is called embedded metastore. Embedded metastore means by default, if you just download and install Hive, Hive will need some place to store the metadata. So it by default comes with this Apache Derby database, and it starts using Derby to store the metadata. You don't have to do anything. It will be all configured. Okay, so this embedded metastore is good because you're saying that if I'm downloading and installing Hive, right, it will come with a database and it will store the metadata in the database. This is all good. But this Derby has a drawback. The Derby database is a single instance database. That means it will allow only one connection at a time. That means if you are using the embedded metastore of Hive, only one person can access Hive. So that is a drawback. So what you can do is that you can configure your own database as metadata storage for Hive. Example, MySQL. So this is what we do in production. Meaning in production, what we do is that we will download and install Hive. Now we know that Hive will start working automatically because it will use Derby to store the metadata. But when it is using Derby to store the metadata, right, what happens is that it will allow only one connection at a time. Because Derby will allow only one connection. So we don't do that. What we do is that we will configure something like MySQL and ask Hive to store the metadata in MySQL so that multiple people can access Hive. The latest version of Hive allows updates, but all other versions of Hive by default does not allow updates, because remember it is Hadoop. Hadoop is a write once read many system. In Hadoop there is no update process, right? You copy the data, you delete the data, you again copy the data. It is all writing the data and reading many times. But the latest version of Hive allows you to do that. It selectively can update it Okay, it can refer to the position of the block in the data node. So Hive can by default talk to Hadoop. It can understand where is your data, and accordingly it can do. So what you need to understand is that if you are practicing Hive on the Cloudera VM, if you are practicing Hive on the Cloudera VM, you are using embedded metastore. That means there is a Derby inside, and that is storing all your metadata. Very simple. But if you go to a company and start working on Hive, right, then the metadata will be stored in a separate database like MySQL. That is the difference. So two types of metadata storages are possible. So if a user write a query, the query will be accepted by somebody called a driver. The driver is not shown in the picture, but there is a driver. And the driver will pass it to somebody called compiler. Compiler will check with the metastore to get the metadata and compile your query. Then optimizer will optimize it and give to executor. Executor is your MapReduce, and MapReduce will run your query in the cluster. So step number 1, user writes the query, and the query comes to Hive. Okay, and first step is compiling the query. Now you won't simply compile the query because you need the metadata. So you will check with the metadata store about the metadata. Once you get the metadata, you compile the query, and there is a component called optimizer. It will optimize your MapReduce code so that it can perform better, and then give it to another component called executor. Executor is normally your MapReduce program. I mean MapReduce engine, and that will execute your query and show the result. There are two situations. Okay, again this is coming mostly from the practical aspect. If you are having a small Hadoop cluster, let's say you are having only 3 servers, I mean 3 data nodes, 4 data nodes, etc. And so it's a very small cluster, right? And normally this cluster will be accessed by only a couple of guys. So if you are sitting here, you have a computer, entire Hive will be installed here. Your Hive server will be running, everything will be running here. Why? Because it's a small cluster. There is no point in installing here and then connecting. You can install Hive, but usually, so I'm talking different use cases. I'm talking different use cases. In small Hadoop clusters, where you're having 3 to 4 data nodes and all, you will not do any heavy lifting. Why are you creating small Hadoop clusters? It might be for proof of concept. You are not actually running any production workload. So that means in this case, there is no Hive component in the Hadoop cluster. Entire Hive package is on your machine. Hive server, Hive CLI, whatever you call, anything starting with Hive is on your computer. Nothing is there in the cluster. Are you getting my point? Why? Why? Because either you or only your friend will be accessing this. And you don't need a separate client server and all, right? Because it's a very small cluster. So you install all the package on your computer, and then you can also install SQL client on your computer and create a JDBC connection. From here it will connect, etc., etc. But everything will be on your computer because it is a small Hadoop cluster. Now, what if it is a very big Hadoop cluster? In a very large Hadoop cluster, so this is a large Hadoop cluster. Say thousands of data nodes. You will have something called a gateway node. Have you guys heard about this? What is a gateway node? Have you guys heard about this? No, I think. What is a gateway node? This guy will have connectivity with Hadoop. And it's a Linux machine. Imagine it's a Linux machine. Here, you will install everything. You will have your Hadoop client here. You will be having your, Hive server here. And maybe Pig. Everything will be installed here. And what you do is that if you're sitting here, right, you have a laptop. You don't install here. Maybe on your laptop, this is your laptop, right? So this guy is sitting here. This guy is sitting here. What he can do is that he can do multiple things. He can SSH to this machine. connect to this machine. So he log into this machine, and from here he can type Hive, he get a command prompt, start working on the cluster. Now another guy is sitting here, he has a laptop, okay, and here he has installed let's say SQL workbench SQL client. Now if he open the SQL workbench, it will connect to this, and from here it will connect to this, right? So what is the gateway node? Gateway node is nothing but is a server, okay? It acts like an intermediate between you and Hadoop cluster. In large Hadoop clusters, you will not be directly logging onto the cluster. You will never even see your cluster.
Just a quick info guys, if you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
It is strictly prohibited. You cannot access your cluster. All you do is that you connect to this gateway node. From here you can do anything. So if you prefer the CLI, what you do is that you log on to this gateway node using SSH. From there you are on the gateway node. You type Hive CLI, you get Hive CLI. Or if you're having a SQL client, okay, you give the details of this gateway, and this will connect to the gateway. From there it will connect to the large cluster. Right? So all the client packages are actually installed in the gateway node. That is my point. So you have two options. Either you log on to the gateway node. So now you log into the gateway node and open the command prompt and say hit Hive, you will see the Hive shell. You start working. Or if you're having a SQL workbench, your Hive server will be running on this gateway node. Okay, SQL workbench will connect to Hive server and to your cluster. Interface of Hive. Just type Hive and hit enter. And this is the Hive shell. So this is the command line interface of Hive, the interactive shell of Hive. What you see is Hive shell. Now, once you are in the Hive shell, most of the commands that you type need no introduction, because the commands are SQL commands and most of you are familiar with SQL, right? For example, I can say first command, probably if you log on to any of these systems, the first command you will probably type is show databases. You can see all the databases that got created. Now, the best way to understand Hive is to start working with Hive. So what I'm going to do, I'm going to say create database, let's say Dell, and if I do a show databases, it will be there. There is a database called Dell. Now if you want to use it, just say use Dell. So when you say use Dell, the database has changed. So now you're using the database called Dell. Fine. So far, so good. Now, these are regular things, right? Now, let's take a sample scenario and see how we can use Hive to solve a problem. Rather than just speaking about Hive, right? Let's take a sample scenario. So let me show you the data that I'll be working with. Yeah, so on my desktop, I have a file called transactions. Can you see this file? It is called txns1. It's a transaction data. If I open this file, this is how the data looks like. Just to give you an idea, right? Now, if I have to explain this data, let's pick one record. So this is one record so that I can explain to you. As you can see, every record is comma separated values. So this has some structure. The first column, so this is a transaction data from a sports store or a retail store. So first column is transaction ID, which is 4. Then you have date of transaction, 17th December 2011. Then you have something called customer ID, 4002613. That is the customer ID or the customer number. Then the amount spent, which is $98.81. And then the category, team sports, the item, field hockey, city, Nashville, and the state of Tennessee, it's a credit transaction. So this is how your transaction data looks like, line by line. Multiple customers have purchased items from a sports store. That's it. So it's a very big data actually. I mean, there are a lot of lines in this data, right? So this is one file. Now, I also have another file here called customers. So if I open this file, this is my customer data. For example, if I pick one line or one record at a time, first column is customer ID, okay, which is 400015. Then you have first name and last name, Julia Desai, aged 49, profession is musician. So we are having two set of data. One data is the transaction done by the customers. The second data is the data about the customer. Their name, customer ID, age, and profession. So I'm having two set of data. And as you can see, the customer ID is common in both the data set, right? Now what I want to do is, I want to analyze this data. What sort of an analysis? What I practically want to do is that I want to understand how much money is spent by youngsters in my store and how much total amount is spent by middle-aged people in my store and how much amount is spent by old-aged people at my store. So basically, I want to classify the customers into 3 groups, say 20 to 30, one group, 30 to 50, another group, 50 above, another group, and I want to calculate the sum of amount spent by them. I want to use Hive for this. So let's look at how we can do this. So as a first step, what I'm going to do is that I'm going to create a table. This is the syntax to create a table. And this should not be a surprise to you if you already know SQL. I'm saying create table called, this is my table name, transaction records. And this is my schema. Very simple. Transaction number, date, customer number, amount, category, product, city, state, spent by. And Hive imposes schema, which is very similar to, and the data types and all are very similar to what you deal in day-to-day life. Like it supports in, string, double, float, everything almost, right? So I have given the schema to my data, right? Then I say row format. I am expecting my data in row format. That means by default, Hive will identify a row and using new line character, it is going to separate every record. Delimited fields terminated by comma, meaning my individual fields are comma separated. If you give semicolon here, your input data should be having semicolon. Then I say stored as text file. By default, Hive stores the data as text file. Now you can say sequence file or any other format also if you want, but if you don't type text file also, it is going to store it as text file. This is the for syntax. If I hit enter, Hive says OK, which proves the data is created, right? I mean, the table has been created. Now, the next point, I have the table. How do I load the data to the table? Now, there are multiple ways to load the data to a Hive table. I'm going to first show you the common way. That is what everybody does. So where is the data? The data is on the desktop of my Linux machine. I mean, the data is in my local file system. So what you can do is load data local in path.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
/home Cloudera. So this is the path. Desktop. Into table px. That is how you load the data. You can actually do insert, right? But typically in data warehousing, you get bulk data to load. So you will be getting huge amount of tables and text files which you want to load it into this place. So usually you will not say insert. Usually you will dump the data like this. So what I'm saying load data local in path. This means my data is in my local file system, and this is the path of my data into the table transaction records. That's it. So now if I do a select star from the table, say limit of 20 or something, I should be able to see the data. See, I'm able to see the data because I have loaded the data to the table, right? So now the data is also in the table. But what is happening in Hadoop? Behind the scenes, what is happening? That is one question, right? I will show you what is happening behind the scenes. Whenever you install Hive on any platform, what Hive does is that it will create a folder called warehouse in HDFS. So if I do an HDFS DFS-ls, you see this? Whenever you install Hive, Hive will automatically create this folder called warehouse in Hadoop or HDFS. The folder name is warehouse. Now, if you check what is inside this warehouse folder, you see all the databases you have created. So this is our database, del.db, right? So whatever databases you are creating is actually stored inside this warehouse directory. Whenever you create a database, okay, the database gets created in this path, user Hive warehouse, and then the DB, what you create. Now, the DB is just a folder in Hadoop. DB is just a folder in Hadoop. Hue is a web interface to your Hadoop, nothing else. So in Hue, I can just go to browser and I can just see, rather than typing HDFS, DFS, I can just come here and see what is the files in Hadoop. When you install Hive, it creates a folder called warehouse. So this is the warehouse folder, right? Can you see the warehouse folder? So it creates a folder called warehouse. Inside this warehouse folder, if you open this warehouse folder, you can see all the databases you have created. So this database called del.db is nothing but a folder in Hadoop. You created a database and you think it is a database. It's not a database, it's just a folder. See del.db. If I open this folder, what you see? Another folder called transaction records. The transaction records table you created is just a folder. And if I open this, can you tell me what you see here? The file that I copied. So look at the table structure. Look at here. Your database del.db is just a folder. Transaction records is another folder. Inside that you have the file. This is what is happening in Hadoop. So when you are loading the data into a Hive table, it is just copying the data from Linux to this folder in Hadoop. Is this clear to you or not? Of course, you use a command load data local in path, but what is happening behind the scenes is that the data that you are inserting into the table is just copied into this location in HDFS. And if this data was very big, it will be divided into blocks and all, just like regular Hadoop file. This is where your data gets stored. So I can also show this from command line. So if I do warehouse, then del.db, what will I see? I see another folder called transaction records. And if I again say txn records, I will see the file. So that is why I'm saying Hive is just giving you a projection. The actual data is just lying in Hadoop, right? Now what I will do is that, okay, I will create one more table because we have the customer data to be stored. I will say create a table called customer, and this is having customer number, first name, last name, etc. So another table, and we will load the data. So the data is into the table called customer. Right? So now the data is loaded into customer, but you will be wondering, so far I have not seen any MapReduce program, right? So I was telling you that if you query the data, you will see the MapReduce job and all, but so far I have not seen anything because you have not actually ran a query. So let's say select count star from transaction records. So this is a proper query. So I'm doing a select count star from the table. So basically I want to know how many rows are there. If I hit enter, it's going to fire a MapReduce job. Can you see this? Because it's a proper query, it cannot just show the result. It's going to launch a job and create a jar file. And here is the result, 50,000. So the answer is 50,000. The result of the query is 50,000. How did I do it? I just wrote my query and hit enter in Hive, and it automatically launches an equivalent MapReduce job to show me the result. And I get the result here. Now let's analyze this further. So what I want to do is that I'll be creating one more table. So I'm going to create a table called out1. Okay, this table has customer number, first name, age, profession, amount, and product. So basically my idea is to do a join operation. I have a customer data, I have a transaction data. Both the data has a common column called customer ID. So my idea is to do a join operation, a simple inner join operation. And the results of the join operation has to be stored on a table. So I have created a table already. So this table is called out1. And how do you do a join operation in Hive? Very simple. Insert overwrite table out1. So out1 is the new table we have created. Select a.customer, a.first name, a.age. So if you look at the syntax of the join operation, it is exactly same as your normal SQL join operation, right? If I hit enter, it's going to launch a MapReduce job. So now the join is over, and if I do a select star from out1, this is the result of our join, And if I do a limit of 20 or something, see, this is the result of the new table. In the new table, if you see, this is the result of the join operation. So you see, you have customer related data and transaction related data. This is very simple, okay? I'm just following the same logic of SQL. Only difference here is that, it is converting it into MapReduce job, right? Now what I can do is that after this, I will create one more table. I'm creating a table called out2. Now what I want to do is, see, now I have done the join operation, but I want to classify my customers, right? My customers are having different age. So I'm having a column called age, and I want to classify my customers. How can I do that? Very simple. If you look at here, insert overwrite table out2. That means the result will be in this table, which we created in the last step. Select star comma case. You see, I'm opening a case here. And what is the case? When age is less than 30, then it will be marked as low. When age is between 30 and 50, middle. Greater than 50, old, else others, end. So what this query will do, it will pick all the rows from my previous table, look at the age column, and based on my criteria, it will mark every record as low, middle, old. You hit enter, it's going to fire a MapReduce job again. So every query will fire a MapReduce job. You don't have to worry about that. So you can see the map 0, reduce 0, etc. And now it's over. So if I do now the query is over. If I do a select star from out2, if I do a limit of 20 or something, you see every record is now having a category: old, middle, old, etc. Right? So now I am able to classify the customers. Now all I need to do is very simple. I will create one more table. I will do a group by query. So what I'm doing here is very simple, guys. I'm saying insert override table out3. So out3 is the latest table I have created. Select level. So the level column will have low, middle, that age classification. Sum of amount from out2, group by level. So it's a very simple group by query. The result of this query will have your final answer. So the table name is out3. And the query is over. If I do a select star from that, I will have the final answer. See, this is your final answer. So the youngsters are spending this much amount, middle-aged people are spending this much amount, old-aged people are spending this much amount. So this is how you start working on Hive. There are two types of tables in Hive. There is something called managed table. There is something called external table. And by default, any table that you create is a managed table. So I will tell you what is the difference, okay? But there are two types of tables in Hive which you can create. I mean, two types of tables. There is something called managed table and there is something called external table. Now, what are these things? By default, any table you create is called a managed table. So what is that? How do you know that? If you go to Hive, you can say show tables. And we have a table called transaction records. If I say describe formatted txn records, if I type this command, describe the table, it says it's a managed table. table type is managed, and look at the location of the table. Managed table means the table is managed by Hive. That means this table is stored under user Hive warehouse, and you cannot change that as well. That is called a managed table. So if that is managed table, what is an external table? In Hive, I can say, what I can do is this. I can say create external table. So when you want to create an external table, I will tell you what is an external table. You have to say create external table. Well, the syntax is not correct. Let me add one more thing. Location / user / Cloudera / user Cloudera. I think it is user Cloudera. Then I can say my customer, something like this. Okay, let me type this first, then you will understand. Yeah, so this is the proper syntax, guys. So what am I doing here? I'm saying create external table. So whenever you're creating an external table, you have to specifically mention that it is an external table. Otherwise, you just say create table, it's going to be a managed table. So I say create external table, and this is the table name. And if you look at the schema and row formats, they are all same. There is no difference in the schema or the format or anything. Only difference, I'm saying location user Cloudera my customer, meaning this is the location in Hadoop. How do you know that? So once you create this table, if you go to your Hue, you go to user Cloudera, there is a table created called my customer. Can you see this? This table is just created and there is no data inside this. Now what is the advantage is that, so now I created a external table. If I do a select star from this table, TXN records 2, there is no data because I just created a table. I didn't fill it with data. If you want to fill it with data, all you need to do is very simple. Go to the folder mentioned in the external table, that is my customer, copy the data to that folder. Now I just uploaded this data to this my customer folder. Can you see this? In the my customer folder in Hadoop, I just uploaded this data. Now if I come back here, again I do a select star, do a limit of 20, I have the data. So what is the difference between a managed table and external table? In managed table, which is the default table by the way, when you create a table, the table is always created in user Hive warehouse, that location. And then you manually load the data to the table. External table means when you create an external table, you are mentioning the location of your data. Look at this line. You say that the data will come from this folder, and whatever data you dump in this folder will be visible in your table. Very simple. What exactly is the difference between a managed table and an external table? Is the difference only the location? Yes, the difference is only location, but the real question is, where will you be using a managed table and where will you be using the external table? Now I can show you practically. Have a look at here, guys. Now, if I do a show tables, there is a table called transaction records. This is a managed table. I can say drop table TXN records. So what am I doing? I'm dropping the table called transaction records. That's a managed table. What will happen to the data in this managed table? It will be deleted. Why it will be deleted? Because when you drop a table, that folder is deleted from Hadoop. Remember the folder structure. The data is inside that, right? So that means if you drop a managed table, the data is gone. But if I do a drop table TXN records 2, that is an external table, the table is gone, but Cloudera and the folder is my customer, the data remains there. This is the difference. This is the difference. If you drop a managed table, the table goes, the data also goes. If you drop an external table, only the table goes, the data remains the same. So if you want to share your table with others, let's say you're working in a project, okay, you create a table and you think that you want to share the table with others, and you suspect accidentally somebody may delete your table, create an external table, because if somebody accidentally drop your table, still your data will be safe. Otherwise, create a managed table. How to use a Beeline. So Beeline is the new CLI, and by default, if you are using Cloudera VM, it will have Hive Server 2 running, and the default port number it is 10,000. You can check the documentation to ensure that. Now, if you want to connect with Beeline, all you need to do is you have to start Beeline first. Okay. This is how you start Beeline. You will say user lib hive bin Beeline. Basically, this is a location where Beeline is installed. It may differ in different distributions, but in Cloudera Hadoop, it is always right. So now you see the Beeline CLI, but here if I say show tables, it's going to throw an error. When I say show tables in Beeline, it's going to throw an error. It says no connection. Remember, Beeline is a client. It needs to connect with Hive server. Beeline is a client. Now you see the difference, right? When I'm opening Hive, if I just hit Hive, I am accessing the Hive entire package. It's not a client only. But when I say Beeline, it's a client. So in Beeline, when I say show table, it says no connection. I can't connect to the server. If you want to connect to the server, what you need to do is this, guys. This is the connection string. You can use the same in your JDBC or ODBC or whatever you have. This is your connection string. Connect JDBC Hive 2. Hive 2 stands for Hive server, right? Localhost, that's the port number. Username, password by default, nothing because I'm running locally, and JDBC Hive driver. So it will connect, right? So now I am inside this. Right now, if I say show tables, show databases, it will list all the databases. So this is how you start Beeline. So you will say user lib hive Beeline. So that will start Beeline. Beeline is your client. And when you say show tables, it won't show anything because it need a server connectivity. And this is the connection string. So you will say connect with JDBC Hive server 2, localhost running in localhost, and the port number, username, password, hit enter, it will connect. Okay. Once it is connected, you can type your regular commands. So I am typing, where is the command? Where is the command? Show databases. So this is the command I type, and here is the list of the databases. And the command line is pretty much similar to your Hive CLI. So this is how you start working on Beeline. This is Beeline. Okay. Now, if you want to quit Beeline, just say exclamatory mark Q. This is the command to quit. Very important. Exclamatory mark Q will quit Beeline. So now I am back. Right. So that is how you connect from Beeline client to Hive server 2. You can also download Beeline client on your desktop or something and make a connection to the Hive server. Now, if you don't want to type all the commands and all, you hate the commands of creating a table and all, what you can do is come to Hue. Okay, then what I'm going to do is that let me show you the data I'll be working on. Here, okay, there is a data called healthcare sample data. Now this has patient ID, patient name, patient mobile number, date of birth, hospital data, email address, social security number, the disease, diabetes, fever, cold, blah, blah, blah. So this is a sample data that I'm using. What if I want to upload this data into Hive and query the data? Basically, I want to get a list of all the people who are having cold. So if I want to do that, you can of course use the command line, but you can also use the GUI. Let me show you that. Go to Hue, go to this data browsers. There is something called Metastore table. Click on this. Once you click on Metastore table, okay, it will allow you to select the database. So I'm going to select our database. I can select this database. I can say create a table from a file. I can give a table name, test table. Okay. And then I can say select the file from where you want to create a table. So which is this healthcare data. Say next. It's going to automatically look at the data. It will ask you, hey, is this how your data looks like? Yes. I will say next. And it is also automatically going to select the data type. I'm going to say create table. So this will create a table from the file that I have uploaded to Hadoop. No need to type any statement or anything. Right? So going to create a table. Now once the table is created, you can query the table from the GUI. You don't have to use CLI. Let me show you that. What you can do is you can go to this query editors. There is something called Hive. Can you see here? You can go to Hive. In Hive, you have to use the database. I have a database called test table. I can select this table, right? So there's a table. So I can say select star from test table where column number 7 equals cold, and then execute the query. So this will run the query in the GUI and show me the result. Can you see this? Right? And I can create nice charts and all if I want. Right? I can create like, charts and all. See, stacks and groups and everything I can create if I want. Basically, what I'm telling you is that you can run queries from the GUI also. Partitions in Hive. So what exactly is partitions in Hive, and why are we doing this, right? What's the idea behind partitions in Hive and what we are supposed to do? So just imagine that you are working in a project which uses Hive. Okay, so you are in a project which uses, of course, Apache Hive, and you're happy you're working on Hive and everything is going fine. Now what happens is that, let's imagine that your manager comes to you and say that, hey Raghu, do one thing, create a table for me in your Hive in which I want to upload all my sales data. So what I did, I created a table, create table, sales data. I created a table called sales data because my manager says he has to upload some data related to sales. So I created a table called sales data with some schema, some columns and all, whatever we have. Now imagine you are working on a managed table. So for the time being, we assume that we are on a managed table, and by default, what happens is that if you create this table, the table will be stored in user Hive warehouse, and let's say our database is called newdb/sales data. If you create a table called sales data, this will be the location by default. So this is the basic stuff, right? So whenever you're creating a managed table, the table's location will be this. Now what happened is that your manager told you that, hey Raghu, do one thing. I have some data. Why don't you load the data to the table? So your manager gives you a file and asks you to load that into the sales data table. No big deal, because usually you know how to load the data. You will say load data local in path and then load the data. When you loaded the data, so the manager says, hey, this is January month data. So you loaded a file called january.txt. Very simple. I have created a table called sales data. I have loaded a file called january.txt. This contains all the sales transactions in the month of January. Very simple. So you are happy. Your manager is also happy, right? Yeah. So then what happened is that, you keep on working in the project, and the next month your manager comes to you and say that, hey Raghu, we have some more data, so this data is from the month of February. Why don't you load the data to the table? So you end up having, so now the file is february.txt because this is the February month data. However, since this is getting loaded into the same table, this will be the structure. Now inside the sales data folder, now you have two files, January and February, right? So probably I will write it like this so that it's easy for you to understand. I will say like this. And then your manager says, hey Raghu, I have some more data. I have some more data. March.txt comes. Then what happens? April.txt comes. Then what happens? May.txt comes. And June.txt comes. So what is happening here? Every month you are getting the data, right? Every month you are getting the data, and you are loading the data to the table because you have a table called sales data. But if you look at the way in which the data is stored, what you can see is that these all different files, January, February, March, April, May, June, all are inside the same folder called sales data because that is your table name, right? So, okay, so you might think that that's fine, but what is the problem? Now imagine, okay, you are writing a query like this, okay? Just imagine that you want to write a query something like this. Select star from sales data table where month equals, let's say, April. I'm just giving an example, okay? So let's say you want to query the table. You want to query the table. So what is the query? You say select star from the table where month equals to April. Means you want to see all the data from April month. Now look at the problem you have. Hive by default doesn't know where is April month data. So what Hive will do, it will come to this folder called sales data. It will first scan this entire January.txt, then scan this entire February.txt, then March.txt, then April.txt, it finds a match, again May.txt, again June.txt. Meaning your entire data is scanned for this single query, and your queries will be really slow. So the problem we have is we have a table. So table in Hadoop is like a folder, right? And you keep on loading the data. Every time you load the data, it's going to store as a file. So that means inside a single file, now I have 6, inside a single folder, now I'm having 6 files. January, February, March, April, May, June. And if you write a query, Hive doesn't know where is the data. It is going to scan all the 6 files. It is going to go through all the 6 files to show you the final result. And so you imagine you keep on adding files every month, data every month. If your table has, let's say, 100 different files, Hive has to scan this entire files before showing you the output of the query result. And obviously your queries will be really slow. So you are not actually saying where is the data. So that is a simple problem. And Hive has to scan the entire files to produce result. So ideally your queries will be slow. It will be really slow. So the question is, what can I do in such a situation? I don't want my queries to be slow. I want my queries to be faster. That is where your concept of partitions come into picture. So there is something called partitions in Hive. So what exactly is partitions? Partitions means you tell Hive to divide the data based on a column.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
What is a partition? You're telling Hive to divide your data or segregate your data based on a column. For example, what I can say here is that I can say, hey Hive, look at what I'm writing. Partition my table based on the month column. So this is what you can tell to Hive. So I can tell Hive, hey Hive, do one thing. Partition my table, okay, based on the month column. If you tell this, what Hive will do is that it is gonna look at, now once you write this, it is gonna look at the whole data first. Then it is gonna look at the month column in the whole data, right? Now obviously in your January.txt file, the month column will be what? January. What Hive will do, it will create a folder called Jan and place this file inside that. Accordingly, it's going to create something called Feb and place it here, and March, place it here, sorry, and April, place it here, May, place it here, June, place it here. So when you tell Hive that, hey Hive, I want to create partitions and I want to create partitions based on the month column, what Hive will do is that it's going to pick the column from the whole data and understand how many values are there. In my example, there are 6 months data. It's going to automatically create 6 folders, Jan, Feb, March, April, May, June. All the January month data will be copied into this folder. All the February month data will be copied into this folder, etc. So now if you write the same query, select star from sales data where month equal to April, Hive will scan only this folder because it knows April month data is inside a folder called APR. Your queries will be much faster. This is called partitioning in Hive. A partition is nothing, it is a division on your table actually. So when you are saying create partitions, what is happening is very simple. Based on the partition column, those many folders will be created, and whatever criteria matching with that folder, that data will be moved into that folder. Very simple. You have to understand one more thing. So I will show you the data maybe, so then it is easy for you to understand. This is the data that I will be using for partitioning. If you take one record of this data, you will understand what is this data. So let me show you what is the data first, and then I will explain what I'm going to do. First, let's analyze the data. Look at here. This is one record. This is one record. So first name Gerardo, last name Vodka, Then 69206 Jackson Avenue, that is the address. Australia, that is the country. Then the state, primary phone number, secondary phone number, email address, and website. That is the data. Now, if I scroll down, let's say this data. Look at here. Angelicia Lovero, that is the name. The address is 689 S Steel Street, 1887 CA, California. I think California, right? And so then you have the other details. So basically, the data actually contains users' names. Okay, so I will just show you the last part of the data. Let me just show you the last part of the data. Yeah, this is US. So if you look at here, Gilma Luco and the address US, again for primary phone number, secondary phone number, email address, website. So that is the data that we are going to do. Now, there are two types of partitions. There is something called static partitioning. Static partitioning, and there is something called dynamic partitioning. Now, what is static partitioning? What is dynamic partitioning? In static partitioning, you have to manually create the partition and load the data. In dynamic partitioning, Hive will automatically detect your data and create the partition. So you will naturally think where this is applicable, because dynamic partitioning seems to be really good, because in dynamic partitioning, Hive is automatically going to create my partitions. Then why should I use static partitioning, right? So let's say you have a data like this, Raghu, comma, the phone number, and then you have email address. Then you also have Ram, something. Okay, ram@abc.com. Okay, now you also have some more data. Let's say Tina, some phone number, tina@abc.com. Now then you have Ajay. Okay, some phone number for Ajay, ajay@abc.com, comma. So let's suppose you are having this data. Now Raghu and Ram are in India, and Tina and Ajay are living in USA. But you do not have a strict column for India and USA in the data. See, in the data, all I have is name, then phone number, then email address, and website. I don't have a country. But I know that Raghu and Ram belong to India and Tina and Ajay belong to USA. In this case, what I do is that I will manually create two partitions. And partitions will be India and USA, and load the first two files in India and last two files in USA. This is static partitioning. Did you understand the use case of static partitioning? Static partitioning means you are getting the data. You know that the data is segregated. You know that half of this data is belonging to country India and half of the data belonging to country US. But that information is not present in the data, right? So what you do is that you create static partitions. Static partitions means when you are loading the data, you will ask Hive, create a partition called India, put this data there. Create a partition called USA, put this data there. Then you can query the data saying select star from my table where country equal to India. It will definitely query this partition. So this is like you're defining a column while loading the data. Now I will show you partitioning. That will be the best way to do this. So what I'm going to do is that I'm going to connect to the VM first. Okay, then let's see how partitioning is done. So now what I'm going to do is that, okay, I'm going to launch Hive first. Okay, first thing I'm going to do is that I'm going to launch Hive. So, and we have the data. I just showed you the data, right? So the first thing I'm going to do, I'm going to demonstrate static partitioning right now, right? Show databases. We have to take a database. Okay, so remember, Hue is your web interface, right? So first thing I'm going to show you is how my folder structure looks on Hadoop. Now, so I'm going to go to my root directory and user directory, and we have the Hive directory. There is the warehouse, and there is the Dell DB, and inside the Dell DB I have these folders. Now what I'm going to do is I'm going to say create a table called partitioned user. Now you can give any table name, and look at how I'm creating a partition table. This is my schema. Okay. After the schema, I'm saying partition by country and state. Look at here. So whatever columns you are using for partitioning should be outside your schema definition. So when you are creating the table, you say create a table, give the schema, no problem, that's all fine. But I'm saying partitioned by country and state. That means I'm telling Hive that, hey Hive, I'm creating a table and this is my schema, and I'm going to partition using two columns, country and state. If you hit enter, it will create a table. But look at here. If I refresh my Hue, this is the table we created, partitioned user. If I go inside the table, there is no partition. There is no partition. So when you create a partitioned table, there is no divisions. It's a normal table only. Can you see this? I just opened this table. This is the table partitioned user. If you open this, there is nothing inside that. Now, how do you create static partitions? Very simple. In order to create static partitions, what you need to do is, let me show you the data. I will duplicate this session. Root sudo su Cloudera. Okay, I'm going to use this file called static. Let me show you the file. Now this file has 3 rows of data, and I am going to load this file into my table and create partitions. Now I completely understand that this file, is copied from the original file that we had, but this is the file which I will be using for demonstrating partitions, right? If you look at here, it has only 3 records as of now, right? So you have the name, then you have the address, right? And then you have the phone number and email address, website. That's it. So what I'm going to do is, I'm going to say load data local in path. So I'm going to load this folder into this table, partition country equal to US, state equal to California. This is how you're creating static partition. I already have a table, and that table has all the schema. Now I'm saying load this file, but while loading this file, create a folder called US. Inside that, create a folder called California, then put the data. Now US is my country, California is my state, the file will be inside that. I created the table here, then I loaded the data where I said country is US and state is California, right? Now I will show you how the folder looks like in Hue. If I refresh my Hue, if I go to Dell DB, there is this partitioned user. Inside that there is a folder called country America. Inside that there is a folder called state California. Inside that my data is there. and this is the data. Now, if you look at the data, there is no country column, there is no state column in the data, but I created this so that it falls here. Now, if I query the data, I will write a query where country equal to US and state equal to California. It will land on this data and query this so that it will be faster. So these are the commands are used. First, you create the table, give the schema. Define your partition columns outside the schema. So this is what I'm doing, right? Define the partition columns outside the schema. Then you load the data. While loading the data, okay, the data you should say this data is belonging to which country, which state. Very simple. You have to give a country name and a state name. Okay, now let's discuss dynamic partitioning so that you guys are familiar with this, right? Now, what I want to do is, before you do dynamic partitioning, you have to do a couple of things. First of all, you have to enable dynamic partitioning. Now, I will show you how to do dynamic partitioning. So what am I doing here? See, by default, Hive has static partitioning enabled. That means Hive will not allow you to do dynamic partitioning. So that is why I'm typing this command, set Hive execute dynamic partition true. That means it will enable dynamic partitioning. I'm also saying that maximum dynamic partitions per node is 1000. That means maximum partitions created will be 1000. You can give more numbers if you want. It is up to you. I just use 1000 so that it sounds good. Okay. You are also saying that the partition mode is non-strict. Okay. You are having something called strict mode and non-strict mode. Okay. So I'm just saying that, you know, partition mode non-strict. Now, in order to do dynamic partitioning, like what I'm going to do is that I'm going to show you dynamic partitioning with the same set of data. Hive will allow both static and dynamic partitions. As of now, I have enabled dynamic partitions. By default, it has only static partitions. Okay. Now let's look at what I'm going to do. It's very simple, right? I'm going to create a temporary table. Now the temporary table concept in Hive is exactly similar to your normal temporary table. Okay, so how do you create a temporary table? Temporary tables are valid only till the session last. You say create temporary table, and this time I'm not doing any partitioning. You see, I'm giving the complete schema. Look at here. I'm creating a normal temporary table. No partition, nothing. Just a simple temporary table, and this table is called temp_user. So I'm creating a table called temp_user, normal temporary table, no partitioning, nothing. Once I create the temporary table, I want to load the data. So let me load the data. Now this time, what data am I loading? I'm loading this file called customerdata.txt, and that is this file. This file has country and state column. We are working on this file. This file has a column for country and state. Okay, so I'm creating a file. Then I'm creating a table, a temporary table. Then I loaded my data into the temporary table. Now, as the first step, I just want to write a query and see whether my query is taking time or not. So what I will do, I will write a very simple query. I will say select first name comma phone 1 comma city from the temporary table, where country equal to US and state equal to California, order by city, limit 5. It's a very simple query, but the only condition is that I'm using country and state just to see or just to demonstrate how much time it will take if I'm not partitioning my table. So right now there are no partitions. Okay, so let's run the query, and the query runs, of course, and let's see how much time it is taking. Okay, so this time the MapReduce job is over and it took 85 seconds. So we will see whether it is faster. Now There is also one more setting. I'm running it on a VM, and even if I do partitioning, it may not have much of an impact, but let's see. Now let me show you how to create dynamic partitions. If I go to my Hue, I go to this del DB, okay, and okay, so this is my del DB, right? Now what I want to do is I want to create a partition table. So what I will do, create table called partitioned user 1, okay, and this is the schema of my table, right? Partition by country and state and stored as sequence file. Now this is optional. You can store it as text file or sequence file or anything, that is optional. But this is the same command we used for creating static partition. When I was creating a static partitioning table also, I used the same command. But here the difference is that the data already contains the state and country column. Now see what I'm going to do. So I created a table called partitioned user, right? Now see what I'm going to do. I'm going to say insert into table partition underscore user 1 partition country comma state. So what I'm telling Hive is that, hey Hive, I want you to copy all the data from my temporary table and load it into this new table and partition it with country and state. I'm not going to tell you which country, which state, you decide, because already the columns are present. Now let's see what is going to happen. So see, now what Hive is doing, it will take the data from your temporary table, look it into the country state columns, identify the countries, identify the states, create those many folders and put the data accordingly. I will show you this now. Look at your screen very carefully. You will be able to see Hive creating these folders. So now it is creating the partitions. You will see that right now. Just wait for a moment for that to pop up.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Can you see the loading partitions, loading partitions, loading partitions? Can you see that? Country, country, state, country, state. Can you see it creating these files and folders? And done. Now if I look at my Hue, the table is called partitioned underscore user 1. If I open this table, there are 5 countries: Australia, Canada, UK, US. Okay, I mean last one you leave it. There are 4 countries. If I open the folder called country US, all the states are created wherever you had the data. If you open any of these states, you will have a file that will have only that state data. Of course, you are not able to see the file in the proper format because it is storing it as a sequence file. But this has the state related data only if that is matching with here. So now you can see that, you know, it is creating countries, and then inside country it is creating states also, and inside that the file is created. So this is dynamic partition. Now we will just see whether the query is faster right now. Okay, so what I will do, I will write the same query on the partition table, see whether it is running faster. So I'm writing the same query we ran last time. It took 85 seconds in the last time. Now the same query but on the new table, see what is going to happen. It might not be that much difference, but I guess there will be some difference. See, time taken 41 seconds. Can you see this? Last time without partitioning it was 85 seconds. Now your query is taking only 41 seconds. That is the impact on the query time when you are using partitioning.
So now let's see how do these two differ. So batch processing is an efficient way of processing high volumes of data, such as a group of transactions which is collected over a period of time. Hadoop focuses on batch processing, but as you can see over here, there is a time lag in processing this data. So the data which is generated on day 1 is processed on day 2. Similarly, the data which is generated on day 2 is processed on day 3. And on the other hand, real-time processing involves a continual input, process, and output of data. So it provides an organization the ability to take immediate action in times when acting within seconds or minutes is significant. So Spark helps in achieving this real-time processing. So again, as we can see over here in this figure, the data which is generated on day 1 is processed on day 1 itself, and there is no time lag in processing. So that's the major difference between Hadoop and Spark. So now let us understand about Spark briefly. So Spark is a cluster computing framework for real-time processing. It was Hadoop's sub-project introduced in the UC Berkeley R&D lab in the year 2009, and it became open source in 2010. And in 2013, it was donated to Apache Software Foundation. So Spark provides an interface for programming multiple clusters with implicit data parallelism and fault tolerance. So now that we know what is Spark, let's actually have a look at some of its features. So Spark is real-time. That is, it provides real-time computation and low latency because of in-memory computation. And Spark is also 100 times faster for large-scale data processing. And Spark is also polyglot. That is, you can write Spark applications in multiple languages such as Java, Scala, Python, R, and SQL. Spark also has a simple programming layer which provides powerful caching and disk persistence capabilities. And Spark also has multiple deployment modes, so it can be deployed through Mesos, Hadoop via Yarn, or Spark's own cluster manager. So now, let us look at some domain scenarios of Spark. So from small startups to Fortune 500s, almost every single company is adopting Apache Spark to build, scale, and innovate their big data applications. So let us see some industries where Spark is used widely these days. So industries like healthcare, media, finance, e-commerce, and travel are extensively using Spark to add value to their business. So now let's understand how our Hadoop and Spark use together. So Hadoop alone provided limited predictive capabilities as organizations were finding it difficult to predict customer needs and emerging market requirements. But with a combination of Hadoop and Spark, companies can now process billions of events every day at an analytical speed of 40 milliseconds per event. Companies can also enhance their storage and processing capabilities by working together with Hadoop and Spark to reduce costs by almost 40%. And by deploying a big data platform in the cloud, organizations can avoid duplication by unifying clusters into one, which basically supports both Hadoop and Spark. So now many organizations are already using Hadoop and Spark together. Yahoo, Amazon, NASA, and eBay run Apache Spark inside their Hadoop clusters. Hortonworks and Cloudera Hadoop distributions come bundled with Apache Spark. Altiscale uses Spark on Hadoop to provide big data as a cloud service. And Uber also uses Spark and Hadoop together to optimize customer experience.
So the first thing that you need to understand is Spark is comparatively a newcomer in the big data world. When you say newcomer, see Hadoop came in 2005, and then if you look at the other projects like Hive or Pig or HBase, they all came somewhere in 2007 or 2008, etc. Spark was developed in 2010. So if you look at the history of Spark, Spark was created in 2010, 2009 or 2010, you can say, at University of Berkeley. So Spark was created as a research project. So a group of researchers at the University of Berkeley, they had a project called AMP Lab project. The project is still there, and they were just trying to create uh, a distributed processing engine, and thus they created Spark. And you also have to remember that in 2010, MapReduce was the popular big data processing engine, right? Because MapReduce came in 2005 and it was, very popular at that point in time. So when Spark was created, one of the what you say goal was to create a big data execution engine, which is probably better than MapReduce. So if you really ask me where Spark fits in our Hadoop world, I would say that it actually sort of like replaces MapReduce. Even though Spark can do much more than that, but if somebody asks you like, okay, on Hadoop, where do we see Spark? Or when you compare Hadoop and Spark, where do you see it? My answer will be Spark is an execution engine very similar to MapReduce and probably better than MapReduce. So I will see Spark probably as a replacement for MapReduce, right? As a better execution engine. But like I said, that's not the complete story. Spark can do many more things, and we will get into that eventually. So in 2010, when Spark was created, it was kind of like a university project, and like I said, it was an execution engine, big data execution engine. Very soon, people found that Spark is much, much faster than MapReduce. So then what happened? The Spark project was contributed to Apache. It became an open source project. I think somewhere in 2012 or 13, it became part of Apache open source project. But again, I think it took couple of more years. People started using Spark in the industry by around 2015 or 16. This is my personal experience. As far as I know, it became popular somewhere around 2016, I would say, or 15, which means it is comparatively new, right? Because Hadoop came in 2005, and it was popular. But Spark is like in 2016. But from there onwards, it was a roller coaster ride. As of now, Spark is the most contributed and most widely used big data open source execution engine. So Spark holds many records actually. At one point in time, it has the highest ever number of committers in Apache open source projects. And today, even if you look at the industry, there is no big data project without Spark. So it's probably the most widely used big data project. Uh, Around 70% of workloads uh, in around the globe, if you look at big data workloads, are handled only by Spark. So it's probably the most popular open source project right now when it comes to big data, right? Spark is specifically designed for big data. You cannot use it for other kind of case studies. In the sense, the real advantage of using Spark is if you have huge amount of data. Like if you want to process maybe 1 GB of data, probably Spark is not the right choice. You can have other execution engines as well, right? So that is a brief history of Spark, but then the real question that people usually ask is, why should I use Spark? And this is a question that probably people need answer to. Like, yeah, Spark is probably the most used project, but why should I do it? Why should I go for it? So obviously, it's a big data processing engine. So naturally, you can think about all the use cases where big data is involved. I'm quite sure that you have gone through many case studies and all in big data, and you were probably learning that using MapReduce. So wherever you find a big data problem and MapReduce as a solution, you can replace that with Spark. Spark will fit anywhere. But what are some of the other unique features of Spark? So if I go to the website of Spark, the first thing is, let's go to the official website of Spark, which is nothing but spark.apache.org. So you can make a note of this website, because this website provides the up-to-date information, also a very nice documentation related to Spark. So the site is spark.apache.org. This is the website. And by the way, I almost forgot, the original founders of Spark. There are people like Mate Zaharia, Bill Chambers, the people who created Spark, right? These people, they went ahead and started a company called Databricks. So Databricks is the company which is created by the original founders of Spark. And Databricks basically sells Spark. So you can just go to Databricks and ask for Spark. They have a proprietary platform. It's not open source. Okay. Also, they don't sell only Spark. It's kind of like a platform, but Spark is the what you say, brain or heart or whatever of their platform. And Databricks is the leader in the industry when it comes to Spark, because these are the people who created Spark, right? So we will be using the Databricks platform for some of our hands-on. So Databricks provides a free platform for practicing Spark. Uh, you may not be able to do everything there, like all the hands-on, but some of the hands-on, we will switch to the Databricks platform and experience it there. Okay. Um, Now, when you go to the official website of Spark, you can see the definition. It says Apache Spark is a unified analytics engine for large-scale data processing. Yeah, that's the definition. We'll come to the definition. And the advantages are already written in the website. First thing you see here is speed. So Spark can run your workloads 100 times faster. 100 times faster means what? In comparison with MapReduce. So this is not always true. I mean, these are what you say benchmark numbers. There were cases where they took a benchmark and Spark ran 100 times faster than MapReduce. That's true, right? But don't think like in the industry, every time you're running Spark, it's going to be like 100 times faster than MapReduce. But yeah, it's fairly faster than MapReduce. I mean, you cannot compare them. On an average, my experience is if a MapReduce program takes, say, 1 hour, Spark will do it in 2 to 3 minutes, probably, maybe in seconds. So it's like nowhere near to Spark. So speed is definitely uh, one of the what you say advantages of using Spark, and how Spark programs are faster. So Spark does something called in-memory execution. So in-memory execution basically means, when you read the data, you keep all the data in memory. In memory means in the RAM. So as long as you're processing the data, the whole data is kept in the RAM or the main memory, and only the final result will be written back to the hard disk. When you go to MapReduce, this is different, because in MapReduce, you have a mapper, then reducer. So after the mapper phase, whatever um, output is there, the intermediate output is going to be written to the hard disk. So for a MapReduce, it uses the intermediate output. It will write and then read. So it is kind of like slower. But when it comes to Spark, it is faster. So speed is definitely one of the advantages. Second thing is ease of use. Write applications quickly in Java, Scala, Python, R, and SQL. So um, if you talk about the programming languages supported by Spark, these are the ones: Java, Scala, Python, R. Now, among them, we are using Scala because Spark itself is written in Scala. It's one of the most widely used language when it comes to Spark. There are a lot of companies, for example, JP Morgan Chase, right? They use Spark with Java. The reason for that is more or less the developers or the workforce. So if you're working in a company and let's say you have a lot of Java developers, then it makes sense to, how do I say, go to Spark and then develop programs using Java, right? And especially if you are a person coming from machine learning, data science, deep learning, you're probably going to use Python or R. So for machine learning people, Python or R are their primary languages. So Spark supports that also. However, it does not really matter which language you are using. If you write a Spark program in Scala or Java or Python, it will run exactly the same. There is no difference, right? It just depends on what background you're coming from and which languages you are comfortable. Spark also supports SQL, so SQL, right? And SQL is probably most widely used with Spark now. So you can use Scala or Java and Python. However, more than them, Spark SQL is the library which is being used a lot. And we will get eventually there, and I will talk about what is Spark SQL and all these languages and all. So ease of use in the sense you just need to learn one language, maybe like Scala, and you can work with Spark, or maybe Scala or SQL, any of this, right? Now, the next thing that I want to talk about is something called runs everywhere. And this is, I think, a question that many people have. So people may be wondering, hey, where can I run Spark? I mean, where do I install Spark, right? Spark is practically platform independent. You can install it wherever you want. All you need is a cluster. So one popular option is you can run Spark on Hadoop. And this is a widely used option. So you can take Hadoop, install Spark on top of Hadoop, and then Spark can run on top of Hadoop. And one thing you need to understand is Spark doesn't come with storage. And many people have this confusion, right? There is no storage for Spark. Spark is like MapReduce. Does MapReduce have storage? No. MapReduce is just the processing engine, right? Very similar to that, Spark is just a processing engine. All Spark says is, okay, you store the data wherever you want, give me the data, I will process it. So when you say you are running Spark on Hadoop, HDFS will be the primary storage on Hadoop. Yarn will be your cluster manager. Spark will be the execution engine. You can also run Spark on top of something called Mesos. Mesos is another cluster manager like Yarn. So what I can do, I can take a bunch of machines and maybe I don't want to install Hadoop. Okay, so I can take a bunch of machines, install Mesos on top of them. So Mesos becomes like Yarn, your cluster manager. Then install Spark on top of that. In fact, the original Spark came on Mesos. You can also install on top of Kubernetes. This is, how do I say, container orchestration, microservices and all. So if you are aware of technologies like Dockers and containers and all, Spark very well works on top of that. Or in the cloud, so many of the cloud vendors like Amazon or Azure have their own implementation of Spark. You can go to them, they will set up Spark on a cluster and allow you to use it. Or there is a mode called standalone. Standalone mode basically means you install Spark uh, on a bunch of machines, and Spark will come with its own cluster manager. So what I'm trying to tell you here is, let me take a pen thing so I can talk about it.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
Yeah, so what I'm trying to tell you is Spark requires two things. One is storage and one is resource management. So if you're installing on top of Hadoop, what happens? You will get HDFS. This is the storage, correct? On top of that, you will get what? Yarn. Yarn is your cluster manager. On top of that, you install what? Spark. This is one option, and this is very common because many companies might already have a Hadoop cluster and they probably want to install Spark. So this is your storage, right? And this is your cluster manager, and this is Spark. The second option is you take a bunch of machines. So here I will just say machines. You take a group of machines and let them be your local storage. You bring up this cluster manager, which is called Mesos. And then you install Spark on top of that. Third option, again, you take a bunch of machines and there is something called Spark standalone. And then you install Spark on top of this. So what I'm trying to tell you is all these are same. There is absolutely no difference in terms of execution, I'm saying. So Spark just says it needs to be installed somewhere. So you need to provide storage, a cluster manager for Spark to work. So one option will be I go to Hadoop. So their HDFS is my storage. Yarn is the cluster manager. Or I take a bunch of machines, create a cluster, and use something called Mesos. Mesos is another cluster manager. Or I take a bunch of machines and use something called Spark standalone. Spark standalone is where Spark will come with its own cluster manager. You are not using Mesos or Yarn or anything. Spark will have a Spark master, its own cluster manager, and gets installed in the cluster. So all three options are equally good. It's not like one is better, one is bad, or it's just your use case. That's all, right? So these are the common options you have. On top of this, you can install Spark on Spark in the cloud, as well as on top of Kubernetes and many other options, right? The other point I want to clarify is once you install Spark, so let's say you have installed Spark. One of the speciality of Spark is that it can read and write data from almost any platform. And this is, in fact, I think a great feature when you talk about the big data requirements and all. Because normally when you look at the big data requirements, one challenge is, okay, you might have data, but the data may be in different places. So Spark is capable of reading the data from, let's say, any RDBMS platform. So this can be Oracle, MySQL, Microsoft SQL, any of this. Or if your data is on top of any data warehouse. So this is like Teradata, Greenplum, Netiza, any of these data warehouses. If your data is there, Spark can read. Or you have your data on top of any NoSQL database. For example, your data might be on MongoDB, Cassandra, DynamoDB, Spark can read it. Or the data might be in any of the cloud stores, Amazon, Microsoft, Google, uh, any of these cloud, right? Or it can be even in other systems. For example, Spark can read from SAP. There is an SAP connector. Spark can read from mainframe. There is a connector. Spark can read from, if I remember correct, it can also read from Salesforce. There is a connector. Spark can also connect with almost all the BI tools. So, for example, Tableau, Informatica, Spotfire. So you see, this tool is not what we are thinking, right? Look at the connectivity options. You are saying that you can connect to almost any platform. I have listed almost everything that I know. RDBMS, data warehouse, NoSQL, cloud, SAP, business intelligence, ETL. Almost any tool you bring in, Spark will be able to read and write the data. Accordingly, Spark is being used as an ETL tool now. So there are many organizations who use Spark as an ETL tool, and an excellent one, because the challenges will be, even in the big data world, you have your data lying in many different platforms. You might want to read and aggregate them, clean them, and write it into some other platform. For example, I might have data in MongoDB. I might also have data in Salesforce. I don't know. So I want to read this, combine them, write it back to, let's say, Oracle. Spark can be used. So one of the use cases of Spark is uh, connecting to a variety of data sources and bringing the data and then transforming the data. And I will show you an example of how Spark can be used as an ETL tool in our course, right? So this is another great feature of Spark. So what did we discuss? Coming back to the discussion. So I was telling you why somebody should use Spark. Why somebody should use Spark? The speed. So definitely it is faster, and the ease of use, like you can use one language and then do anything, runs everywhere. So you can bring it up on any platform, doesn't matter. Also, it allows you to read and write from any type of data source. If this is not enough, right? See, the classic problem with Hadoop is, so we always try to compare Hadoop and Spark, but the classic problem with Hadoop is, if I go to Google and search for Hadoop ecosystem tools, let's say go to here. So have a look at this picture. So this picture talks about Hadoop ecosystem, or this picture talks about what is Hadoop, and uh, what are the tools you can install on top of Hadoop. So as you can see, Hadoop has HDFS, then Yarn and MapReduce. Fine. So this is, oops. So this is basically the core of Hadoop. Like you have HDFS, then you have MapReduce. Now the point is, when Hadoop initially came, okay, it was supposed to be a batch processing platform. Even if you look at the definition of Hadoop, you will see that Hadoop is a batch processing engine. So all Hadoop does is, okay, it takes a bunch of data and do batch processing. Now, again, for this, what happened? A lot of tools were created. So if you look at Pig,
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Pig was created so that MapReduce programs can be written easily. Okay, so there is a engine called Pig, right? Then some folks said, okay, Hadoop is great, but we want to do SQL on top of Hadoop. Okay, and that is how this tool called Hive was created. So Hive is basically what? SQL on top of Hadoop. Some other guy said, okay, you know what? Everything is fine, but we want to use machine learning on Hadoop. So for machine learning, Mahout was invented. Then some other folks said, okay, we want tools to ingest the data. Then Scoop and Flume were invented. So the problem is this Hadoop ecosystem is ever growing. So for each type of analysis, you have one tool. For SQL, people use, let's say, Hive. For machine learning, they use Mahout. For batch processing, they use Pig. So I have to learn like, I don't know, 5, 6 different tools when I want to work with Hadoop. The advantage of Spark is when you come to Spark, this is the Spark libraries we have. You just download Spark and install it. And whatever Hadoop and all these 6 different tools were able to do, Spark alone can do it for you. So Spark comes with built-in libraries. For example, if you are interested in just batch processing, okay, you are a developer, you just want to read some big data and do some batch processing, you use something called Spark Core. So this is basically what you call, this part is what you call Spark Core, okay? Spark Core is basically the execution engine. And here you get this abstraction called RDD. I was talking about RDD, right? So one of the ways in which you can program in Spark is using this Spark Core and then RDDs. So what you're doing here is you're going to Spark and you're saying that, okay, I just want to do batch processing, that's all. And I'm a developer. So Spark will allow you to directly interact with your core library. On the other hand, you say that, okay, I'm a SQL developer, then you go to Spark SQL. So Spark SQL is where you are using your SQL library. So you can create tables, write SQL queries, do join operations, just like whatever you are familiar with SQL. If you want to do real-time data analysis, you go to Spark Streaming. So Spark Streaming is where you have real-time data analysis. And this is something I guess people might not have seen. So normally in the Hadoop world also, all the tools are created to do batch processing. There is no real-time processing. Spark provides you with a library called Spark Streaming, which can do real-time analysis. And I will explain what it is later. Now, if you want to do machine learning, there is a library called, MLlib. So MLlib is the library which allows you to do machine learning. There is even a library to do graph processing. So the real deal with Spark is it is not only faster, it is not only easy to work with, it is not only something which you can install everywhere and read from everywhere, it comes with a bunch of libraries to address any kind of workload. So in the modern day big data projects, our problem is really this, and Spark solves it. The problem in modern day projects is that, I'll give you an example from my experience. Imagine you are designing a system which is going to catch credit card fraud. So credit card fraud is a very common thing, right? So, what happens? A lot of people steal the credit card, they will hack and, they do fraud, identity theft. So maybe you have a credit card, somebody will steal the number, the CVV code, then they start using it. So credit card fraud is very common. And what happens is, if I want to design a system which can catch, let's say, credit card fraud, what are the challenges? So my first challenge is this system should be real time. Real time in the sense, millions of people might be swiping their credit cards, right, during peak hours, and you want to catch it and then probably make a decision, right? So if I am getting all the credit card transactions today, if I analyze it next month, it is going to be useless because uh, this is fraud and you have to do it in real time. So I need a system which can process, say, 1 million transactions in a second and make a decision. So you can use Spark, and there is Spark streaming. Then in the credit card fraud system, I also want to implement machine learning, because usually when there is some sort of a prediction, like whether it is fraud or not, machine learning is heavily involved. So again, you can use MLlib in Spark. And in the credit card, what you say, fraud detection system, I probably want to use SQL, so I can use Spark SQL. So you see, using the same Spark, you are able to implement three-way approach actually. This is not possible in Hadoop. When you go to Hadoop, the problem is, for SQL, you have to install Hive. For machine learning, you need to install Mahout. For real-time processing, you need to install something called Storm. And integrating all these tools together is a challenge. But in the world of Spark, like I said, um, it comes with all these built-in libraries, so you will be able to perform uh, all these kind of analysis using a single tool. And that is the real advantage of using Spark. I'll get back to your questions in a moment. Also, I think probably I spoke about it, but if you look at the versions in Spark, right, Spark has three major versions. There is something called Spark 1, or the 1 dot release, we call it. Nobody uses 1 dot release, it's pretty old. Then you have something called Spark 2 dot release. 2 dot release is what people use in the industry uh, as of now. There is also Spark 3 dot. Some of the customers started using it, but it is comparatively new. We will be using Spark version 2.3.1 in our course. So now I can quickly, refresh the slides to talk about these things, right? This is exactly the same thing that I was talking about. So if I go here, yeah, this is again the same Spark architecture we were talking about. As you can see, on top, you can see the languages, Scala, Java, Python, R. Then you can see the libraries, Spark SQL, Spark Streaming, MLlib, and graphics, right? At the bottom, you have Spark Core. And like I said, it can read from all these platforms. So you have many platforms actually listed here. You have like Cassandra, HBase, MySQL, and I almost forgot one more thing. Okay, so I almost forgot one more thing, which is Spark is also capable of reading any file format. And I will show you an example for this. Uh, File formats are very important. So you might be aware of CSV, JSON, XML. So Spark can read all of this. On top of this, there are some big data file formats. We have ORC, Parquet, Avro. Spark will be capable of reading any of these file formats, right? And convert them from one format to another one as well. So then what we spoke about. So this is again the categories of Spark components. Again, same thing I was talking about. The programming languages you can see, the libraries you can see, but end of the day, the execution will be handled by Spark core engine. Then cluster manager can be Yarn, Mesos, or Spark scheduler or Spark standalone. Storage can be HDFS, standalone machine, cloud or RDBMS, even NoSQL. So one more thing you need to understand is the data need not be always with Spark. For example, you might have installed Spark on top of Hadoop, but that does not mean like you have to keep all the data in Hadoop. Yeah, it can read from Hadoop, but the data may be, some of the data may be in Cassandra, some of the data may be in cloud. Still Spark can read and process it. So like I said, it's a processing engine rather than something like Hadoop. Okay. Yeah. So what we have to understand now is something called Spark architecture. So we will build on the Spark architecture. I mean, we will understand the basics, and then, you know, we will build on that knowledge, what it is. Uh, See, usually what happens is, I might have to use my pen. So usually what happens is, when you create a Spark program and then submit the program, you definitely need resources to run the program. And I think this is something everybody agree, right? So you may be processing a 10 GB file, or maybe you're processing 100 GB file, or you may be processing data from different sources at the same time. So whatever you do, one thing is sure, you need resources to run the program. So one way to get this is from the yarn. Not one way, the only way. So who will give you resources? Resources will be given to you by the cluster manager. Let's say yarn. So we are assuming that Spark is running on top of Hadoop. So if that is the case, the cluster manager is yarn, and yarn is supposed to give you all the resources to run the job, right? And what happens in case of Spark, the resources are given to you in the form of something called executor. That is what you see in the picture. So there is something called executor. What is an executor? Uh, in Spark's terminology, executor is a combination of CPU and RAM. That's it. It is like a container given to you so that you can run the program. An executor is a combination of CPU and then RAM. So you can go to Yarn and ask for as many executors as you want. Also, you can decide what is going to be the configuration of the executor, like how much RAM, how much CPU cores, all you need. And this has to happen depending on the data that you are handling, right? So depending on the data and the complexity of the program, that you're written, you can probably ask for this. So typically the executors are allocated based on the decision of yarn. Now this is actually a very crucial thing, but in my experience, you will not be the only person who will make this decision, right? Because let's say you created a program and you want to run the program in a cluster. Now, you may be reporting to somebody, or maybe someone else will also be responsible for, running this program, right? So you are probably not the only one who thinks, okay, I can run the program. Now, executors can be launched on each of the machine. So if you have 100 data nodes or 50 data nodes, on each of them, executor can be launched. And there is a calculation that typically you use. To show that calculation, we need a cluster. So I'm just going to use a cluster that I know. Don't worry about this. So there is something called CloudX Lab. So I'm just going to log on to this lab so we can see what the resource policies are in this cluster. Let's try to log in. So the executors are allocated by yarn. So you need to go to yarn. Okay. You go to yarn and you will be able to see some of these options here. I don't know where to find it. Let me just check in this cluster. So if I go to yarn, non-manager, if I go to configuration, yes. So see, first thing you need to understand is if you go to what you say yarn, you can find these requirements. There is something called memory node. Memory allocated for all yarn containers on a node. So there will be restrictions. Okay. So in this cluster, what you see is memory allocated for all yarn containers on a node is 9 GB. So you can see this value. This value is 9 GB. So maximum 9 GB is in this cluster. In the real world, it might be bigger. Okay. In this cluster, maximum RAM that can be allocated for an executor is 9 GB. Minimum is, okay, so that is for all yarn containers on a node, right? And then there is a minimum container size and maximum container size. So you can set it individually. So minimum is 128, maximum is actually 5 GB, right? So all containers put together, it should not cross 9 GB total. For an individual container, right, minimum 128, maximum 5 GB is the size. So let's take these things in account so I can write it. So on a machine, maximum memory of all executors put together. In this cluster I'm talking about, okay, executors is 9 GB. Minimum memory for one executor is 128 MB as per this cluster. Maximum memory for one executor, that is 5 GB as per this cluster. Okay, you also have settings for CPU. So if you scroll down, this is CPU. So you can see minimum container size is 1, maximum container size is 8. So for CPU, what they say is minimum CPU for one executor is 1. Maximum CPU for one executor equal to 8. Okay, so these are the settings. This is set by your administrator. That is why I'm showing this page. See, this is the yarn page of this cluster. So you can see the total RAM for all the executors together is 9 GB. Minimum RAM is 128, maximum is 5 GB. And minimum CPU core you can ask is 1 core, maximum is 8 core. So you need to first understand this, then only you can ask for resources. Now this may change for different clusters. And these are very small numbers because this is a training cluster. In the real world, this might be in gigabytes and very big numbers, but you need to understand this. And now if you come to this picture, what you do is typically when you are creating a Spark program, you create a Spark program, and within the program, you will be able to set all these numbers. I will show you how that can be done. But typically when you write a Spark program, within the Spark program, you will be able to ask resources to run the program. And when you launch a Spark program, what is going to happen is, take my pen, there is something called driver program. You can see this blue box. The driver program will start on one of the machines. So I'm just assuming this is my data node 1. So remember we discussed about driver program even in Scala. What is the driver program? The driver program contains settings to run the program. So this can be, for example, the resources you are asking, the compression that you are using. All this is part of the driver program. So typically what happens is the driver program will initialize on one of the machine, and it is going to create an object called Spark context. So Spark context is basically an object. Okay, it is an object, and this will be initialized by the driver program. Now, why do you need this object? Because once this object is initialized, you can see using this object, the driver program will talk to your cluster manager. The cluster manager in this case is, let's say, Yarn. So driver program starts first. It will initialize the Spark context object. Using that object, it will connect your cluster manager Yarn, and then the driver program will negotiate resources from Yarn. So in this simple example, you can see there are two executors. So the driver program is going to Yarn, will go to Yarn and say that, hey, you know what? I need two executors. And you will also say that, let's say each executor, let it have 8 GB of RAM and 8 CPU. As an example, I'm giving. So each executor, you are assuming you have like 8 GB of RAM and 8 CPU. So the driver program will go to Yarn and say that, hey, Yarn, in this program, the developer has asked for two executors, each with 8 GB RAM, 8 CPU. So Yarn, what it is going to do, it will launch these executors. Now, you really don't have any control here. If there are no resources, right? So suppose sometimes what happens, your cluster may not have enough RAM. Then what will happen? Yarn will not launch any resource for you. Your program will wait in the queue. Nothing will happen. But assume you are in the ideal environment where there are resources in the cluster. What Yarn will do? Yarn is going to launch two executors. Now, again, there is no control as to where these executors will be launched. Yarn can even launch both the executors on one machine. Quite possible. That depends on the discretion of Yarn. But let's assume that in this ideal example, Yarn launches one executor on each of the data nodes. So this is my data node 2, okay? And this is my data node 3. These are 3 data nodes in the cluster. So Yarn launches one executor on data node 2, one executor on data node 3, and each executor has 8 GB RAM, 8 CPU cores and all. And now your driver program will push the business logic in the form of something called task. So if you're wondering what is this task, when we write the program, I will show you. But if you write a Spark program, it will be broken down into smaller pieces of unit called task, which can be executed. So the driver program, now since it has got the resources, it starts pushing these tasks to the executors and they execute it parallelly. Once the program execution is over, the final result will be sent back to the driver program. So driver program is the one which will be getting the final result or output or whatever you call. So driver program gets the final output, right? And then the executors will be deleted. Executors are only required at runtime. You don't need them like all the time. They are only required at runtime. Once your processing job is over, executors are also deleted. Now the question will be, how do I know how many executors I need? Well, there is no hard and fast answer to this. Okay, so next question will be, okay, I got the idea. You're saying that to analyze the data, you will ask for executors, but how do you know that you need 2 executors? Or better, how do you know that each executor need 8 GB RAM? Like, what is the logic that you're using here? Well, the logic is something that probably has to come with experience. To give you an idea, if you have a 50 GB file, let's say you have a 50 GB file to process, I can ask for even a single executor with 50 GB RAM, but that is probably not a good idea. So as an example, what I'm going to do, I will launch 5 executors. This is just an example. Okay, 1, 2, 3, 4, and 5. So this is my executor 1, executor 2, executor 3, 4, and 5. So I'm going to launch 5 executors in this example. Each executor gets, let's say, 10 GB RAM. So each are going to get 10 GB RAM. Also, each executor will be getting 10 CPU cores, assume. So I'm just going to say 10 CPU core. This executor, 10 CPU core. Again here 10 CPU, 10 CPU, 10 CPU. So I have requested for 5 executors, each with 10 GB RAM and 10 CPU core. Now the problem is how this 50 GB file will be loaded in 5 separate machines or 5 executors. So Spark uses a concept called partitioning. Spark has a concept called partitioning. Partitioning is nothing but dividing your data. That's all. So when you are reading this file, 50 GB file, you can ask how many partitions you need on this file. So I'm going to say that, okay, I want to divide this file, this 50 GB file, into 50 partitions. So when you say 50 partitions, each partition will be like 1 GB. Okay. And then what is going to happen? partition 1, then partition 2, partition 3, up to partition 10 will be loaded here. Again, partition 11, partition 12, partition 13, up to partition 20 will be loaded here. Partition 41, partition 42, all the way till partition 50 will be loaded here. That is how the processing will happen. So I think I spoke about too many things at one time, and maybe people are kind of like confused probably. So I will reiterate what I'm trying to explain. So first thing is, how do you decide the number of executors? Now there is no hard and fast number, like I said. In this example, I'm calling for 5 executors to fit 50 GB data. So rough figure will be, if you have 5 executors with 10 GB RAM, you fit 50 GB data. You can also ask for 10 executors with 5 GB RAM, right? That also works. But normally the rule is the number of executors should not be too less or too more, what you call, right? See, if the number of executors are very less, like you're calling for 1 executor, then only 1 machine will be participating in the processing, and it will be very difficult to process the data. If the number of executors are more, for example, for this 50 GB file, I can call for 50 executors. Absolutely possible. But if I call 50 executors, the problem is there will be a lot of data shuffle operation. Sometimes, say you are using Spark and you do a join operation, the data might have to travel from one executor to another executor. So if you have too many executors, that will be a problem. So I came up with a number 5.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, that is my golden number probably. Each executor get 10 GB RAM. So 50 GB can be accommodated there. Now the most important point here is processor. Processor. Why processor is important? First of all, processing has to happen, right? Data needs to be processed. So you need CPU. The second reason is CPUs are not easily available, meaning I can have a server with 200 GB RAM. I cannot have a server with 200 CPU. Check it out. I don't think it is possible. CPUs are limited. Okay, so when you plan your processing, you should consider CPU. It's not possible to process your data if you have only RAM. RAM cannot do processing. So that is why in this example, for each executor, I have allocated like 10 CPUs, 10 CPU core. So now the rule is you have 10 CPU core, and ideally each processor core can process some data. That is where partitioning comes into picture. So this 50 GB file, when you're loading in these executors, you can partition them. And I will show you how to do this practically, but you can basically run a command and the file will be split or partitioned. So I decide 50 partitions so that each CPU core in an executor get 1 partition to process. That is ideally how you should design. So when you have a processor core or a CPU core, it has to work with 1 partition. And there is no golden rule as to what is the size of a partition, but 1 GB is something typically we can consider. Even it can process 2 GB or 4 GB, but in this simple example, this is what we do. Now, you don't have to break your head if you don't understand this. These are some ground rules. And also, you don't decide this on your own. You cannot go to your company and say that, okay, I learned Spark, I'm the boss, I'm deciding partition. You will be fired the next thing. So you need to take permission from people to do all this, because this all affect the cluster, right? So yeah, your theory might be correct, but you need to, discuss this with other people, maybe your administrator. You ask your administrator, hey, I have 50 GB data. I'm going to launch 5 executors. Will it work? He will say, no, it's not going to work. Increase it to 7. Some reason, right? So you need to adjust all this. But end of the day, the total RAM among all the executors should fit your data, and the CPU cores should process each partition. That's kind of like the rule. Okay, I'm bored with theory. Let's go to hands-on. Since we spoke so much, I thought I will do something. I will show you what? Okay, let's open the Intellipaat VM. I'm just going to open this Intellipaat VM. But I want to show you a couple of things before we get into the actual hands-on kind of thing. So I'm starting the Intellipaat VM, and I am connecting with the VM. Intellipaat VM.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
And in order to work with Spark, there are many ways. If you want to write a Spark program, you can always use an IDE like Eclipse we have seen. So you will be able to develop your Spark program using an IDE. I will show you that. But more than that, Spark also provides us with an interactive shell. So if you want to work with Spark using Scala, all you need to do is just type this command spark-shell and hit enter. So this command spark-shell, this is going to launch something called Spark Interactive Shell using Scala as the language. So once we get the Spark shell, we will be able to type the code and execute it and see and all. So as you can see, when I type Spark shell, you can see the Spark version is, okay, it's 230, not 231. That's okay. So you see Spark has started. Version is 230. And you can see the Scala interpreter. So basically, Spark has started, and I'm using this Scala language to write programs on top of Spark. So one thing I wanted to show you today was that you can just type spark-shell, and then you get an interactive shell for Spark. And also you see something here, it will be written Spark context web UI available at this location. So whenever you start the Spark shell, Spark also gives you a web UI. It will be available in 4040 port number. I can just copy this, go to my browser, paste it, and there you go. So this is the Spark UI. And as of now, you don't see anything in the Spark UI because, typically when you run any program or any logic, then only Spark UI will display something. As of now, the UI is completely empty. We are not going to run a program, right? And I can exit from here. Now, if you are a Python developer, there is something called PySpark. So PySpark is where you will be working with Spark using Python. So in order to get the PySpark shell, you can just type PySpark. So I'm going to just type PySpark, hit enter. And what happens here is, again, the Spark shell will be started. But now you can see again Spark came, but you don't have Scala here. You have Python. So now are you able to understand the connection between Spark and the languages? Spark is the execution framework, and you can program in Spark using any language. So this is your PySpark. So I just typed PySpark and this started. And now I will be able to type Python commands here. They will be executed by Spark if I want to do that. Well, I think we will not be using PySpark. So I will exit here. Let me start this Scala shell once again, because I want to show you one more thing. So we will be working with this command called spark-shell, because this will bring the Spark interactive shell in Scala. And this is where we will be spending most of our times. And I want to show you one more thing. So when I start Spark, it says that the web UI is available in 4040. You can see that the version is 2.3.0. It also says Spark context available as SC. What is this Spark context? Go back to the diagram. So Spark context is this object using that your driver program is communicating with the cluster manager. So normally when you start this Spark shell, the Spark context will be automatically created for you. So you can see Spark context available as SC. SC is the name of the Spark context object. Also, you see something interesting. It says master equal to local. What is this? There is something called local mode in Spark. What is local mode? In local mode, Spark will run only on one machine inside a single executor. So driver, executor, everything is going to be inside a single machine, single JVM. That is local mode. Why? This is good for learning, development, testing, and all. Local mode is great if you want to experiment with Spark. See, if you want to learn Spark, you don't need 100 node cluster, right? Spark will behave exactly whether you are running it on one machine or 100 machines. So by default, when you start Spark, you see it is starting in what? This local mode. Now you can do everything in Spark using local mode, but the difference here is, like I said, it is using our Intellipaat VM. Intellipaat VM is one machine, so you are not actually getting a cluster. But I wanted to show you a cluster as well. What I'm going to do, I'm going to use Google Cloud. Well, any cloud platform will do. But if you go to Google Cloud, okay, I have an account with Google Cloud. You don't have to do this, don't worry. If you go to Google Cloud, they allow you to quickly launch a Spark cluster. It's very nice. I'll show you. So you can go to Google Cloud. There is a service called Dataproc here. I go to this service called Dataproc, and I can ask Google Cloud to give me a Spark cluster, Hadoop and Spark cluster. How? So it says here, Google Cloud Dataproc lets you provision Apache Hadoop clusters and connect to underlying data stores. It will come with Hadoop and Spark. So I can just say create a cluster. Okay. And I can give a name for my cluster, not required right now. And cluster type is like one master and n worker. meaning you will have one master and n number of data nodes, what you call. Scroll down, enable component gateway. I can go to configure nodes, and you can select whatever type of machines you want in the cluster. So I'm going to use this N1 machine. You get like 4 CPU, 15 GB memory. Okay. And hard disk space, I don't need like 500. I can ask for some 30, right? Then worker node also, I will say 2 worker nodes, just 30 GB hard disk space, say create. See how easy it is. So now Google Cloud is creating this cluster and this is chargeable. Don't try if you're not aware of cloud computing. This is chargeable, highly chargeable. Okay. I think for running this for an hour, they charge $10 or something, even more than that sometimes. So this is highly chargeable, but very easy to demonstrate something like this. So now what Google Cloud is doing, they're creating a cluster for us, right? So you can see the cluster is provisioning, right? And it is happening. Meanwhile, I need to check something. Let's look at Stack Overflow. Okay, anyway, go here. The cluster is running anyway. So we have the cluster running, and why I wanted this cluster is I can just go to the cluster, and in here, what I want to show you is, where is the VM instances? Let me connect with the cluster. So how do you launch the Spark shell in the cluster mode? That's basically what I wanted to show you. So in the Intellipaat VM, when I say, okay, start the Spark shell, you're getting something called local mode, right? So here, since we have a cluster, what I can do is I can say Spark shell, then I can say hyphen hyphen help. So if I take help from the Spark shell, you see a lot of interesting things here. For example, the master URL. So the default master is client, meaning by default, Spark shell is going to start in the client mode. Okay. Sorry, local mode. Sorry. So the default is local mode for master, but you can ask for Mesos as your master, Yarn as your master, Kubernetes as your master, Spark itself as your master. So we will say start the Spark shell and we will say master is Yarn because we have a cluster. What else can you do? Look at this. Driver memory. So how much RAM or the main memory you should give for the driver? So that is the driver memory. And look at this, executor memory. So how much RAM you can ask for the executor? Then here is the driver cores. The CPU cores you can ask for the driver. And here is executor cores. So let's try to launch Spark shell like this. I'm going to say Spark shell. The master is Yarn. And I'm going to say number of executors, 5. I need 5 executors. Then I'm going to say executor memory 2 GB. Then I'm going to say executor cores 2. Executor cores 2. Then I'm going to say hyphen hyphen conf. Now I need to put this. Spark dynamic. Yeah. Hey, this is enabling. I will try this hyphen hyphen conf I need to give. I think this will work. Let me just check. Give me a minute. to force. I will tell you what I'm doing. So what we are doing here, we are launching a Spark shell, and we are saying that, okay, hey, go to yarn. Okay, just go to yarn and ask for 5 executors, each having 2 GB memory and two CPU cores. So I will tell you what is this dynamic resource allocation, but you can see this started. And now if I go to Spark UI, I will be able to find it. So how do I find this in the Spark UI? I can go to web interfaces. I can go to resource manager, go here. And this is the Spark shell. I open this. I go to this UI. Okay, so you got the Spark UI in the Google Cloud. And here, quite interestingly, expand this event timeline. Can you see there is something called event timeline? And if I expand, it says executor driver added. So this is your driver, which started first. Then you have executor 1, 2, 3, 4, 5. So you can clearly see that we asked for 5 executors and Spark launched it. So first the driver will launch, it will negotiate with yarn, get 1, 2, 3, 4, 5. So you're getting 5 executors here. You can also go to this executors page here, and it'll show you all the executors. If I scroll down, see, this is my driver. This first thing I'm highlighting is the driver. And below this, you can see 1, 2, 3, 4, 5 executors are there. So these are all my executors launched, 1, 2, 3, 4, 5. Okay. So this is something I wanted to show you. Like practically you can see these executors and all, something I just wanted to show you. So you can clearly see here, 1 driver added, then 5 executors. So I will probably delete this cluster because otherwise this is chargeable. So I'm just going to delete this Google Cloud cluster. It's actually chargeable. The Scala programming language. Scala, what is Scala? There is a car by the name Scala, by the way, but I have never heard a Scala as a programming language. What is it? Who created this? When did it come? You know, you tell me Python, you tell me C# or Java. I know this. What is Scala? I never even heard about it, and you are going to talk about it. Well, honestly speaking, Scala is a very popular programming language, but you know, it is really popular in the big data landscape. Okay, so if you're even in the traditional world, there are projects which use Scala, but in the big data landscape, Scala is extremely popular. Now, the first question that probably I need to answer is why somebody created a language called Scala. Because there are too many programming languages in the world, then why did you come up with another programming language? So Scala was created somewhere around, I think, 2004 or 2005, roughly around that. And the real reason for Scala was, I would say, in a way, Java. So if you look at the industry, probably around, 2001, 2002 and all, the industry largely had two type of programming languages. Okay. So one type of programming languages were languages like Java. So if you look at Java, Java is in fact one of the most popular programming language, right? And Java is platform independent. Most of you might be aware of that. You can install Java wherever you want. And Java programs are highly optimized. But the problem with Java, now I don't call it as a problem, is that it is very difficult to learn. Now, if you are a newcomer in the programming world and then you try to learn Java, then it's gonna be hard. It's not that easy to learn Java, right? So on the other hand, you had other type of languages, for example, like Python. So the advantage of Python is it is more or less like a scripting language. It's very easy to learn. Anybody can learn practically. So Python code is more or less written like you write English. So the way you can learn Python is very easy. On the other hand, Python lacks some of these optimizations which, uh, you know, Java provides. So you have like two type of languages. One is probably languages like Java, which have all the benefits of platform independence, optimizations, but they are kind of like a little bit hard to learn. On the other hand, you have languages like Python, which are like super easy to learn. But Python lack a lot of optimizations that languages like Java provides. So Scala came as a language which takes the best of both worlds. So to put it in the technical terms, I would normally say that Scala was the first programming language which supported both object oriented and functional programming styles. So this is the real reason why people started using Scala. So Scala was the first programming language which started supporting something called object-oriented programming and functional programming styles. Now, object-oriented programming is not something new, right? What is object-oriented programming? Languages like Java, C++, they support object-oriented programming, right? In object-oriented programming, we represent classes and objects, or we create classes, and ideally everything should be an object, right? So this is the traditional way of programming, which is known to people, right? There is another way of programming, which is actually called functional programming. Now, I will come to what is this functional programming later. I mean, an explanation and what it is. I will come to that in detail. But functional programming is a way of programming in which you try to minimize the number of lines in your program, right? And you will be using a lot of variety of functions. Like the name suggests, it's called functional programming. So with the use of proper functions, you try to reduce the number of lines of code, and that way of programming is actually called functional programming. There are a lot of more aspects to functional programming apart from this, but in a one-liner, if I have to define, I would say functional programming is a way of programming which is fairly easy compared with object-oriented programming. So Scala was the first language which started supporting both styles of programming. And Scala was modeled after Java. So Java was already there, and when Scala was developed, a lot of libraries in Java were reused in Scala. So if you are actually coming from a Java background, you will find a lot of similarities in Scala. However, Scala is a language which is comparatively easy to learn and easy to work with. Now, when it comes to the performance benefits of Scala, right? So first thing we need to understand is that it supports something called object-oriented and functional programming styles, which means if you are an object-oriented person, you are familiar with classes, objects, and inheritance, and all these concepts, you can definitely use Scala, no problem. You can also use it for your functional programming kind of projects. Now, the second interesting point is when you write a Scala program, okay, and then you compile it, the compiled program can be executed on top of something called JVM, or Java Virtual Machine. So you remember, if you're writing a Java program, what happens? Any Java program you write, you compile the Java program, it will create something called a jar file, and the Java program requires something called JVM. Scala programs also run exactly on the same JVM. So what is this JVM, or Java Virtual Machine? JVM is a platform where your programs can run. The beauty of this is JVMs can be installed on almost any kind of hardware software combination. So the real reason Java programs are platform independent is because you are able to run them on top of JVMs. So on the same line, Scala is also platform independent. So wherever you are able to run a Java program, you can run a Scala program as well. Because as long as you have a JVM, you will be able to run a Scala program. Also, the JVMs provides extraordinary performance tuning. So when it comes to the performance benefits of Scala, it is actually contributed by the JVMs. The real reason why Java programs are so optimized is because they run on top of this JVMs. So Scala programs also can benefit from the JVM architecture. So when you write a Scala program and compile it, you can basically execute it on top of a JVM. So that advantage is also there. So Scala programs, they can be written in object-oriented and functional. Scala programs usually are easy to write. Scala programs can be platform independent. You can run them on top of Windows or Linux or any platform you want because they support JVMs as the platform. Scala programs are also performance oriented because the JVMs allow you to do performance optimizations, right? And usually when you want to work with a language, any language, Scala as an example, the best way to start working with the language is that you start, doing some hands-on with the language, right? So what I'm going to do is, Intellipaat has a virtual machine, right? So you will be able to install Scala on the Intellipaat VM. Now I know that some of you might have already installed Scala. In that case, it is fine.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
In case if you have not installed the Scala, don't worry, I will help you to install. So we will be primarily using this Intellipaat VM as our platform. So what I have done, I have already installed Scala on the Intellipaat VM. So I'm just going to connect with the Intellipaat VM. Okay, so I just logged on here. And you will be able to install Scala if you run a couple of commands. I will share that with you. Once you have installed a Scala, the beauty of Scala is Scala provides an interactive shell. So if you're coming from the Java background, normally what happens, if you want to write a Java program, you always use an IDE, right? Something like Eclipse. Eclipse is an IDE for Java. Now, Scala also supports IDEs, but Scala supports this interactive shell. So I can just type Scala in the command prompt, and what will happen? You will be getting something called the Scala shell. Now, don't worry, I have a small error. Don't worry about it. But as you can see, I have just launched the Scala interactive shell. So the easiest way to get started with Scala is using the Scala interactive shell. You can just type Scala in the command prompt and it is going to start it. I will also show you the IDE for Scala. Don't worry, we will discuss about that. But we will first start with the interactive shell. Okay, so when I start the Scala shell, I want to show you something interesting. What is interesting, right? So I'm going to type something. I'm just going to type 2. So all I did is I typed the number 2 and hit enter. And what you see here is Scala says, hey, you know what? 2 is an integer. This is very interesting. This means Scala can automatically figure out the data types, right? So I never told Scala that 2 is an integer, but what happened? Scala came back to me and said that, okay, did you just type 2? Okay, so 2 is an integer. And this will work for anything. If I type, let's say, oops, sorry. If I type something like 10.3, Scala will tell me that this is a double. If I type something like A, just in single quotes, Scala will tell me it is a char data type. If I type something like Raghu, Scala will tell me that it is a string. So one of the features of Scala is what we call dynamic type inference. So this feature is actually called what? Dynamic type inference. So we are talking about dynamic type inference. What is this? Dynamic type inference means Scala is able to dynamically guess the data type. So anything that you type or feed to Scala, it is able to figure out the data type. Now you may be wondering, what is this RES0, RES1, RES2, and RES3? These are system generated variables. See, normally you will say something like A equal to 2, right? So normally when you declare a number like 2, you will assign that to a variable. Now I'm not assigning to any variable, I'm just typing 2. So Scala will create a variable called res0. It's actually called result 0, right? And assign this to me. Don't worry, in the real world, we will not be what? Declaring variables like this. We will be doing proper variable declaration, and I will show you how that works. I just wanted to show you that Scala can automatically guess the data type. Also, using the Scala shell, you can do basic mathematical operations and all. For example, I can just say 100 plus 2, and Scala will do the math and tell me that it is 102 and the data type is integer. So the Scala shell is very interactive. You will be able to perform a lot of operations here. And the point that I wanted to clarify here was that Scala has this dynamic type inference. Now, this is very similar to the language called Python. If you are a Python developer, right, then Python also has the same dynamic type inference. So when you go to Python, you just declare a variable and Python will also detect the data type. But there is a difference here in Scala, and I will come to that in a moment. Okay. Now, the next thing that we need to understand is about variables in Scala. So there are two types of variables in Scala. So normally in a programming language, we typically say there is only one type of a variable. But when it comes to Scala, there are two types of variables. One is what we call immutable variable, and this is represented as a VAL. Second is called mutable variable, and this guy is represented as a VAR. And this might be something which is a little bit confusing initially, but I'm quite sure all of you will really get along very well. Only in Scala I have seen this. Now I may be wrong, my experience also matters, but I have never seen this in other programming languages, because in every other language, when you want to declare a variable, you just say a equal to 100. So when you want to declare a variable, you will say something like a equal to 100. But in case of Scala, you need to say this a is a val a. It can be a val a equal to 100, or it can be a var a equal to 100. You can never say just a equal to 100. The a has to be either a val, a val, or a var. What is this val and var? So if you go back to the Scala REPL, we can try to see that. So I can try to declare a variable. I'm going to say val a equal to Intellipaat, let's say. So now this is how you define a variable in the proper way. I just said, okay, val a equal to Intellipaat, right? So as you can see, Scala is able to tell you that a is a string value. So there is dynamic type inference, fine, no problem. And the value of a is actually Intellipaat. Now, whenever you declare something as a val or a val, it's immutable. Immutable means something which you cannot change. Meaning, if I try to do this now, if I try to say a equal to, let's say, spark or anything, what will you see? You will see error reassignment to val. So once you declare something as a val, it cannot be modified. Val is immutable. And there are certain situations where you will use them. Maybe when we start discussing Spark, I will come to more details about this. So usually people have a belief that programming means when you have variables and you should be able to modify them. And naturally people will be having this question, hey, what is the use if I declare something then I'm never able to modify? So there are some special use cases, especially in the big data world. When we start discussing about Spark, maybe I will come to that. But as of now, just be aware that when you say val, it is immutable. On the other hand, I can say var b equal to Hadoop, and then I can say b equal to MapReduce. So as you can see, when I declare something as a var or a var, right, I'm able to modify that. So var is what we call mutable. So if you're coming from the Java background, these are very similar to Java final variables and non-final variables. Or you can consider them like constants, for example. So whenever you have a val attached, they are more or less like a constant. Whenever you have a var attached, that means you will be able to modify them. However, most people understand this. This is a concept that most of the people get it, because you just need to remember which is mutable, which is immutable. That's all you need to remember. However, there is a catch here. And I think you have to be very careful. What is the catch? The val is fine because once you declare something as a val, you can forget about it because you are not going to change it. When it comes to var, the VAR, I just told you that you can modify, but it comes with terms and conditions. What do you mean by terms and conditions? See, I just said B is Hadoop. Fine. But if I try to do something like this, I will get an error. Why am I getting an error? You just told us that you can modify B. Yeah, I told you. However, there is a catch. What is the original data type of B? It is string, right? So this basically means you will be able to modify the value of B, but it has to be a string. So I was trying to assign an integer. Then what happened? I got a type mismatch error. It did not work, right? So this is what we call static typing. So this technical term for this behavior is called static typing. And sometimes people will say Scala is a statically typed language. What do you mean by that? This means once you declare a variable and assign a type, it remains the same throughout the scope. So when I declared B initially, B became a string. This means you can modify the value of B, but it has to be another string. Okay, so that is what you call static typing or statically typed programming languages. Great. So what did we learn about variables? We learned that whenever you declare a variable, there is this feature called dynamic type inference, where Scala will guess the data type. We also saw that there are two types of variables in Scala. There is like immutable and then mutable variable. And there is one more thing that probably I tell the audience, which is I can definitely declare a variable like this. So I can definitely declare a variable saying val z equal to 100, and it works. And Scala is also able to tell me that the data type is integer. But what I have seen in the production is that when you declare a variable, you don't want to, how do I say this? You don't want Scala to guess the data type. See, if you're so sure about the data type, then why do you want somebody to guess it? So a better way of writing the same code will be, you can say val z, it is integer equal to 100. So you will be able to mention the data type rather than Scala guessing the same. It is your choice. Okay. If you just say Z is 100, Scala is definitely going to guess it. I know that. And it is going to be correct. But a better practice will be like this. Now, why this is a better practice? Two reasons. One reason you are sure, right? You don't want the language to guess. If you know that Z is an integer, you declare Z as an integer. One reason. Second reason, if you already give the data type, then the compile time can be less. Because sometimes what happens, Scala has to take a lot of time. This might be microseconds, but still it matters to figure out the data type, right? So if you're so sure about the data type, then why you want somebody to guess it, right? So you will see sometimes when you look at Scala programs, people will hard code the data type. And I think that is something which you can justify. Even I do that sometimes. Okay. Sometimes during the classes is that, hey, you just told that you will be teaching us Scala for 2 classes. Why 2 classes? Can't you teach like 5 classes of Scala, right? So that we become like experts in Scala. Honestly speaking, I don't want you to become an expert in Scala. Now, a trainer should not say this, but I really don't want you to become an expert in Scala. And this is a statement which is very dangerous. There are many reasons for that. First of all, when it comes to Spark, right? See, why are we learning Scala? We are learning Scala so that we can work with Spark, right? In Spark, when you go, you will see that the majority of programming can be done using SQL, right? So SQL is primarily what we use in Spark. We also use Scala, but in the latest versions of Spark and all, predominantly it is SQL, not Scala. That does not mean you should not learn Scala. If you learn the basics, you are going to be just fine. The second reason is when you start working in the industry, like I said, maybe you're working in a company, they may be using Java for Spark. They may be using Python. They may be using R. So the language might change over the period of time, right? So the programming language, especially in the big data world, usually what people do, they just get a basic idea, right? And then whenever there is a necessity, you can learn if you want, right? And that is exactly the reason we spend probably only 2 days on Scala, and then we go to Spark. And when we actually start Spark programming, you will understand why I told all about this. Okay, great.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
One of the other reason you are learning Scala is the source code of Spark is written in Scala. The Spark framework, one of the most used big data framework in the world, itself is written in Scala. So it probably justifies somebody learning Scala and programming in Scala because Spark itself is written in that. If you go to Hadoop, right, you have this MapReduce, right? And when people learn MapReduce, they learn MapReduce using Java. Maybe some of you have gone through MapReduce classes. And have you ever wondered why you are learning MapReduce using Java? One of the reason is because Hadoop itself is written in Java. So it makes sense to actually program in Java because it is more native, right? So probably this is also a similar reason. Spark itself is written in Scala. So accordingly, Scala is a very popular language among the Spark developer community. Okay, we will probably talk about it later. I will just talk about one more concept and then I will get back to your questions. I know that there are a lot of questions. There is one more interesting thing in Scala, which is what we call a block expression. And this is something I might have to show you. So in Scala, you will be able to type something like this. So I can say add equal to, let's say where a equal to 10, where b equal to 20. Then I can say a minus b. Oops, I think that might be an error. A plus b. Yeah, definitely it's an error. I'm sorry. I have to rewrite it. There is no other way. A add equal to, I'm sorry, where a equal to 10, where b equal to 20, a minus b, let's say a plus b. Yeah. So what is this? This is what you call a block expression in Scala. And I think this is something which is very common in almost every programming language. Like maybe you are uh, talking about Java, right? Uh, or even C, right? You see this flower brackets, right? This is called a code block or a block expression, right? In Scala, when you write a block expression, you can see I'm writing it line by line. one thing that you notice here is that there are no semicolons at the end of the statements. So in most of the other languages, when you write something like this, you keep a semicolon at the end of this statement. In Scala, semicolons are optional. You don't have to use them, right? The second thing that I want you to understand is when you write a code block like this, the last expression is always evaluated and assigned to the variable. So now the last expression is a plus b. So that is 30. So that value 30 is being assigned to this variable called add. So I just want you to be aware of this. Okay, so you will find it in many places in Scala that people write a code block like this, and they will be assigning that to an entire variable. So this variable will be taking the value of this last expression that you have inside the code block. So here the last expression is a plus b. So even though it will evaluate a minus b, it is not going to assign that to anywhere. So the last expression here is a plus b, and that is what is going to be assigned to this variable called add. So you can have an entire code block, and then the value of that code block can be assigned to a variable. So this is actually what we call a block expression. This is called a block expression. And with that, we will probably come to one thing. I just wanted to discuss one more concept, okay? And probably I will, maybe I will ask you to guess the output. I'm going to write something, and what I will do. So Scala supports something called a paste mode. There is something called a paste mode. So if I want to write like 3 lines of code in one shot, I can go for a paste mode, right? So what you can do is you can just type colon paste. So when you type colon and then paste, you can see that you will get a message entering paste mode. And what I'm going to do now is I'm going to type 3 lines of code, and I want you to guess the output, just to be familiar. So what I'm going to do, I'm going to say val x equal to, I will say, I want to print a line, foo, then 10. Then I will say, I want to print bar, then I will say print x. So this is the 3 lines of code that I have written. Can you tell me if I run all these 3 lines, what is going to be the output? Now, this is a block expression, okay? And these are print line statements, which basically print line by line. 3 lines of code, right? So how do you execute these 3 lines of code, right? You can see here, it says Control D to finish. So when you are in the paste mode, if you press Control D, it will execute all 3 lines. That's how you get the output. Okay, so I will try to do a Control D. This is the output. Foo bar 10 is the output. So I think some of you like Anuradha, then Leta, they got the correct answer. It's fine. Some of you may not have got it. Now, if you're wondering, how did you get this output? First thing, this is a block expression. So value of x is going to be what? 10. Value of x is going to be 10. Okay. And since there is an explicit print statement, it will print. So the rule is whether it is a block expression or not, when you have an explicit print statement, it's going to print. So first line is going to be foo because there is a print of foo. Second line is going to be bar because the print of bar. Third, you are saying print x. Okay, value of x will be what? The last part of the block expression, that is 10. So when you say print x, you're going to get 10. So the output is going to be foo bar and then 10. Okay, now this is not what I want to do. I was showing this as an example. This is not what I really want to do. I want to show you something else. So I'm going to rewrite this program in a slightly different way. Okay, so I'm again going to say paste. And instead of typing x, I'm going to say lazy val x equal to, I'm going to say print line foo. So same code I'm going to write, almost same you can say. Yeah. So if you compare this code, what I wrote just now, with the previous code, there is only one difference. The difference is previously I had this x, right? I had this x. Now I just have this lazy val x, right? I have something called lazy val x. Yeah, so if you look at here, the only difference here is between these two lines of code. Here I was declaring the variable x and it was just an x. Here it is a lazy x. So this is what you call lazy evaluation. If I run the code, you will see that the output is different because previously you were getting foo bar 10. This was my first code. Now you are getting bar foo 10. So what happened here? So Scala supports something called lazy evaluation, and that is what I just showed you. You can declare any variable as lazy. So in this particular example, I just added the lazy keyword before the variable x, which means the initialization of this variable will be deferred. What is the word I'm using? Deferred. So this variable initialization will be delayed or deferred, I can say. So when you say lazy x, you're basically telling Scala that, hey, Scala, this variable is lazy. Please don't run this line. It is as good as you are not running this line. So when you do something like this, Scala understands that, okay, X is lazy. I'm not going to run this line. So the first line it is going to execute is this print line bar. And that's what you get here. You get a bar. Then the moment you call this variable in the program, it will initialize it. So then you're calling print x. Now Scala will initialize this line. You will get a foo and then 10. So whenever you declare a variable as a lazy, the initialization of that variable can be deferred. Now, where will you use this? This concept is built into Spark RDDs. So when we speak more about Spark RDDs, Resilient Distributed Data Sets in Spark, I will come back to this lazy evaluation. As of now, just be aware of what is lazy evaluation. Probably you're thinking, why should I do this, right? I will tell you why you have to do this, but you can make anything lazy. So here this X is actually lazy, which basically means this line is not getting executed. And then you have the print statement. Then whenever you call this variable in the program, it just gets started. So, I mean, it just gets initialized and then this variable is alive now, right? Okay, so that's what you call lazy evaluation. Now, so far we were working on this Scala ID, I mean, interactive shell, right? But in the real world, you don't work with the Scala interactive shell a lot. So if you are a Scala programmer and if you want to write a program, the shell doesn't support debugging the program, also correcting the program, giving you suggestions. These are all not there in the Scala shell. So typically, what we do is we go for something called an IDE. Okay, so coming back to using an IDE, right? So like I said, one of the ways in which you can write a Scala program, let's say you are in production, is using the help of something called an IDE or an integrated development environment. Uh, some of you might have heard about Eclipse. If you are a Java programmer, then you might have worked on something called Eclipse. Eclipse is one of the most, how do I say, used IDE, especially probably for Java programs. Now, when it comes to Scala, there are many IDEs. There is an IDE called IntelliJ, which is popular. There is also Eclipse. So let us first try Eclipse. We will also go to IntelliJ later. Now, one thing you need to understand is that if you are going to use something like Eclipse or any IDE, right, my suggestion will be install it on your laptop, not on the VM. See, the VM, anybody will do like that, right? So if you are, even if you are working in the production, right, and if you get a chance to install an IDE, the IDE will be installed in your developer machine, not on a VM. And in production, you don't have a VM also, right? So what I'm going to do, I will show you how to install this Eclipse IDE for Scala on your laptop. So this can be installed if you have a Windows or a MacBook or anything. All you need to do is just go to Google and search for Scala IDE. So just go to Google and search for Scala IDE, and the first link that comes up is Scala IDE for Eclipse. So you click on the link and directly you can see an option called download the IDE. Now the beauty of this Eclipse IDE for Scala is that once you download this IDE, you don't have to install it. It will come in a zip file. All you need to do is extract the zip file and it will work. So there is no need to install it. I think that's great. At least on Windows, there is no need. I think in MacBook also it is same. You're basically getting a zip file. So I'm using a slightly older version. Like you can see the current version is 4.7.0. I may be using a slightly older version. That's okay. So I have already downloaded this thing. And to see this, I need to check where I have downloaded it. Yeah. So I just extracted the contents to a folder called Eclipse. So here you can see there is an Eclipse folder and there is a file. So once you extract this zip file, you will be extracting the contents to a folder, right? And then you can just double click and it will start. Now, if you already have Eclipse installed for Java, you can go to this marketplace, search for Scala, install it as a plugin. That is also going to work. I mean, for freshers who are not using Eclipse at all, this is what I recommend, right? But let us assume you're already using Eclipse and maybe you are using Java. What you can do is just go to the marketplace. There will be a Scala plugin and you can just, add that Scala plugin. It should work, right? So I'm just starting my Eclipse. This is like Eclipse Neon. I think it is slightly older, but it will do the job. See, normally when you write any program, the program is going to have two components. There is something called a driver and there is something called business logic. I'm talking about a normal program. We are not talking about big data or anything. I mean, any program you write, typically we say that there is something called driver and business logic. Business logic will be the actual business logic you are writing. Maybe you want to find out the top 10 profitable products sold by your company. So you may be writing some program. So this is your actual program, the program that you're writing to find out whatever you want, right? However, in order to run this program, there is a component needed called driver. The driver is responsible for getting resources to run the program, initializing the objects, right? And all this. And typically within the driver, we declare something called a static class. Right. If you again are taking the example of Java and all, when you start writing a Java program, we will say public static void main, then arguments. What is that? So you're declaring a static class in Java, which means that is the after that you have the main method, that's the entry point, right? So a static class is needed. There can be only one instance of it. It's immutable, like most of you said, right? A static class is needed so that you instantiate the driver part of the program, which in turn will get resources called the JVM and then make your code work. And typically in any program, you start by declaring a static class. After that, you will also have something called your main method. When it comes to Scala, Scala doesn't have something called a static class. Instead of a static class, Scala uses something called singleton object. So a singleton object is nothing but a static class. It is probably just another name, but when you start writing your code in Scala, you will never find something called static class. You will find something called singleton object, whatever it is, right? Singleton object. So I will show you. So let us try to do one thing. Let's try to create a simple control structure. So when we learn new programming languages, we also talk about control structures like your for loop or if else loop. These are all called control structures. So what I'm going to do, I'm going to go to my Eclipse. So I just started Eclipse. And the first thing you normally do when you start something like Eclipse is that you go to File and you will say New, and then you will say Scala Project. So first thing that you do is you go to File, New, Scala Project. Okay. So you select this, you select your Scala project. Okay. And you're supposed to give a name for your project. So I'm just going to call it as, I don't know.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So first thing that you need to do is you're supposed to create a project within your Eclipse. And within this project, you see a source folder. You can definitely have a package and all inside this, but I'm not getting into those details right now. What I'm going to do is I'm going to right click this source thing. And there is an option called new. And I can say here, Scala object. So the first thing that I'm going to do is I'm going to create something called a Scala object. What is this Scala object? This is your singleton object. or the static class. So I'm going to give a name. Let's call it as if else. Any name will do. I'm just going to call it as if underscore else. So you can see in my code, it is object if underscore else. This is equal to typing static class, whatever class name that you want. Okay. And below this, so once you declare your singleton object, the first thing that you do is you define your main method. So you can say def, you can say main, and the main method can take arguments as an array of string values by default. You can change it. Okay, the default is your program will be able to take arguments as an array of string values. And now you will be able to type your code. So this is like the bare minimum boilerplate code you need to write a Scala program. You need a singleton object, or call it as a static class if you wish. You need a main method, right? Main method will mark the entry of your program execution. These two are actually your driver. These two are actually your driver. They are not part of your business logic, but they are required to run the program. For example, if you want to pass some runtime arguments, you use this argument option, right? Same like that. Now let's try to create a simple if-else loop. I don't know what if-else loop I will create. So let's say there is a variable called fruit and the value is apple. If I say, I'll say if fruit is apple, println red, else println no color. I don't know what this is, but this is my loop. So probably this is not the best program that somebody can write, but I think you got the idea. Simple control structure or if else loop. So I have a variable called fruit. The value is apple. I'm saying that if the value is apple, just print red. Otherwise, print no color. Okay. And how do you run this? You can save it. Just right click, say run as Scala application, and you get red. No surprises there. You are going to get red. So Scala supports a regular if-else loop. And there is no magic in this. If-else loops are same across almost all the programming languages. You can even go to a else if condition. So this is like you're validating only one condition. I had another example. Let me check. Yeah, this one. So here you can see this program. Yeah. So this is a program to calculate the grade of a student based on the mark. You can see the student has got just 10 marks. So the variable x is the mark. And then you're saying that if the mark is more than 80, then print grade A. Else if the mark is between 65 and 80, grade B, 50 and 65, grade C, 35 and 50, grade D, finally fail. So if you have a series of statements to evaluate, you can use a combination of else if statements, right? And if I try to run this, what will happen? You see the student is failed because he got only 10 marks, right? So all these type of else if conditions are supported in Scala. Yeah, so this is how you write a simple Scala program. Let's try for a while loop. I just wanted to show you a while loop and a for loop before we wind up. So how do you write a while loop? I'm just going to create one more program. So you say new Scala project, call it as my while loop. And I'll copy this main method probably. There is a shortcut I can use, but I like it this way. So you can say var I equal to 10. And how do you write a while loop? You write a while condition. The condition is, let's say I greater than 0. You want to print something. Hello plus I equal to I minus 1. So what is a while loop? It basically checks for a condition and then execute the statement. You can see I have a variable I, the value is 10. And then I say, as I is more than 0, just print hello and the value of I. So this is basically string concatenation. So when you say hello plus I, this is actually a string. It'll add the value of I here. Then in each iteration, you are subtracting 1 from I. So eventually it will reach 0 and the condition will be broken. Simple while loop, right? And if I try to save it and then run it, you can see that I'm getting the hello 1098 up to 1. So while loops are also very common, and in Scala also there is no speciality the way the while loop execute. Let's try a for loop as well. I will give you more examples, don't worry. If you're thinking, hey, how do I learn a couple of more while loops, I'll give you examples, don't worry. But let me do one for loop as well. I'll copy this. And for the for loop, the syntax is slightly different. See, for loops are normally used to iterate through something and produce the output. So normally in other programming languages, you will say I equal to 0, I plus plus, this kind of a syntax. In Scala, it is very simple. You can say for I in the range of 1 to 10, you can just say print I. So this is how easy it is to write a for loop in Scala. The way I wrote it is, I said for, this is I in the range of 1 to 10. This is like I plus plus, I is iterating from 1 to 10. But you may be wondering, what do you mean by 1 to 10? Are you writing something like in English? 1 to 10 seems to be something different, right? See, 1 to 10 is a Scala collection called range. If I go to the Scala shell, if I just type 1 to 10, it will produce numbers from 1 to 10. It is a Scala collection called range. So you can see range of numbers 1 to 10. You can say 1 to anything or anything to anything basically. It will generate a numbers like an array, you can say. Range is another collection. You can also say 1 to 50 by 2. It's very interesting to work with Scala. So when you say 1 to 50 by 2, what it means? The numbers are going to be from 1 to 50. The step function is 2. It will start with 1, keep on adding 2, 1, 3, 5, 7, 9, blah, blah, blah. So again, this is again a range. So I'm just iterating through this range and printing the numbers. That's what you're using the for loop. So when you say 1 to 10, I can take values in this range and you can say print I. And if I try to run this, you can see you're printing numbers 1 to 10, right? So now coming to learning Scala. So I want to share some more information before we wind up. Of course, important information. So first things first, where can you find all the material? Now I'm talking about Spark and Scala in general as a course.
So coming to the first question on the top Hadoop interview question set, it is what are the differences between Hadoop and Spark? This is a very commonly asked question and it has a very simple answer, to be honest. We'll be comparing three simple points here. One is how storage is handled in Hadoop and Spark, the other one is the processing speed, and the third one is the availability of libraries. So in terms of dedicated storage, Hadoop has its own file system, right? It has its native file system called as the Hadoop file system, while Spark lacks a native file system. Then you're talking about processing speed. Hadoop has an average processing speed when you compare to large amounts of data, because here Spark is really very good at handling large amounts of data without having to do much when you compare it to Hadoop. Coming to the next point, which is libraries, right? So Hadoop has the connection with multiple tools, multiple libraries, and Hadoop is pretty much a big tool. But then when you think about the native availability, where a lot of people depend on it, so Spark provides the Spark core, you have the Spark SQL, Spark streaming, Spark graphics, Spark ML lib. So you have all of these libraries that come attached with Spark. While you will have to learn and integrate these new things in case if you want to use all of these with Hadoop as well. So that extra learning curve in terms of Hadoop is required. Coming to question number 2, it states what are the real-time industry applications of Hadoop? Hadoop, as you might know, it is already called as Apache Hadoop. It's one of the world's most famous open source program, especially for the world of distributed computing, where we handle large amounts of data day in and day out. The world generates 2.5 quintillion bytes of data a day, so we needed a solution to handle all of that, and Hadoop does just that. So when you think about the practical applications of Hadoop, all the way from the small scale industries to handling a little bit of the big boys as well. So think about Google, think about Yahoo, think about Facebook. So all of these guys also have a solution for their big data, because they are generating a lot of data, right? So everything from managing traffic on the street, handling streaming processing, working on content management, how to archive emails, how to save them, working on fraud detection, which is very important in today's world, fraud prevention, targeted advertising, and guys, you can go on and talk about the applications of Hadoop for a long time, and then make sure to keep your answer concise. Do talk about 2 or 3 points, or if you do know some of the application, then make sure to note at least 5 of it. So with this, we can come to the third question that states, how is Hadoop different from other parallel computing systems? Well, this could very well be the first question through which your interview starts. So Hadoop is actually a distributed file system that lets us, handle a large amount of data, to store it, to work with it on, either local machines, offshore servers, or even on clouds as well. So when you think about it, if your data is stored in multiple places rather than one place, it
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job. Now let's continue with the session.
creates redundancy, yes, but here we have the good amount of redundancy, because if your data crashes, if you tend to lose your data, because if one of the nodes stopped working, then your data is still there. So in a distributed manner, you can store data on multiple places. You can use the processing power of multiple machines to actually go on and work with your data. So this does not happen in a relational database, because when you think about it, right? So if you have a relational database, you have to query the database, you have to, pick up all the tables, records, columns, and it'll be a manual task, and you really cannot make use of, multiple machines to do this effectively. It is a good enough method, of course, but at the end of the day, it is not as fast as what Hadoop can do. And of course, Hadoop also provides a scheme where you can build your own column databases, and just for this, we have the Hadoop HBase. HBase is very similar to SQL, and here we actually go on to run queries on the rows, on the columns, wherever it's required. And basically this is Hadoop's approach to making sure your data storage and access protocols are done easier. And this is how Hadoop is different from the other parallel computing systems out there. Coming to question number 4. Question number 4 is a very important one. It states, what are all the modes that Hadoop can be run in? Well, it's a pretty simple question with a very straightforward answer. Hadoop can be run in three modes. One is the standalone mode, the second one is the pseudo-distributed mode, or what we call as the single node cluster, and then we have the fully distributed mode, which is also called as the multi-node cluster. Coming to standalone mode is actually the default mode of Hadoop where it uses the local file system where you're working on for all the input and the output operations. So this is not used popularly in the case of a production environment, but mostly when you're testing or when you're debugging, right? So standalone mode is very important. One highlight you have to talk about when you talk about standalone mode is that it does not support the usage of a Hadoop file system because it's using the local file system. So make sure to mention that. And then when you're thinking about the pseudo distributed mode, right? So what happens in pseudo distributed mode is that you will have to provide three files for configuration. There's the core site.xml, you have the HDFS site.xml, and the MapReduce site.xml, right? So for MapReduce, for core, and for working of HDFS, you have to provide a configuration on which this mode works on. So if you're running on one node, it means that So if you're running pseudo distributed mode on one single machine, it means that that machine itself is the master and that machine itself is the slave node as well. So this is one thing you have to note. And then coming to the fully distributed mode. Fully distributed mode is of course the production phase of Hadoop where, this is where Hadoop is known to be very powerful, and this is where it beats all the other tools out there. Because here data is used and data is distributed across multiple clusters, multiple nodes. And once you have more than 2 or 3 nodes, we call it a Hadoop cluster. And using clusters, you can have a separate node, which is a master node. You can assign all the other slave nodes as well, and then, work with it in a chain of command in a very structured way. So this is the advantage of the fully distributed mode. Now, moving on to question number 5, it states what are the operating systems on which Hadoop works? Hadoop supports a lot of operating systems. In fact, it's an open source tool, and the support for multiple operating systems were being added one after the other. It's mostly preferred to use Hadoop with Windows or Linux because most of us almost use Windows or Linux, right? But then for the people who are using OS X, or the people who are using Apple's operating system, or let's say even the BSD, which is also called as the Berkeley Software Design OS, the support for Hadoop is there. So there is a lot of flexibility in terms of what operating system can be used to run Hadoop effectively. So make sure to mention 3 or 4 of these when asked. Coming to question number 6, it states what is distributed cache? What are its benefits? Distributed cache, right, in Hadoop is actually a service. So what it does, as the name suggests, it caches files whenever we require it. So let's say there is a file which is cached for a particular job. What Hadoop does is that it'll make it available to the data node, both in the system memory and both in the actual system where it's been accessed from, and of course in the memory as well. Because at the end of the day, this is where your map operations are happening. This is where your reduction tasks are happening, right? So if you have a cached version there, it's almost like copying it and keeping a temporary sample there where you can use it. You can populate any collection that you like, right? So think about arrays, think about hash maps, and all of that in your code, and later use it quickly without having to wait for the pull operation from another node. So what are the benefits of doing this? One benefit is that it provides a very simple path of you accessing the data, copying the text file, data file, or whatever it is. And it also ensures that there is developer efficiency in terms of there is a decrease in terms of access time. And of course, what distributed cache does is that it tracks the modification timestamp for each and every cache file, which means that the user or the machine or the language itself can have the capability to check if the file has been modified or not. So the general practice is that the file will not be modified until the job is complete, because once the file is changed, it doesn't become a cache file, it becomes a standalone file at the end of the day, because caching is a copy of something. Once you've copied onto that, it has to remain the same until you work with it, right? So these are some of the benefits and the working of the distributed cache in Hadoop. Coming to question number 7, this is a big one. It says explain the differences between NameNode, checkpoint NameNode, and backup node. Well, let us check out NameNode first. I think you would already know this. NameNode is one of the most important components, the core components of the Hadoop file system, which is used to handle metadata. Metadata is what we talk about when we have to describe the events of files. See, files will have certain information, but then to describe what information these files has, that is exactly what metadata is. So what we're doing with NameNode is that we're trying to map all of these files using metadata to check where the block locations are, what blocks are located on which point in the data node, right? So what we're trying to do here is we're trying to understand and map a way on which, think about a tree structure, right? Think about a directory structure where we have all the files arranged one after the other in the Hadoop cluster. That's the exact purpose of the name node. So to do that, we'll actually require two files. One, we have the fs image file. It's used to check the latest checkpoint of the namespace, and of course we have the edits file. Edits file will give you a log of changes that has been made after the checkpoint has been achieved for every single namespace entry, because at the end of the day, whatever changes you do, minor or major, it is very, very important that you keep it in check. This is NameNode. Now let's talk about checkpoint NameNode. Checkpoint NameNode is basically very similar to what NameNode does, and here what we're trying to do is we're trying to create checkpoints for NameNodes at regular intervals rather than in randomness. And here, by doing this, what we have to do is we have to download the FS image, we have to edit all the files, and later after editing, what we'll do is we'll merge these files into the local directory. And after this, we'll have a new image, and the new image, after being merged, is basically uploaded to the NameNode. So after these checkpoints, after analyzing them, after editing the files, after merging them, is when we create it and upload it to the name node. So this is the checkpoint name node. And then now when we talk about backup node, right? So backup node basically provides the functionalities very similar to checkpoint, but at the end of the day here, what we're trying to do is we're trying to achieve a synchronization with the particular name node. It is very vital, as I've been saying, that your file should be up to date. Your file should have an in-memory copy. It should not differentiate from each other when it's being cached or when it's a copy or anything like that. So backup node needs to save the current state in the memory to an image file, to create a latest checkpoint file as well. So this is what a backup node is. So this is the basic difference that lies in between name node, the checkpoint name node, and the backup node. So when you ask this, make sure to put the answer out in a clear and a concise way. And whenever you're answering questions regarding nodes, name nodes, and especially data nodes, things get a little messy, right? Make sure you put the answer out in a very structured way. Now coming to question number 8, it states, what are the most common input formats in Hadoop? Well, there are 3 common input formats in Hadoop that you should know about. One is the text input, we have the key value input, and of course we have the sequence file input. So the default mode, right? So you can have another question here that says, what is the default input format in Hadoop? It's actually the text input format that is the default format. And then we have the key value input. So the key value input format is used for plain text files where the files are actually broken down into lines and later used. But in the case of sequence file input, here we make use of this particular format to read all the files in a particular sequence as per requirement. So these are the 3 common input formats in Hadoop, and you have to stay. Order really doesn't matter. The default one is the text input, and talk about key value inputs, and of course how you'll be reading files in a sequence using the sequence file input as well. So with this, we can come to question number 9 that states, define data node. How does name node tackle the data node failures? Well, the name node we've already seen, right? But what is data node? Data node is where the data actually gets stored in the Hadoop file system. The data actually resides here in a way where it has the capability to communicate with the name node. It does this by sending a message called as the heartbeat message. The heartbeat message literally, is to show that it is alive and that it is working. So what happens is that we have 10-minute intervals, and in these 10 minutes, if the name node does not receive a message from the data node, right? So the name node is waiting for the data node to send a message. In 10 minutes, if it doesn't send a message, what the name node thinks is that the data node is either dead or it's out of place or it's not working fine. And the name node actually starts replicating the blocks which are hosted on that particular data node which wasn't responding. And it takes that and pushes it onto another data node to make sure that the data replication and data redundancy part of it is maintained well as well. So this is how actually name node tackles data node failures. But then to denote the failure, we have some something called as a block report. A block report is actually consisting of all of the lists of blocks that are present on a data node. So whenever a system starts to replicate it, right, you will get to know what data was stored in the data node and what data needs to be moved. So this replication of data to moving from one data node directly into the other by keeping a track under the name node by making use of a heartbeat message, this is something which is very important, and this is how communication happens between the data node and the name node. With this, we can come to question number 10 that states, what are the core methods of a reducer? Well, there are three core methods whenever you're talking about a reducer. One is the setup, we have the setup method, we have the reduce method, and of course we have the cleanup method. Talking about setup method is basically used to configure all the parameters that we have to feed into the network. See, you have the input data size, you have the distributed cache, and all of these parameters, right? So to do this, you can use public void setup and context as the parameters to send it in. But then when you talk about reduce is the most important part of the reducer, right? As the name says, it is the heart of the reducer. So every time there is a new key that's generated, the reducer is called once with that particular task. The key is given to it, the value and the context is added where this method can run the reduction operation and be done with it as well. And then when you're talking about the cleanup method, as the name suggests, again, is pretty simple. It is used to clean all the temporary files once a task is ended. So you will have certain files which are required to perform the reduction operations, but then as soon as the operation is done, you will not require them anymore. So in that particular case, it is vital that you keep cleaning the memory then and there to keep it effective, right? Cleanup method does just that. Now, do take a look at the syntax. And if you have a pen and paper in front of you or your computer in front of you, do make sure to put that down to showcase to the interviewer that you actually have worked on this or that you know it in detail. Now, coming to question number 11, it states, what is a sequence file in Hadoop? A sequence file is basically a flat file, in Hadoop. So whenever we're talking about flat files, especially here in the case of sequence file, it contains binary key value pairs. And we have the map inputs, we have the map outputs, where the map output actually gets stored, as a sequence file internally here itself. So if you're thinking about what classes does this sequence file provide, it provides you the sorter class, reader class, writer class, and each of these file formats, right? So there's actually three formats that you need to know about. One is the uncompressed key value records, then we have the record compressed key value records where only the values get compressed, and then you have the block compressed key value records where it's not just values here, but both the key and the value gets collected in separate blocks and compressed, and the size of these blocks, right, this is assignable to you. So having it uncompressed, compressing only the values, or compressing both key and value in the case of sequence files are very important. So these three classes in the binary key value pair see a lot of usage in the daily world, so it is very vital that you answer this like that. Next, coming to the 12th question, it states, what is the role of a job tracker in Hadoop? Job tracker, as the name suggests, again, its main function here in Hadoop is to basically handle resource management. So we have something called as task trackers, where the job tracker actually handles and manages the task trackers. So it will be checking for resource availability, it will be checking for task lifecycle management, it will be understanding about what's going on in terms of fault tolerance, in terms of the task's progress, and much more. So there's a lot of things that the job tracker does in Hadoop, right? So it is basically a process that runs on a separate node and not on a data node. And this is a very important point that you're supposed to mention. And then of course the job tracker communicates with the name node to identify the data location. And if it finds the data, then it will execute the task. If it cannot find the data, then of course it goes into redundancy. But then one important thing is that it will monitor all the individual task trackers and submit your overall job back to the client. It's like, hey, it takes in all the data, it works with it, executes all the tasks, and sends it back in a structured way. So what it does is that it also tracks the execution of the MapReduce workloads, the operation, and the tasks local to that particular slave node, and creates a file where you can track that as well. So in terms of what job tracker does, is it does a lot of things and it does them very effectively. That's the important part here. Coming to question number 13, it states, what is the use of record reader in Hadoop? So when you think about it, we have input split, right? So input split basically defines a slice of data, but then what it does not do is that it does not describe how to access this slice of data, right? So what the record reader does is here is where this class comes into the picture. Here we take the byte oriented data from its source, we directly convert it into the record oriented pairs, right? So you already know it, it's the key value pair. And after we convert the byte oriented data into its key value oriented data, then we give it to the mapper, where the mapper can handle the task, it can read it and work with it. So in the background, what happens is that the input format, right, it actually defines the Hadoop record reader instance where it keeps adding up onto that list about what's going on, what files got converted, and if the mapper is ready to pick it up or not. So in that particular case, even record reader adds a lot of value to Hadoop. Now, coming on to the 14th question, it says, what is speculative execution in Hadoop? Well, one important limitation we have to talk about every time we discuss about Hadoop is that whenever you're distributing a lot of tasks on multiple nodes, right? Sometimes it is not always that you have nodes which are really fast. So a few slow nodes will actually limit the execution, it will limit the efficiency of the entire program, right? So when you think about it, there might be multiple reasons of why a task is slow. In a small scenario, this is a very simple thing to find, and you can work with it, hunt for the node which is slow and replace it. But when you're thinking about a large scale solution, it is not easy to detect which node is slow. So what we try to do here is, instead of fixing all of these slow running tasks, Hadoop will actually try to detect what tasks run slower than an expected time. It will have an expected time through which the task has to finish. It will see what task is taking more time than the expected time, and it launches other tasks as a backup in case if this is taking more time. So this backup mechanism that exists in Hadoop, right, this is exactly what we call as speculative execution. This is a very important thing to maintain high efficiency throughout the execution of our task, getting closer to our big data handling goals, or whatever it is. Speculative execution is definitely one of the most important things that's adding a lot of value in the community of distributed computing. So when you ask this question, make sure to give it out in a concise way. Coming to the 15th question, it says, what happens if you try to run a Hadoop job with an output directory that is already present? Well, if your directory is already present, what Hadoop does is a very simple thing. It will give you an exception saying it already exists, because you really cannot create a directory when already one is created, right? So a Hadoop job requires either a creation of brand new directory or working with it as well. So in that particular case, to run a MapReduce job, you need to make sure that the Hadoop directory will not exist, because if it does, it will not work. It will give you an exception. So in case if it exists, but then you want to delete it, run your Hadoop job fresh, make sure to use the file structure command Hadoop FS RMR, which will basically remove it, put the path to your output, and as soon as you're done with it, you will delete a directory, or you can make use of a Java API as well. Get local conf.delete will actually make sure that your directory gets deleted, and later as soon as you run the job again, this time you will not have an exception, but this time the job will run as expected. Now, coming to question number 16, it states, how can you debug Hadoop code? See, to debug Hadoop code, one very important step you always have to check is to check the list of the MapReduce jobs that are currently running. And once you see the logs, once you see all the jobs that are being run, there you have to make sure that there are no orphan jobs which are running. If they're running, make sure find the location of the RM logs, make sure to check it out, and especially when you run the command that's given on your screen, right, with the resource manager. So what it does, it will look for the log directory. It is very important that there should be no orphan jobs running. So based on what we find on the RM logs, right, we have to check if the worker node was involved in the execution of task or not. To do that, we have to log into that particular node, right? Because without logging into that node, we cannot see if a worker node was involved in the execution of a task. To do that, you can use psef grep inode manager, and using this, you can log into the node to see if it is the worker node that was involved. So later, after doing this, what you'll actually do is examine the node manager log, where the majority of the user level logs come from here, for every single MapReduce job out there. So this is a structured way, an ordered way of how you can simplify and debug Hadoop code. If you have a Hadoop structure running on your machine, if you have a standalone structure, or let's say if you're connected to a multi-node structure as well, open up your laptops to show all the working of this practically to the interviewer. That will add a lot of value to your candidature at that particular company. Not just this question, among all the questions we discussed, wherever it is possible, do show it practically. So with that, we can come to question number 17 that states how to configure replication factor in HDFS. See, to configure HDFS, you remember we spoke about 3 files, and one of those files are HDFS site.xml, right? So this is a very important file which we use to configure the file system. So basically, to change and configure the replication factor, we have the dfs.replication property that's present in this particular file. So by changing that, we can modify it. But then if you change it on a file basis, right, per file basis, where you're checking out each and every individual file and working with it, for that you have a Hadoop shell command, Hadoop setrep, where you can put in the file name and work with it. But then if you have to change the replication factor of all the files at a time, but then not like each one of them individually, then of course we have another Hadoop command for that as well. There are certain subtle differences. You have the capital R in the second one that denotes that you'll be adjusting the replication factor for all the files in the directory, and of course for the first one it's only the individual file. So here it's very important that you talk about replication factors on individual files, and of course replication factor changing on all the files that are present in a single directory as well. So make sure to mention this. Moving on to the 18th question, it states how to compress a mapper output, not touching the reducer output. To basically compress a mapper output which is not in touch in the reduction process, what we try to do is we set 2 things. To achieve the compression, we have conf.set, where we're trying to set the output compressed to be true, and what we're trying to do is we're trying to keep the file output format to be false. So after setting these 2 parameters, right, this is how compression can be achieved. It's a simple question, it's a very straightforward answer, and again, if you have a pen and paper, rather than spelling it out, make sure to write it down and show that you'll be setting the bits to be true in the case of the map output, but in case of the file output format, we'll be putting it to false. Now, coming to the 19th question, it states what is the difference between map side join and reduce side join? Well, map side join happens at the map side, right, as the name suggests. So whenever your data reaches the map, this is where the join operation takes place. So then, I'm sure you're already aware of this, but then to do this, you will really have to have a strict structure, right? So especially when you're defining your map side joins, you really need that. But then when we talk about the reduce side joins, it's also called as the repartition joins. So here, it's a little simpler when you compare it to map side joins, because here all we're trying to do is, map the files rather than the input data sets. The input data sets need not be structured out here. So when it comes to that, but then when you talk about efficiency, right, map side joins are more efficient here, because in the case of reduce side joins, it'll have to go through a lot of sorting phases. It'll have to go through a lot of shuffle phases where, you'll be coming in touch with a lot of network heads, and it might take a lot of time and, work power to actually get the job done in the case of the reduce side joins as well. So hence, this is one of the reasons why people prefer the map side join. But then to do that, you need the structure, and this is a very important point that you should talk about. Now with this, let's come to the 20th question that states how can you transfer data from Hive to HDFS? Well, it's a very simple question with a very simple answer. You just have one query that you have to write where you can pick up the data from your Hive and push it onto your HDFS. It's a Hive command as insert override directory, where you have the / select star from emp, where emp is the directory, where emp is actually the record there, and after you execute this query, you can import whatever files you want from Hive to HDFS. So the output that we get here is actually stored in part files in the specified Hadoop file system structure as well. So that's one very important thing too. So if you're expecting a very complex process of transferring files from Hive to HDFS, well, sorry to disappoint you, because it is pretty simple, as you can see on the screen. Coming to question number 1, it states what companies make use of Hadoop? Well, there is a lot of companies that make use of Hadoop. In fact, there's thousands of companies right now making use of Hadoop, even when you're watching this particular video. The big boys are Yahoo and Facebook, because Facebook developed Hive to perform analytics, and we have Yahoo is one of the biggest contributors in the entire creation of Hadoop. We have Amazon, we have Netflix, we have Adobe, we have eBay, we have Spotify, we have Twitter, we have a lot of other companies where each of these products have one particular or multiple use for Hadoop. So it can be a very small scale solution that they're trying to implement, or in fact it can be a very huge thing that they're trying to add on to their company by making use of Hadoop as well. So in that particular case, right, Hadoop is very, very well regarded and used a lot in many companies out there today. So question number 22 states, how do you stay up to date with the new and upcoming concepts in big data? So the 22nd question states, how do you stay up to date with the new and the upcoming concepts in big data? You have to know one thing is that this is a very commonly asked question here, because with this, right, the interviewer wants to understand what your interest is, where your interest lies, and what are your abilities of learning something new and how can you learn it well. So talk about how you've learned things in the past, talk about how you're planning to use these past learnings. Probably you could have taken an easier way to learn, a more structured way to learn, or there are many other concepts which keep coming out, right? So the tool of today will become obsolete tomorrow, and it is very vital that you know the latest versions of the software, you know what are the changes that happen. And it's not only that, it's about how you change yourself with these new changes, or how you plan to impart these new changes in a very simple way, in a fashionable way in your particular project of whatever you're handling. So the interviewer wants to understand this. He or she wants to understand your interest, your ability to actually find, and how you will learn new things, because in a production environment, when you're looking for a job, it becomes very vital that you have to pace yourself and learn new things rapidly. So make sure to keep this answer concise, but then put it out in a clear way. If you have a path, it can be very different from what I told you. You might go on the internet, check a couple of YouTube videos, pick up a certification program, or whatever it is. You really have to mention your way on how you plan to learn new things. As an added bonus, talk about how you've used these new things as well. Coming to the 23rd question, if you're a fresher, or if you're an intermediate user, or let's say if you're an advanced developer, there's a good chance this question is asked. It's a very frequent one. Hadoop is used in multiple different kinds of. So Hadoop is used in multiple industries, right? So you might be working at Facebook, which is a social media company. There's many other companies, right? There's Google, there's Yahoo, and there's Adobe, which do a lot of different things compared to social media. So based on the industry that you've worked in before, if you're a fresher, of course, you can say you're a fresher, and you'll move on to the next question. But then if you're an intermediate developer, who's looking forward for this interview, if you've had any experience in that industry, right? So make sure to elaborate about it. Talk about the industry experience that you have, because at the end of the day, you can talk about the tools you've used, you can talk about the techniques that you've used, and how you've made a change in the same industry before, and basically what you bring to the table as well. So it is very important, if you have the industry, do talk about it. But then if you do not have it, talk about how you plan to bring the learning from the industry that you belong to into this particular one. So you might be moving from social media to another industry, but then talk about how you plan to make that switch of what you'll carry along with you from that different industry, to see to it that if it works or not, or how better it can be implemented in this particular industry as well. So this is a very important question. And then the 24th question says, what is your plan after joining for the Hadoop developers role? Well, the first thing you have to talk about is when you ask for any plans in the future, right? So talk about how you're planning to understanding the complete data workflow setup in the company, because once you understand the workflow of the company, then you can have a plan of action. You can work on the plan of action, discuss it, implement it, and verify it to see if it's working or not. Don't just say that you're going to step into the company and start changing things around, because that definitely wouldn't work in a production environment. So you yourself have to get very familiar with what's going on, what's already existing, and then you can work on seeing what can be changed, what can be made better, or in fact, if you fit into the actual requirement that is already there, and you will not have to change anything. So in multiple cases like that, it is very vital that you state out a plan of action, right? You joining, you learning new things, you talking to the people who have done it, see what can be done better, verifying if it can actually be done better, and doing it better. So this is something that would add a lot of meaning to your particular interview as well. So with this, we can come to the last question, the 25th question, that says, have you earned any sort of certification to improve your learning and implementation process? Well, I'm sure if you're at this point of time, if you're at the 25th question, you will already know the value of what a certification program would bring to you, right? So you will have a lot of experts teaching you a lot of content over a couple of months. You'll be picking up industry level projects. You'll be working on real-time projects. You'll be given thorough training where basically you have learned all the concepts thoroughly. A good certification program will also give you industry level projects where you can actually implement your learning to see and verify if you have actually learned, because at the end of the day what you put on your resume is your projects, right? So if you put on a certification, well, it's well and good, but in an interview, as soon as they talk about the certification, the first thing the interviewer is going to ask is what did you learn and how have you solved problems using that? Because when you think about it, all the IT problems that exist out there today, right, are being solved and we have solutions for that. See, the entire process of big data handling itself is a problem, and handling that is the solution, right? So we had a lot of data that's being generated every day, and now we know how to handle it and work with it. In fact, that is one thing that you could state about what you learned in that particular program, but then make sure to elaborate about how you've learned it and how you've planned to use it in the near future, or how you already used it in the past to solve a real life problem. So all of these will give the interviewer an impression that you are very good at advancing your career, that you've put in your time, your money, your effort into working on Hadoop or working on big data. In fact, it also shows that you are an effective learner and that you have strong aspiration to pick up a certification program, to learn to it, to see through it thoroughly and become an expert at the end of it as well. So a certification program adds a lot of value to you as well as the interviewer, because all of that, the knowledge that you carry is very important for the company there as well. So in terms of job prospects, in terms of impressing the interviewer, in terms of working well at the job that you do, anything, right, a certification program definitely helps. So with this, we come to the end of the top Hadoop interview questions set. I take this opportunity to wish you guys all the very best for all the interviews out there. You can use this as a guide to see how you can approach each of these questions in an effective way, and how you can answer them in a clear and a concise way too. So with this, I wish you all the best, and I'll see you on the next one.
Now that we have come to the end of the session, please subscribe to our channel and hit the bell icon for more updates from Intellipaat. If you have any queries, you can comment down in the section below and we'll be happy to answer you. Thank you. Just a quick info guys, if you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job.